Hello everyone, welcome to today's extensive session on machine learning. ML is an exciting field that involves developing algorithms and statistical models enabling computers to learn from data and make predictions without being explicitly programmed. The future of machine learning looks promising, with businesses investing more in AI and its subfields. The global machine learning market is projected to grow at compound annual growth rate of 43.8% and reach $96.7 billion by 2025. Not only that, salaries for machine learning professionals, even if they are beginners, vary around $112,000 per year according to pay scale. In India, the average salary for a machine learning engineer varies around 9,80,000 rupees per year. So thinking about ML as a career prospect is quite a worthwhile. That being said, let me tell you guys what we are going to cover throughout this long session one by one. We'll start this session with basics of machine learning, what it is and how it's changing the world around us. We'll also look at various types of machine learning including supervised, unsupervised and reinforcement learning. Then we'll dive deep into regression using Python, where we will cover linear regression and logistic regression. We'll explore these concepts in detail, including how to implement them in code and the mathematical concepts behind them. Next, we'll discuss entropy, a measure of uncertainty in a system, and Smote, an oversampling technique used to address the class imbalance in datasets. We'll also discuss the disadvantages of decision trees and explore data preprocessing techniques. Then we'll look at the Naive Bayes Classifier, an algorithm used for classification tasks, and unsupervised learning techniques like k-means and hierarchical clustering. We'll also explore the Smote score, a metric used to evaluate the performance of clustering algorithms. Finally, we'll wrap up the video with some common machine learning interview questions and tips on how to ace them. But before we dive deep into this session on machine learning, I'd like to request you guys to enable both the subscribe button and bell icon so that you'll never miss any update coming from Intellipaat YouTube channel.
Machine learning was just considered to be just a niche subfield of computer science, but technology giants have been using it for years. Machine learning algorithms power Walmart product recommendations, search pricing at Uber, fraud detection at top financial institutions, content that Twitter, LinkedIn, Facebook, and Twitter display on social media feeds or Google Maps. Machine learning products are being used daily, perhaps without any realization. A report from TMR mentions that machine learning is expected to grow from $1.07 billion in 2016 to $19.9 billion by the end of 2025. Machine learning is a branch of artificial intelligence and computer science, which focuses on the use of data and algorithms to imitate the way the human learn and hence gradually improves the accuracy. How machine learning works? Step 1. A decision process. In general, machine learning algorithms are used to make a prediction or classification. Based on some input data, which can be labeled or unlabeled, your algorithm will produce an estimate about a pattern in the data. Step 2. An error function. An error function serves to evaluate the prediction of the model. If there are known examples, an error function can make a comparison to access the accuracy of the model. Step 3. A model optimization process. If the model can fit better to the data points in the training set, then weights are adjusted to reduce the disparity between the known examples and the model estimate. There are 3 methods of machine learning. First one is supervised learning. In this type of learning, algorithms build a mathematical model of a set of data that contains both the input and the desired outputs. The data is known as training data and consists of set of training examples. Each training example has one or more inputs and the desired output, also known as supervisory signal. Second method is called unsupervised learning. This method of learning algorithm take a set of data that contains only inputs and find structure in the data, like grouping or clustering of data points. The algorithms therefore learn from test data that has not been labeled, classified or categorized. Instead of responding to feedback, unsupervised learning algorithms identify commonalities in the data and react based on the presence or absence of such commonalities in each new piece of data. Third type of learning is called as semi-supervised learning. This falls between unsupervised learning and supervised learning. During training, it uses smaller labeled dataset to guide classifications and features extraction from a larger and unlabeled datasets. Machine learning is used in day-to-day life, like speech recognition, customer service, computer vision, automated stock trading, discovering data trends, and lot more. So guys, this is all about machine learning.
Up till now, like all the things that you have done, starting from the day one with Intellipaat, like Python, different things of thing in Pythons, like list, tuple, dictionary, many things you have already done with Python. Now, my question is, you have done Python programming, and understand that when I am explaining you, I'm making you ready for industry, which means we are going to see industry level questions, industry level interview questions also at the same time. And this is your first question. You have learned Python programming. Many things you have done in that, NumPy, Pandas, many things. Now you're starting with machine learning. Now my simple question is, what's the difference between programming and learning? What's the difference between programming and learning? Everyone pay 100% attention on screen. I would make your life much easy. You would never forget machine learning after this. Trust me when I say, and you would understand this after the example. So it's a story time, all of you. So pay attention. Now I have a simple task. Let's start a task, a very simple task. I have a very simple task. Task is, so my simple task is there. I want to sort a list. I have a list something like this, that is 2, 3, 7, 4. Now I would use first programming. What is programming? That is writing a set of rules is called as programming. Writing a set of rules. So writing a set of rules is called as Python programming, is basically called as programming. Now I would write some rules here to solve my task. What are my rules? My first rule is like take a list, then find the minimum element, then swap that element, okay, then run that in a loop, something like that. I have written some rules. Now any sorting algorithm you can think of. So with this, what I'm doing in my computer, I have input. What's my input? My input is just simple 2, 3, 7, 4. And what I give to my computer, I give a set of rules. This set of rules is also called as algorithm. I give a input, a set of algorithm to my computer. Computer gives me, like, apply that rules on a list, and computer give me an output. What is the output here? Output is a sorted list. That is 2, 3, 4, 7. That is a sorted list. Now see the difference. You would start jumping, dancing on your chair after you see such a easy difference in machine learning. Now in machine learning, what you do? You have a same computer, but in the same computer, you input, the input remains the same. That is your input. Input is 2, 3, 7, 4. But at the same time, you give the output also to your machine. You give output also to your machine. What's the output? That is 2, 3, 4, 7. Basically, you give this output also to your machine, and your machine would no matter do some magic inside this. Okay. And your computer needs to understand how to reach from this place to this place. That is what computer needs to understand. That is what computer needs to learn. That's a difference. Understand. This word is very important. Here we are giving input and output, and we are saying that, boss, I don't know whatever you do. I want that you learn this input and output, you learn this mapping. Whatever you want to do, I want this as an output. And your computer gives you an algorithm. Okay, or you can also call it as a program, algorithm or program. And now once your machine has learned this, let's say tomorrow Hitesh sir comes in and he gives a new list to your program would sort that automatically. That's the power of machine learning. You just make it learn one time and it can perform the task for you. Is that everyone 100% crystal clear what is the difference between programming versus learning? So what we have done, I would just summarize it. Machine learning is where your machine learns. Okay, where your machine learns. You do not write, you do not mention the steps it needs to perform. So in learning, what you do, you give that an input and you give an output to it. And your computer would learn on its own how to perform a task. It can be any task like sorting a list. It can be recognize a cat, and many examples can be there like this. So I would be showing you more machine learning examples, but this is a difference between programming versus learning. In programming, you mention how to do a task. In learning, you allow the computer to learn from input and output. So let's make it little complex now. Now this time, you are not doing just a sorting. We would take a complex problem. So basically, let's say Shivani says me that, okay, Akash, in programming also my problem is solved, and in machine learning also my problem is solved. So why to learn a new concept when we can do it from programming? Let's make it complex now. Now you have a cat. Basically, you need to write a Python program to recognize a cat. Okay, and you need to make your machine learn how to do a cat. Now, basically, writing a Python program for recognizing a cat is too difficult or not possible. Let's say even if you write some program like this, if eyes equals to 4, okay, if tail equals to 1, and if legs eyes equals to 2. If eyes equals to 2, your legs equals to 4, then print it as a cat. Now, even if you write something algorithm like this, your algorithm would be very difficult. It would not be able to recognize a difference between a cat versus a dog or different type of animals, because dog also has the same things. But at the same time, in machine learning, you would give an image of a cat and you give a label to it that this is your input, and you give a label to it, and your label is cat. You give two things to your computer, and computer would automatically understand how a cat look like. You don't need to tell what are eyes, what are tails, what are legs, how many eyes are there, how many legs are there. You don't need to tell that. Your computer would give you a cat recognition algorithm. That's the power of machine learning, where your machine learns how to do the task. Okay, so this is all about the stuff, how and where machine learning is different from your normal programming. Let's see some of the examples of machine learning. And I'm going to give you a very big definition of machine learning. Machine learning is same as, I'm giving you a very big definition, is same as human learning. Now tell me one thing, guys. In your childhood days, when you used to understand how a cat look like, you remember that you used to have a book, and in that book there used to be a cat here and a big label like CAT, cat, written like this in a book. A cat was drawn here, something like that. You remember? Now, as a human, you recognized, no one tell you that, okay, look at the legs, look at the tail, count the legs, count the eyes. No one tell you that, okay, this is the height, count the height of a cat and then say it is a cat. Your brain has automatically understood how many legs are there. Your brain has understood how a cat look likes. That is learning. There's a difference between you when you program someone or you make them learn someone, and that is machine learning. Now, there are millions of examples around you that are machine learning. For example, the first thing here is product recommendation system. Now in Amazon, you might have seen a lot of product recommendation system. Now we are going to see that all the things in live. Nothing is like just theoretical. Whenever you see any product, you would see that you would also get, along with the product, you would get some recommendations there. Like, see, product related to this item. How no one has set and make that relations, like this fridge is color to this fridge. No one has done that. Machine has learned it, which things are more similar. That is called as recommendations. So you get the recommendations here because machine has learned that. That is your first example, product recommendation system. Movie recommendation systems. Again, you have also seen that YouTube recommendation system, movie recommendation systems on Netflix, on YouTube, based on the video that you watch. Okay, you would get recommendations like that. Google Maps, again, a very big example of machine learning. Now, this is all about your machine learning, the examples that are near you. Now, there are many more examples. Some demo I'm going to show you that would make your life very interesting. See, this is one of the example of auto draw. Now, whenever I draw something here, see that. Now, see, everything is blank right now. Now, the moment I start drawing here, okay, let's say I draw something here, you would get some suggestions here. Like, see, I was trying to draw a cat and I got a cat suggestion. This suggestions, again, machine has learned that, like based on the drawing stuff, a model is trained that can give you the suggestions. Car. Okay, let's try a car. Yes, I got the very good examples of car. Even if I have not drawn that. Yes, bird. I don't know if I can draw a bird. I'm drawing a normal birds, but yes, see that also it has recognized the birds. Yes, TV. So yes, that's a very interesting. You would find something similar to it. Satellite, I can't draw. I don't know if I can draw a satellite. It has given a toffee or something. Yes, satellite also came. Perfect. Okay, so you can try that later on. So this is the perfect example of all machine learnings. Same way you have this also, one more example of machine learning. Now, can a neural network learn to recognize what you doodle? Doodle means again the drawing. Let's try to see that. Now see, it has told me to draw a vase. So let's try to draw it.
I see line, 4 leg, 4 door. Oh, I know, it's face.
See, it has recognized it. Now it has given me next challenge to draw a lion. So see, basically whatever I'm drawing, understand here, it's speaking that also, which means that it is taking an input, giving it to the model, and your model is predicting that. So for example, if I draw a car, see.
I see line, 4 computer keyboard, 4 van.
See, it has predicted van.
Fire truck, 4 school bus, 4 bus.
See, understand, it is trying to predict whatever I'm drawing. Okay, and there's some timer like this. So these are all the examples of AI experiments. You can see more over that. All this, the complete world is flooded with this AI experiments. Wherever you would see, everywhere you would find that. If you need more examples, very cool examples are there related to that. Like one of the very favorite example is caption generation. See, so caption generation online, there was one tool for it. Just a second. Caption generator online. Some tool was there that used to generate the free captions. Caption generator. Okay. So this type of examples are also there. I don't know exactly the name of that website, but yes, this is something. If I see, I would show you that. Okay. There is also one more thing, that is text generation. Okay. This website also, yes, this infer kit is there. Now in this, you give a small text to it. For example, hello Shubham. If I give that, if I write here, hello Shubham, and if I say that generate the text for me, it would automatically generate some text based on what input you have given automatically. Again, this is an example of neural networks. So this, in this way, there are millions of examples of machine learning. You can try that more. Everything is available on Google. You can search for more examples like this. Okay, now a lot of things we have seen here. Let's try to understand what are these things. Okay, now pay attention here. What is data science? Let's understand it quickly one by one. Data science means whenever you have a data and you try to apply some science on it, basically you apply some knowledge on top of data and find insights.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
That is called as data science. Like data science is a big umbrella. Inside data science, there is a data analyst. What is the job of a data analyst? He would just analyze the data. For example, now Shatrughan is every 15 minutes, he is just writing hello. Okay, just 15 minutes, he's writing hello. So the task of a data analyst is to analyze this pattern. A data analyst would just analyze the business patterns. Like for example, Colgate is, let's say you are a business analyst at Colgate. So you would analyze here at what time, let's say my Colgate sales are going down, whether it is due to the shape of a Colgate or different variant or any other marketing strategy has failed. What is the problem? That is a task of data analyst. What is AI and robots? AI and robotics are the complete end-to-end solution. Like for example, all of you have seen the robot movie. If you have seen that, or there is a perfect example for the robot movie is that Boston Dynamics. Now this company basically just manufactures the robot. Okay, like you can see that this is an end-to-end product. In this we use like all the things like machine learning, AI, deep learning, neural networks. You use all that things. That is called as your AI, end-to-end solution. Now predictive analytics, again, it comes, a lot of algorithms comes inside it. Like in this, analyst would just analyze it. Okay, for example, a task of analyst is to just analyze that, okay, this movie is not earning money because of this XYZ reason. Analyzing is a task of data analyst. But how much that movie would earn, okay, how much that movie would earn, predicting something is called as predictive analysis. For example, let's say Jaren is analyzing the weather. Jaren is, yes, weather. So Jaren is analyzing the weather. He would just say that, okay, the rain has been less due to this XYZ reason. Because you cut the forest, the rain is not there. But at the same time, let's say Jaren is a predictive analyst. Okay, he is a predictive analyst. He's going to predict, he is going to forecast that what would happen in future, how much rain it would be there, all that stuff. Business intelligence and Data analyst goes together. Business intelligence there are tools for business intelligence for doing this data analysis task, like Tableau is there. Okay, then there is Power BI is there. Many tools are there like this to do all this task. Business analyst, business intelligence basically is related to direct data analyst. Now you have deep learning. Deep learning is like a human brain. How a human brain works? Exactly like this. We are going to see that. Don't worry about it right now. Machine learning, I have already explained you. We are going much detail into that. And data engineer is a person who basically collects the data, store the data, data security, data management. Let's say you are working for a Twitter. Twitter gets like thousands of tweets within a second. How to manage that, how to store it, how to use it perfectly. Okay, streaming the data, that all task is done by data engineer. So now let's understand in detail which terminologies are important for us. Machine learning is a subset of artificial intelligence, which gives a machine ability to learn without being explicitly programmed. Let's understand this. Something that is end-to-end is called as AI. End-to-end means that you deliver the complete product. Correct, Venkata Shubham, that's perfectly right. So to make a robot, you need to use some machine learning. Your robot is a machine, and you want your robot to learn something. That is, it is a subset of artificial intelligence, which gives a machine the ability to learn without being explicitly programmed. Like I have explained you in cat example, we have not explicitly said that how a cat looks. Machine learned that. Same way your robot also would learn. Data is the key and the learning algorithm. So to make this algorithm learn, you need data. That is a very important. Anyone has heard this definition that data is called a new oil? This is a very famous definition. Data is called a new oil. Now in today's world, everything is working on oil. Like your industries work on oil, your shops, everything, basically your vehicles, your car, your plane, everything works on oil. Now in future, everything would work on data. For example, your self-driving car. Without data, your self-driving car cannot work. The machine learning example, which I have shown you just a minute before, sorting a list. In this, the input and output that you give, that is called as data. Now imagine, can this machine learn without this data? If you don't give this data, machine can learn. That is why data is called as new oil. How does a machine learns? Let's understand that. So basically, many things that you do on internet, who knows that we are already training a machine? Everyone have seen this type of captcha? Yes. Basically, you are making the data for Google in this case. Now, whenever I select where is fire hydrant, I would select this. So now automatically in computer, in Google server, they have 3 images that is of this fire hydrant, and they are labeled as well. So automatically you are generating the data for Google. That's the reason Google provides you a lot of things for freely, because you work them as a data, you work them as a oil for them. Without us, the Google also cannot work. Okay, now what is AI versus machine learning versus deep learning? Now AI is the major big part, like I have explained you, the end-to-end solution like a robot. Machine learning is a small part of it, and deep learning is more a smaller part of it. Like you can see, deep learning is like a human brain. Machine learning is how a machine learns. There are 2 different things. And then artificial intelligence is a combination of all these things. So artificial intelligence, area of computer science that emphasize the creation of intelligent machine that works and reacts like a human. Now, whichever points are important, I'm going to explain you. Artificial intelligence is a thing where your computer acts like a human. Machine learning, it is a subset of AI which gives machine to learn without being explicitly programmed. We have already seen the examples for this. Now, deep learning is a subfield of machine learning. Inside machine learning, there is one more field, that is deep learning, which algorithms are inspired by structure and function of a brain called as artificial neural networks. So understand it like you have the big one as AI, उसके अंदर एक छोटी सी चीज machine learning, and inside machine learning you have a small thing that is deep learning. This is how your complete picture look like. Types of machine learning. Now, up till now, we have understood all the basic things like what is data science, what is machine learning, we have understood. Let's now understand the next part of it, of machine learning. That is, machine learning is further divided into three sections: supervised, unsupervised, and the last one that we have is reinforcement learning. Reinforcement learning. Let's understand all three of them one by one. It would be really interesting. Let's pay attention. The first one is supervised learning. Let's understand supervised learning with a story. Again, a very, very important story part, all of you. Supervised. So let's understand the first part of it, supervised learning. So let's take a task. We have a simple task. We want to learn how to ride a cycle. Learn how to ride a cycle. Now, to learn how to ride a cycle, what a human would do, just forget about machines now. Pay attention and try to understand it. The thing is very simple. You might have your father standing behind your back, and your father is explaining you, your father is teaching you how to ride a cycle. So if you make any mistake, your father is there to correct you. You make any mistake, your father is going to correct you. That is called as supervised learning, where your father is acting as a supervision. Supervision means a vision that knows everything. Your father knows how to ride a cycle. That's the reason he can teach you. That is called as supervised learning. When you already know the correct answer, and based on the correct answer, you teach someone, that is called as supervised learning. Now see, if yes, you give this image and you give the label also to it. Right now, here there is no machine learning. Here you are just creating the data for them, Ekansh. Understand the difference. Here you are not using any model. Here you are just giving the data to the model that this is an image of fire, this is an image of fire, and this is the image of fire. But when you use this for training, then it is a supervised learning. Okay, for a minute, let's try to remove all this unsupervised part so that you only focus on supervision and you don't get diverted by unsupervision. Okay, now see, you have here input data, that is apples. You give a labels to it, that is the annotations, that bro, this are apples. Your model would take both the things, that is your data, images, and your apples label, and then your model would learn here. This is called as supervised learning. Basically, this is called as supervision.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Supervision, basically this is called as your labels. Now, whenever in your dataset you have labels means that you actually know what is correct then it is called as supervised learning. Now a new apple comes to you, you would put that into the model, and your model would make the prediction that it is an apple or it is not an apple. Very good, very good, very good. That's great. That is called as supervised learning. Now the difference would be more clear when you see the unsupervised learning. So see, in supervised learning, like I explained you, training data. Now pay attention. In training data, you give an image, you give a label. 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 So this your small Chintu computer would learn that, okay, noted boss, that how an apple looks like. Now tomorrow this Gajodhar would come in, and this Gajodhar would ask the computer that yesterday I taught you something. What is this? What this image represents? And your computer, your Chintu would give you that it is an apple. This is the example of supervised learning. The perfect example for this is a spam classifier. All of you have seen that spam classifier in your Gmail, correct? This is a perfect example for that, where your machine already learns from a data which is a spam and a non-spam, and whenever a new email comes to you, your machine would classify them as a spam detector or a non-spam detector. Same face recognition, fingerprint analysis, this all are the examples of supervised learning, where Savita would give her fingerprint and the model would learn that. Hemant would give his fingerprint, model would learn that, like this. Now let's understand unsupervised learning. Again, the things I would make it so simple for you that you would again start dancing on your chairs. Let's see unsupervised learning. Now see, same example, that's the reason I have taken this, the same example for unsupervised learning. Now this time, let's completely black it off the supervised learning, so that you even not look at any part of it. In unsupervised learning, you take a bunch of data, whatever you have, that is this data. Okay, now, like I said, machine learning is human learning. Imagine that there is a small child, small kid, who doesn't even know how to speak. Okay, but if you give him this type of data, just based on the shape, maybe just based on the shape, or maybe based on the color, or maybe based on size, he can at least differentiate between the products. मतलब वो products को अलग-अलग group, basically that is called as different clusters. In simple way, it is also called as group. This is called as unsupervised learning, where there is no supervision at all. You learn on your own. That is called as unsupervised learning. Like our same bicycle example, which we were understanding with the father. Now let's say on a day your father went to an office. At that time, you don't have any supervision. When you learn, you fall from the cycle, you learn on your own without any supervision. When you learn without a supervision, when you learn without a supervision, in machine terms, when you learn without labels, see, there are no labels. When you learn without labels, it is called as unsupervised learning. Unsupervised learning. This is the perfect examples for supervised and unsupervised learning. Let's summarize it from the PPT, where you have different products here. Okay. Now you ask your machine to create different clusters. Understand this is your child, and you got 3 different clusters here, like cluster 1, cluster 2, cluster 2, based on similarities. This is called as unsupervised learning. Now the examples of unsupervised learnings are the voice recognition, voice-based personal assistant that you see, the example that I've seen you, the Google, that is an example of voice recognition, is an example of unsupervised learning. Netflix recommendations, sometimes, many times, your recommendations are also the example of unsupervised learning, where it learns from the behavior of the customers. Let's move to the next point now, and that is your reinforcement learning. Now, reinforcement learning is again very, very simple, like you have understood supervised, unsupervised. Reinforcement learning is learning from penalty. Very, very best example I have for reinforcement learning is now, all of you wear the helmet while driving? No, perfectly not. No one depends. No one wears. Okay, until and unless you have been charged or you need to pay the penalty for it. Now, just think for a minute. If you have paid a penalty for it, let's say you have paid 1,000 rupees. Will you wear the helmet next time? Yes or no? Yes, you would wear it. For sure, you would wear it. If someone says no, just imagine that 10 days in a row, you are charged with 1,000 rupees, 1,000 rupees, 1,000 rupees, 1,000 rupees, 1,000 rupees. Definitely, throughout your life, you would never get out without a helmet. So here, when you learn from penalty and rewards, as well as rewards as well, okay, that is called as reinforcement learning. For example, see, now reinforcement learning is like this. You observe, select an action. So basically, this is a self-driving car. Now this self-driving car is going. The self-driving car sees a closed board. But this self-driving cars take a action, select a action, and it get banks. Like it doesn't stop. It pays. Like this self-driving cars keep the power on accelerator. Matlab accelerator dabaya, and now that car has been banged with this closed. At this point, we would give algorithm minus 50 points. Now, algorithm has learned from it that next time you don't need to you need to make a turn or you need to stop whenever there is a closed part. So you observe, you make an action. That action can be reward or penalty. If it is penalty, then next time your computer would not do that. That is called as reinforcement learning. Same way, the dog example for it. Now, before conditioning, dog sees a food and dogs goes towards the food. Now, second time, before the dog sees the food, you bell a ring. Okay, ganti bajaya. Now, at that time, dog doesn't know anything. But the moment you were doing this, the dog also sees the food. Now, that time, the water gets out of the dog's mouth. That is called as salivation. Now, next time when you ring the bell, you ran the bell, automatically that dog would comes to that food. So it has learned that whenever you would bell a ring, that is a time for a reward. Whenever aapne ghanti bajai, at that time the dog would get the food. So that is reward and penalty stuff. You make machine learn with a reward and penalty. Use case of this is self-driving car, like I have explained you. The machine learns on its own by understanding the rewards and many other things. What we can do with machine learning now? We can do a lot of things. Some of the examples we are going to see in the real life in today's scenario, that what is the market value of a house, which type of house lies in this segment, whether an email is a spam or not. All these models we are going to make inside the session. Classification. Now there are different types. So up till now, what we have studied, we started our session with what is the difference between programming and machine learning. We understood that to make machine learn something, we need to give input and output. Now there are three types of machine learning, that is supervised, unsupervised, and reinforcement. Supervised have labels, unsupervised is without labels, and reinforcement is reward and penalties. Now it's a very, very interesting part. What's the next part? In machine learning, so up till now we have seen let's take the diagram from here itself, so we don't need to draw that once again. Okay, so now in machine learning, we have supervised learning. So for a minute, forget about unsupervised and forget about reinforcement learning. We would spend our complete time on supervised learning. So now, supervised learning is further divided into two major branches. One is regression and next one is classification. Now see how I would make your life so simple by making you understand these two things. What do you mean by regression? It predicts the outcome, but not exactly percentage. It predicts something, but it is continuous in nature. Let's understand that. Continuous in nature. When there are infinite values, Again, what does this infinite means? Let's say Shubham wants to predict the house price. Okay, simple example. Shubham wants to predict the house price. Now, house price can be 10 lakh rupees a house. It can be 15 lakhs rupees a house. The house can be 17 crores, 0.341278 crores. House can be of 1 lakh, 1,001,11111 rupees, like that. So there are infinite values between a number. Like 1 lakh to 2 lakh, there are infinite values. Whenever you want to predict something that is infinite in nature, or in simple words, you call it as continuous in nature, that comes under regression problem. Like if you want to predict the salary, again, salary is the example for that. Salary can be continuous in nature. If you want to predict the temperature, temperature can be continuous in nature. This all are the examples of regression. At the same time, now, when you understand classification, your doubt would be 100% cleared. What do you mean by classification? Classification is basically categories. What do you mean by categories now? I gave you the example of predicting dog versus cat. Is there any middle example like cat 5.5, cat 1.2? Is there any middle value like this? No. Whenever there are specific categories, it is called as classification. So these are all the examples of classification. So if the person is male or female, again, example of classification. If a person is male or female, that is an example of classification. Is a male spam or a ham male, non-spam male? That is again example for classification. Is there any fraud in this transaction or not? Is there any fraud in transaction or not? Is someone is trying to hack our network or not? Yes and no examples are there. Again, they are classification. Then clustering. Clustering is an example. It is similar to, now understand the difference. Here is where the learners get confused a lot. In unsupervised learning, it is called as clustering.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, I would tell you a simple stuff, whatever you have learned. This is the example of clustering. And like apple, banana, orange, these are classes, these are categories. This is an example for classification. Okay, the one thing that you are missing here, everyone, classification is supervised learning. What is the most important thing in supervised learning? Label is very, very important in classification. So whenever you are doing classification, you would have label. Unsupervised learning is clustering. And what's the difference in unsupervised? Quickly, it does not have labels, no labels, perfectly right. So that's the difference between classification and clustering. You do the same thing. See, here also I'm predicting the apples. Here also I'm predicting the apples, bananas, and orange. But the difference here is I know the labels here, but here I don't know the labels. We have understood clustering. What type of customer buy this product? So for example, now you have an Amazon data set. In Amazon dataset, you have Apple product, let's say iPhone 14. So which type of people are buying this Apple 14 products? Now there is no label for it. We group the similar clusters. Let's say people who are spending more than like 20 lakh rupees per year. Only that type of people are buying iPhone on Amazon. So there is no label for it. We don't know which type of people are there. Just based on similarities, like their buying behavior, they are buying different brands. Based on that, we are grouping the customers here. That's the perfect example for unsupervised learning. Okay, regression. Okay, now the regression. What is the market value of this house? I have explained you. Is it going to, how much it is going to rain tomorrow? It should be how much it is, is it going to rain tomorrow? That is an example of regression. Like in millimeters, it is raining 100 millimeters, or something like that. There is a unit for how much it would going to rain tomorrow. So that is your regression stuff. Linear regression using Python. Let's understand what is regression. Now, regression is basically a technique of finding relationship between two or more variables. Change in dependent variable is associated with change in one or more independent variable. Let's understand this definition. So my simple definition here is that linear regression is relationship between two or more variables. It's simple, relationship between two or more variables. Let's understand this again with this story. It's a story time, all of us. Two or more variables. So what's in the story time? Very simple thing. If I want to predict the house prices, as it is a continuous variable, we are going to use linear regression on top of it. Now, a simple thing here. If I increase the square meter area of house, okay, whether my price would be affected or not. Let's say my first house is square meter area, second house is 1000 square meter area. Whether the price would be affected by this? What I said that linear regression is a relationship between two or more variables. You have here variable 1. This is called as your variable 1. This is your variable 2. There is a relationship between these two variables. Relationship is if one thing goes up, if let's say today Ayush increase his square meter area of the house, if square meter area increases, the price of a house would also increase. This is called as relationship between two variables. And linear regression would help you to find that relationship. How, Akash, linear relationship would be able to find that? Basically, as a human, I can tell this. But linear relationship would tell if you increase from 100 to 1000, how much it would affect the price. You can see that it is an increasing relationship, but linear regression would say how much the price would increase. Like by 20 lakhs, 50 lakhs, 60 lakhs, 100 lakhs, 1 crore, 2 crore, how much the price would be increased if you increase the square meter area by 1000, by 10,000, by 2000, by 20,000. This would be explained by linear regression. Change in dependent variable is associated with change with one or more independent variable. It explains you change in dependent variable. Change in dependent variable is associated with change in independent variable. Now, what is this new terminologies you have got here? Some two different new terminologies, that is independent variable and dependent variable. Let's understand what is this. The equation of line is now C. If you don't know, no problem. I'm going to explain you everything. So equation of line is y equals to mx plus c. Now, what is this? Before going to the maths, we are going to understand that in a real scenario. So we would open a very good website is this, that is graph demos. Okay, you can open this website graph demo, and in this you can make your equation of line, whatever equations you want, you can plot that here. So if you don't know any equation, come to this website, try to draw it, and you would understand it. So for example, I would write here y equals to mx plus c, and I would add a slider for all of them. So this is how my line looks like. There would be a random value of m here, a random value of c. This is called as the equation of line. Now, as you change the m, your line would start rotating. See, your line is rotating. And if you change the c, your line would move up and down. See, your line is moving up and down. We would zoom in more better so that you can see that more correctly. Okay, now see, if I change the c, you would see the line is moving up and down. This is called as equation of line. Now the c would make your line to move, okay, and m would make your line to rotate the way in which you want. With this line, you can find the relationship between multiple variables. Now, in this equation, you see there is y. Y is basically called as your price of the house. Okay, great. So yes, you have y here. Basically, y is called as the price of your house. And x is called as, you can consider this as a variable, or variables are also called as features. What do you mean by variables? Like variables can be square meter area. So x can be your square meter area, like that. M is called as the slope of your line. Now, what is the slope? I'm going to explain you. And C is called as the intercept of the line. Intercept of the line. Now, tell me, here y is, it's very clear that here y is dependent on three values. I'm writing that also for all of you so that it's there in your mind. Y is dependent on three values. What are the three values? It is dependent on m, it is dependent on x, and it is dependent on c. Even if I change x by 0.1 units, my y would change. If I change my c, my y would change. So that's the reason y is called as dependent variable. Now keep that in mind, what is dependent and what is independent variable. Because y is dependent on three things, it is called as dependent variable. At the same time, now your x is not dependent on anything. No matter what value of m you change, what value of y you change, what value of c you change, x would not change. X is independent on any value. X has its own value, and x value would never change. X would never change. If you change m, c, or y, that is why x is called as independent variables. Now there can be multiple variables like your house price. Okay, I have a quick exercise for all of you. Tell me whether that is correct or not. Okay, I'm drawing a simple data set for all of you. I have here on y-axis, I have here the price of a house. So my price of a house, and my second column here is square meter area. So my square meter area of first house is 300 square meter area. Next house is 700, then it is 1400, and then it is 400. Now my first house price is my first house price is 70 lakh rupees. Second house price is 20 lakhs. For this house, third house price is like 40 lakh rupees, and this 400 square meter area is of 1 crore rupees. Now first tell me, is this data making sense? Is this data making any sense? Now, if I add a new column here, that is location. And if I say you that the first area belongs to Mumbai, this 700 belongs to some rural area, this also 1400 belongs to some rural area, and this 400 again belongs to Mumbai. Now, does it make sense? Perfectly, yes. Yes, it makes sense. So this is called as your linear regression. This is your x1, this is your x2, and this is your y. So y does not only depend on one variable, it can depend on multiple variables. Because your y is dependent, y is called as your dependent variable. And rest all this x1, x2, this are called as independent variable. Let's see the example of regression. Regression is a technique that displays the relationship between y based on a variable x. Exactly the example like I have explained you. Your y was the price and it was dependent on some x. For example, as temperature drops, it's a time of a winter now. As temperature drops, the jackets that you have, the clothes that you put increases. So if the temperature goes down to minus 10 degree, you would have 15 jackets. If the temperature goes down to minus 50, your number of jackets would be 50. It would be increased. So this is called as, again, an example of regression, where one thing goes down and one thing goes up. This is also the example of regression. So temperature versus number of cold cones sold at ice cream store. So if your temperature increases, like summer increases, your number of cones would also be increased. Inches of rain versus new car sold. Maybe people do not buy car in rainy season. So it can be opposite relationship. Daily snowfall versus number of skier visits. So if you think there is a relationship between two things, regression would help confirm that. So all these things which I have explained you, temperature versus cone, inches versus car, dayfall, snowfall versus skiers, all these things regression can take case of wherever there is a relationship. There are majorly two types of regression: linear regression and logistic regression. Now, linear regression is continuous variables. I have already explained you. Logistic regression is categorical variables. That also I have explained you. Straight linear means, I was asking the English definition for it. Yes, linear means a straight. Linear stands for straight. So linear is equals to straight. So whenever you draw a straight line, it is called as linear regression. Now, simple linear regression is useful for finding relationship between two continuous variables. One is predictor or independent and another is a response or dependent. Let's understand that. Now, in regression also, so we have reached a position where we are going to understand. So we have reached a position where we are going to understand regression. Now, regression is further divided into two stuff. Let me draw that here. Yes. Now, linear regression is further divided. Linear regression is further divided into two steps. One is simple linear regression, and the other one is multiple linear regression. What do you mean by simple linear regression? When you have one independent, when your independent variable is one, and your dependent is also 1. Dependent variable is also 1. In this scenario, it is called as simple linear regression. X is your independent variable and Y is your dependent variable. So whenever you have only one X, it is called as independent variable. Whenever you have one X and one Y, it is called as simple linear regression. Now, in other hand, what is multiple linear regression? What is multiple linear regression? In multiple linear regression, we would have 2x or more than 2x, like x would be more than 2. So independent variable would be more than 1, greater than 1, and y, that is your dependent variable. See that I have increased already 2 independent variables, x1 and x2, but my y will always be the 1. Price एक ही रहेगी, price change नहीं होगी, price would always remain the same. Based on height, okay, I have here one variable that is height. I am predicting here whether it would rain, how much it would rain, how much. So basically my height here is 20 meter, 40 meter and 100 meter. And height here is like in inches, I am writing here 79, 89 and 101. Okay, which is what it is? Simple linear regression, multiple linear regression, or classification, what it is? So understand, guys, the correct answer here is simple linear regression. This is an example of simple linear regression. Simple linear regression. Why simple linear regression? We want to predict how much the rain is. That is our y. We want to predict y, and we have only x. So when we have only one x, see that only one x and one y, then it is called as simple linear regression. Now see, I would frame this question a little bit in a second scenario. Now I have here the height. We are increasing the height in the same way, but this time I have changed this to how much it would rain. That is not the stuff. Now my question here is, will it rain? Will it rain? And I am writing here, okay, and I have here 0, 1, 0. Okay, so what it is, first of all, simple or multiple linear regression? Perfectly right, Ekansh. This is not a regression problem. Basically, this is a logistic regression problem. This is not simple linear regression. This is logistic regression. Why logistic regression? Don't go with just numbers. If you have numbers, it is regression. It is not like that. 0 means no and 1 means yes. This is a simple categories. So whenever you have category, it is not a linear regression, it is logistic regression. Okay, great. Now we would take one more example where the heights went from here. Let me write the heights also. So heights here was 20 meter, 40 meter and 100 meter. Okay, now the question here changes a little bit. The question here is, now I have one more data set. This data set is basically, I have here, I want to predict the house type, predict the house type. So my house type is like big house, small house, okay, or medium house. I have 3 categories. And I have some columns here like square meter area. Square meter area is 200, not 200, 1200. The small houses of 200 and medium houses of 700. Then I have one more column that is pool. So in my big house, there is one pool, there is 0 pools here, and again 0 pools in medium house. And then location. So the location of this house is at a rural area. This is at Mumbai. This is at Mumbai. Okay, now which is this data set? Will you solve it by linear regression, logistic regression, or you would use here linear regression simple or linear regression multiple? It's not linear. You are looking at this part and you are saying it linear. No. First thing is to understand whether it is regression or classification. How you understand? You first check what you want to predict. मुझे मेरे मॉडल को क्या लर्न करवाना है? What I want to make my model predict. I want to predict here the house type. and they are specific categories. There is nothing like big 1.0, big 2.0. I have category 1, category 2, category 3. It is like simple, apple, banana, and orange. And based like you have categories, it would never come into linear regression. Again, it is a problem of classification. Okay, let's take one more example for multiple linear regression. Now see, the same example I can create that would make your mind perfectly. I think that would crystal clear your doubts. Okay, and the same example I would convert it into linear regression. Okay, that would be fine if I convert this into the same example into linear regression. Yes. Now see, I would just, if you want to convert a classification to linear regression, you just need to remove the prediction column, and I have here, instead of house type, I would just do here house price. Now my first house is of 2 crores. Second house is of 20, not 20, like again this house is of also 2 crores, and this house is of 80 crores, or let's say 8 crores. So this is my, now here there are infinite values. This becomes a regression problem. Everyone agrees that this is a regression problem? Yes. This is your y. How many x are there? This is x1, this is x2, this is x3, 3x are there. So you have, yes, 3 independent variables, 3 independent and only 1 dependent variable. So what it is? It is an example of multiple linear regression, multiple linear regression. Okay, coming back to our point. Now it's time to understand linear regression in detail. It's time to understand linear regression in detail. This is the equation of your line. You have some independent variable, some dependent variable. If the line grows like this, it's a positive relation, which means that, now pay attention and try to understand this. What does this mean? This means that your independent variable, remember what was your independent variable? Square meter area. What's your dependent variable? It's your price. So when your square meter area increases, let's say this is your square meter area, your price is this much. Let's say tomorrow Anand increase the square meter area, he moves to this point. He was staying in like 400 square meter area. Now he has moved to 4000 square meter area. He would see that the price automatically increases. See, the price has been increased this much. This is called as positive relationship, where your values increases, your independent variable increases, your price also increases. Let's see the negative part of it. Now this is negative. Let's understand this with an example. If your independent variable is time spent on Instagram. Okay, now this time, let's say when Anand got a new home, he started spending more time on Instagram. Okay, and his dependent variable is the knowledge that you get. Okay, the knowledge that you get, or maybe the money that you earn. Okay, let's keep it as money that you earn. So it's very simple that if you waste your time, if you increase your time spending on Instagram, your money increasing would be decreased. Like for example, today Anand was spending, let's say, 10 minutes on Instagram. At that time, he was earning very, very good. Let's see this. The price was very high. But let's say from 10 minutes, he increased it for 10 hours. At that time, see how much the money has dropped here. So this much, there is a drop. This is called as negative relationship, where one value increases, like time is increasing, but money is dropping here. One increases, one goes down. Same example we have seen with jacket also. As your temperature decreases, so let's consider this as temperature, and let's compare this as a number of jackets. Number of jackets. Now, if your temperature increases, so your temperature was 20 degree, now it went for 50 degree. Your number of jackets would decrease. In winter, no one wears, sorry, in summer, no one wears the jackets. So if your temperature increases, your number of jacket decreases. Okay. So now your complete task for your complete linear regression is to make this line. Okay. Your complete task is to make this linear regression line. Basically, let's try to understand this with an example. There are some observations and you would make a line here, least square methods. Okay, let's understand this with an example. Okay, but before moving to that, we are going to understand here just last two concepts. What is a slope and what is an intercept? That is in equation y equals to mx plus c. What is y here? So y is your price. Y is your price. Price, basically, yes, y is your dependent variable. That's perfectly right. What is x? It's perfectly right. It is an independent variable. Now it's time to understand only the two concepts for today. That is what is m. M is called as slope of the line. M is called as slope of line. Now what is the slope of line? Slope of line means change in y with respect to change in x. Let's understand this with a very interesting example. I have a small data set. Okay, for example, I have some data sets here and I am drawing one line on top of it. This is my line. Let's consider my x-axis. My x-axis is how much square meter area my house is and y is my price. We would keep a simple example for today. Now, the square meter areas are like this, like 20 square meter area, 40 square meter area. Okay, that is very less. Let's consider 400 and 200 like that. Okay, 200 square meter area, 400 square meter area, then you have 600, then you have 800, then you have 1000 like this. Now, let's say Ayush comes into the picture and we have here price. So price here is like 7 crores, 6 crore, 5 crore, 4 crore, 3 crore, 2 crore, 1 crore, and 0 crore. Now, Ayush comes into the picture and Ayush says that, so we have Ayush. Now, Ayush decided to see the change in y with respect to x. So basically, first what he did, he just plotted that at 400, what is the house price? How to plot it? He would just project this 400 on the line and project it here. So he's getting something around 2.5 crores. This 3 is not here. Basically, the 3 is here. The 2 is here. 1 is here. Okay, let me write it properly so that it's not confusing at all. So you have 3 here, 4 here, 5 here, 6 here, and 7 is there. Now he is getting 2.5 crores. He said that, okay, I would increase the square meter area of house by 200 meters. That is 400 to 600. So basically, first Ayush said that the house square meter was 400. Then he increased it to 600. And he saw that there is an increase of 1.5 crores. So 400 to 600, he got 1.5 crore rupees extra. By increasing 200 meter area, he got 1.5 crores of profit. Here comes the second part of the story. So I would copy this complete story and I'm going to paste that down. Now in this scenario, what Ayush decided in part 2 of the story, this is our part 2. Ayush decided that I would change the slope. I would change the slope. So nothing else is changing. He's just changing the slope. What do you mean by that? First, let me remove these lines. And now, instead of this red line, he has the new line with a new slope. Yes, he has changed the M and he said that my slope is this one. So now, instead of this red line, he has the line, this blue line. Rest, all the things remain the same. So I'm removing this. Okay, and my blue line, I'm plotting my blue line, which is not like this, which is something like this. Okay, so this is the new slope for Ayush. Now he would do exactly, he would do the same exercise. He would plot 400 here. Okay, and he would plot 600 also in the same way. He would plot that here, and he would again plot that here. Basically, now in the second exercise for 400 to 600, his x is exactly the same. X he has not changed, right? Everyone, x is not changed by Ayush. Perfectly correct. Yes, but see the difference. It is went from 3.5 to 5.5. That is 2 crore. 2 crore. So there is a difference in y. Yes. So basically, m denotes the slope of a line. If you change x, how much? If you change your slope, how much that would be affected on y? So if you have a very high slope, now just see this. Imagine the scenario. Now, if you have a different slope, you would have a different change in y. You can see that the y value is increasing. This triangle is keep increasing here, which means that the moment you change the slope, effect on y would also change. So that is called as change of y with respect to x. How much you change that. Okay. Okay, now I have a very good example. Here I have square meter area. So if I increase square meter area, my price would increase a lot. But let's say if I change here, how many trees are there around surrounding the house? How many trees are there? Do you think that trees and square meter area would have same effect on price? Do you think trees and square meter area would have same effect on price? No. The slope of square meter area would be higher. That means square meter area has more impact on price. Trees also have impact on price. That's correct. But that would be very less. Like see, instead of this, your slope would be, now instead of this, your slope would be very less, something like this, where your effect of y, see the effect of y, the change in price is very, very low, like just like around 20 lakhs. 100% clear, everyone, what is slope? Can I see a big yes for slope? Now, do you understand why the line rotates here? See, the line rotates here. Why? Because that would change how much x would affect on y. That is the thing. Now, the last thing for today, and that is the intercept, that is the C. Now, C is called as the intercept of line. When your x-axis is 0, now what is C? What is C? C is called as intercept. When your x-axis is 0, which means that now Mahesh says that I would spend 0 rupees on square meter area. Like, sorry, even if the house is of 0 square meter area, then also there is some price. For example, if you move to Mumbai, some area has already a very high price, like let's say Marine Drive. Now, Marine Drive, even if based on, like, even if there is no square meter area, the base price of the house is very high. It starts from 200 crore. So the base price is very high. So when your x is 0, but still you have some value of y, that is called as intercept. Which means that even if there is 0 square meter area, your house prices would start from 1 crore. There is no house less than 1 crore. That is called as intercept of, and that is called as C. That was your perfect, complete linear regression. Today, we are going to see much more detail in linear regression, and you are going to code also linear regression. So let's get started with first understanding what is linear regression, how we can make a linear regression there. Now it's time for us to take a data set and work with that. Okay, so we have this data set. You can think of any scenario in your mind. Okay, we are starting with the mathematical part of it, and it's really very, very, very important. So we have here x, we have here y. X is your independent variable. It is clearly mentioned here. Independent variable, you can think of any variable. Like for example, this 1, 2, 3, 4, 5 is your days. Okay, and this y is how much time you sleep in that day. Like on first day you sleep for 4 hours, in second day you sleep for 3 hours. So this is number of hours that you sleep.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So that is number of hours that you sleep. Okay, now the point here is we will the first and the foremost thing whenever you get a data set is that the first and the foremost thing when you get a data set is you are going to plot that. Like 1 and 4. So 1 would be here, 4 would be here. So 1 point here. Then 2 and 3. So second point here, third point here. So 1 point here. Then 3, 4. So 3 and 4. The next point is here. Then 4, 2. So 4 on the x-axis, 2 here. So 1 point here. And the last one, 5, 5. So the next point would be here. So we have drawn our data set. See, we have already kept this data set ready. So 1 and 4, you would get a point somewhere here. 1 and 4, we would get a point somewhere here. So in this way, it is exactly same like we have plotted the data set. You can see the black pointers and the blue pointers are matching. That is your data set. First and the foremost thing in linear regression is to plot the data set. Good, clear. Let's see the second point now. Now the second point here is after plotting it, we would calculate the mean of now how to get whatever we are doing. Understand the reason what we are doing here. Whatever we are doing here is to find the best fit line. Okay, we are going to do all these things to find the best fit line. Now what can happen is, like for example, Shubham can say that this line is best. Tanaza can say that this line is best. Same way, Bhim can say that this line is best. Now we need to find which line is best. So for that, we are doing all these efforts. So let's write down the step at the same time so that it's there in our mind as well. So in linear regression, the first and the foremost thing is you have a data set. After data set, the first point that you do is you plot the data set. The moment you have plot the data set, after that, what you do is second step, that is calculate the mean of x and calculate mean of y. Simple as that. Let's understand how to do it. Now, first of all, before I move to this part, which type of data it is? Simple, logistic, or multiple linear regression? What it is? Very simple. It's a simple linear regression. We have only 1x, 1y, simple linear regression. Perfect. Now, the first thing is you need to calculate the mean. Now, everyone knows that there is a simple formula for mean. That is 1 plus 2 plus 3 plus 4 plus 5. That is the mean of x divided by 5. So that is 3, 6, 10, 15, 15 divided by 5. That is 3. So you got mean of x is 3. Simple, we have calculated the mean of x. Same way we'll calculate the mean of y. That is 4 plus 3 plus 4 plus 2 plus 5 divided by 15. Like 5, sorry. So 7 plus 6, that is 13. 13 plus 5, 18. 18 by 5 is 3.6. So 3.6 is the answer for this. Now this is just overwritten, so forget about it. 3.6 is the mean for y. I hope I've calculated that properly. 10, 13, 15, 10, 18, 18 by, yes, correct. 18 by 5, that is 3 and 3, 0, 5, 6, 30. Okay, 3.6, that's correct. So we got y mean as 3.6. So here it is 3.6, the y mean, and x mean is at 3. So we got these two values. The first step is perfectly done. That is 3.6 is the mean for y and 3 is the mean for x. Now, the first and the foremost point is we need to find the m value here. What should be the slope of a line? what should be the slope of a line? We need to find that. So let's see how to find the slope of a line. So to find the m, that is slope of a line, okay, to find m slope of a line, we need to use this formula. Now this formula seems very difficult, but it is a very, very simple formula. Okay, this is also called as Pearson coefficient. Okay, this is also called as Pearson coefficient. What do you mean by that? This means that how x and y are related. Simple as that. Pearson correlation means how these two variables, that is x and y, are related. Whether they are related like this, whether they are related in the negative direction, whether they are not related at all. So that would be calculated by this formula. So to calculate that, okay, we need to use this formula. Let's understand what is this formula and how to calculate it step by step. Now this is x minus x bar. Okay, this is x minus x bar, which means 1 minus 3. That is the mean. X bar means mean here. This is x bar, this is y bar. So 1 minus 3, then 2 minus 3, then 3 minus 3, 4 minus 3, and 5 minus 3. In this way, we would get x minus x bar. Same you would do it for y minus y bar. Let's see that step by step. So x 1 minus 3. Then it becomes 1 minus 3 is minus 2. Same way we would calculate for the other points. So see now here. What's happening? You are getting a distance of mean point versus your other point. Understand it step by step. This is your mean. Yes, perfectly right. This is the mean of x. Now what we do, we calculate the standard deviation. Standard deviation means how much you are away from the mean. Let's understand it with a story. Now I say that in our class, out of 10 marks, the mean is around 7.5, which means that many people are getting the marks in a range of 7 to 8 marks. Right? Everyone agree 7.5 mean? Many people are lying in that range. Now, if I say that Ekansh is, let's say, 8.5. So I'm saying that now we calculate the difference here, which means that Ekansh is one standard deviation higher than the mean. Okay, like we calculate the difference from the mean. So here also we are doing the same. We have a mean. We calculate how spread our data is. How far this point is, how far is this point, how far is this point, and how far is this point. So we calculate that. This is the first thing that we are doing. That is calculating the standard deviation of x. So that's the reason you get here 1 minus 3 minus 2. Then 2 minus 3. Thus in the same way you get the other values as well. So 3 and 3 are completely 0. So you got 0 there. 3 minus 3. So this is your first step. Now, like you get the difference of standard deviation of x, how the data is spread, you would same way get the difference of y also. But before moving to y, the third point that we need to calculate is x minus the mean of x. Okay, I'm going to show you the complete code also. Don't worry. Just say right now, is this steps clear? Perfect. Very good. Now the next part, we need to calculate same way y minus y bar. So y bar here is 3.6. So now here would be 4 minus 3.6, 3 minus 3.6, 0, like 4 minus 3.6, again 2 minus 3.6 and 5 minus 3.6. So basically now we are calculating the difference of how the points are separated by y. First we calculated how much the values are separated by x. Then we have calculated how much the values are separated by y. Y mean. So see 4 minus 3.6, exactly like I said you. Same way we will calculate the next point. And in this way we got the next column. So next step after the fourth number step is, this is third number step. Fourth step here is y minus mean of y. Simple as that. Now we got the numerator. We need to multiply them. So let's multiply them now. Okay, first we can calculate denominator as well. So what is denominator? It's just the square of this third value. That is the denominator, square of third value. So next thing what we do is the fifth step. We take the third step. What is third step? X minus x mean, and we take square of that. So we got minus 2 square 4, minus 1 square is 1, 0 square is 0, 1 square is 1, and 2 square is 4. So in this way we got x minus x square. Now we will calculate here the numerator, that is x. So this basically this column into this column. Simple, we are just following this formula. You just need to remember that formula, that's it. We multiply these two things together, minus 2 into 0.4. Okay, same way minus 1 into 0, minus 1 point, minus 0.6, 0 into 0.4, 1 into this. In this way we would do all the multiplication and we got the values. So the sixth step here is that we need to multiply 3 and 4 together. So this step and this step are multiplied. Now we got the numerator here. This is your numerator. This is your denominator. We just need to take the sum now. We have done this part, this part, this part. Okay, then we have multiplied it. Now we just need to take the sum. Now we are going to just take a sum of it, like 4. So numerator, so this is your denominator. Okay, and this is your numerator. Very simple. We would just take a sum, 4 plus 1, 5, 6 and 10. Like this, we are going to take the sum of this also. See this? We have taken the sum. So this is 10 and here the sum is equals to 1. So 10 and 1, we would take that. You would put that into this situation, 1 by 10. Okay, we would put that 1 by 10 here. This is your numerator, this is your denominator. And you get the answer as 0.1. That is 0.1. Okay, so this is 0.1. So we got our m value as 0.1 easily by solving this equation. We got it 0.1. So our m value is 0.1. X is your 3. And now we have the equation C. So basically we have already calculated. Let me just put that the steps here also. So we have done 6 multiply 3 by 4. So you got numerator here. So what's your numerator? X minus x bar into y minus y bar divided by x minus x bar squared. So this is your step number 3. This is your step number 3. This is the step number 4. This is your step number 5. Okay, now the 7th step is just you need to sum. You need to take a sum of this 5, sum of 5. And 8th step is sum of 6. Basically, you need to take a sum of this and sum of this. This is your numerator and this is your denominator. This is your denominator. Now you just put numerator by denominator. Okay, you just put numerator by denominator. That is 6 by 5. So you basically do here 8 by 7 and that is your m value. Now you need to just follow the steps. It is as simple as that. Calculate the values, put that in the function and you would get your m value. That is your slope of the equation. Now the moment you got the slope, then the next part is much simple. You know the equation of line, that is y equals to mx plus c. Now you know the y. How you know the y? Y is from this mean of y that you have calculated. The second step. Okay, so you took the values here. Y value was 3.6. M value is that you have calculated 0.1 into your x value is 3. So 3.6 is equals to plus c. 3.6 is 0.3, 0.1 into 3 plus c. And c is your 3.6 minus 0.3. That is c is equals to 3.3. Simple as that. We have just put the values and we got the answer here. So this is your complete equation of linear regression. How you get the values of m and c. See here also they have calculated the c in the same way. 3.6 into 0.3 plus c and you get the C value as 3.3. And this is exactly the same value which we have calculated. This is the line that we are drawing here. So that has a C value as 3.3 and the slope is equals to 0.1, the black dotted line that you see. So this is the complete equation of your line, that is y equals to 0.1 in x plus 3.3. Now you can predict any value with the help of this. Okay, you can predict any value with the help of this. So for example, now what was your data set? Let's see our data set. Basically, our data set is this one, that we have the values which are x is 1, 2, 3, 4, 5 and y is your 4, 3, 4, 2, 5. Let's write at one place so that we can find the values. So you have x here, that is 1, 2, 3, 4, 5 and your y values are 4, 3, 4, 2, 5. 3, 4, 2, 5. So you got x and y values here clearly. Now you got the equation of y equals to mx plus c, where your m is 0.1, your x we would take it from here, and your c is 3.3. And your c is 3.3. Now you just need to put the values of x. So x is 1, so 0.1 into 1 plus 3.3, that is your y predicted. So you would get here y predicted. 0.1 into 1 is 0.1, 3.3 plus 0.1 is 3.4. Same way you would get it for 2, 0.1 into 2 plus 3.3. So that is 0.2 plus 3.3, that is 3.5. In this way, all the values are already calculated for you. You can see that 0.1 into 1 is 3.3. You have made any mistake here. It should not be 3.2. Just a second. I think a small mistake here. 0.1 into 1 plus 3.3. So yes, it should be 3.4 here. It should be 3.4. Yes, instead of add, it's subtraction. Yes, there's some mistake while writing it, so no problem, we would correct it. 3.4 and it would be 3.5, 3.6, 3.7 and 3.8. So by mistake, I think instead of plus they have done minus. Okay, no problem. So we got this final values, but you see the, okay, I think yes, it should be 3.7 here and 3.8. Okay, so now even if the values are not written here properly, but you see the line is properly drawn here. So this is the first line, that is at 3.4, this is 3.4, this is 3.5, this is 3.6, this is 3.7 and this is 3.8. So this is your red predicted line and these are your actual points. These are your actual points. 3.6, 3.7 and 3.8. So basically, this is our actual values. And just consider for a moment that Mahesh has created this model. So this is Mahesh predicted value. And these are the actual values. So you got your line here, that is y predicted line. Simple as that. Now you have two things. Okay, let's move to the next point now. Least square regression. Okay, the formula that you have seen for M is least square regression. Yes, actually the Pearson coefficient formula is different. Just to explain you, I was saying that. Okay, but let's remove the confusion. This is least square regression. Clear? Okay, now let's move to the next point. Pearson correlation, what it is, I would explain you at the end of the session in more detail, so that the confusion that is there right now, that would be cleared. But to make it simple, just basically you have, this is your least square regression. Now why it is called as least square regression, we are going to see that in a minute. Now, after we have calculated all this, we would calculate what is the error of the line. What is the error of the line that we are going to calculate here? So let's calculate the error of the line now. Okay. So now we calculate here the R square. Okay, we calculate here the r square. But before calculating the r square, we would understand one concept of least squares here. What is the concept of least square? That is ordinary least square. OLS is also called it as ordinary least squares. Let's understand this point now in detail. So basically for ordinary least square, we would use this simple formula. Let's understand this with the exercise. Okay, now once you got this regression line, you calculate the error of this line. For example, what's the error? Basically, this is your error. How much away you have predicted from a line. So these are your actual points and this is your predicted line. This is your predicted line. So we would first calculate what's the error. How to calculate that? Let's see this. So now you can directly calculate here r square also. So here is your r square. The direct formula for r square is also given. We can calculate that with this method also, the r square. But I'm going to explain you one more method which is not there in your PPT, how to calculate the r square. Okay, for that we need these three things, that is y, x, y and predicted. We would calculate r square with this. So let's take this down. Now this is not there in your PPT, but we would try to match exactly the r square that we are getting in PPT as well. Okay, so the moment we got y, x, y and y predicted, we calculate here the error. Can anyone tell me what is error? Predicted value minus actual value. That's perfectly right. So not x minus x mean, Ragul, that is not the error. Okay, that is how standard, how deviation it is, standard deviation. Basically, we are going to understand this by subtracting. This is your actual value. This is your actual value and this is your predicted value. So error is basically actual minus predicted. So 4 minus 3.4. Okay, so let's calculate this step by step. 4 minus 3.4. That is 0.6. So I would write it also here, 4 minus 3.4. Then we do 3 minus 3.5. 3 minus 3.5. That is 0.5. Okay, 4 minus 3.6. That is your 0.4. Then 2 minus 3.7. That is minus 1.7. And then we take 5 minus 3.8. 5 minus 3.8. So that is 1.2. First of all, this part is clear, everyone, how we got the error. Now we take the error square here. Okay, we take the error square. Just understand it with the story now. Instead of moving into the formulas, let's understand what this formula is speaking. So let's say now Shubham says that the house we have, the house price, the actual price of a house is 10 crore rupees. But now the Shubham made a model and that model is predicting 8 crore rupees. So what error he has made? Actual minus predicted. 10 minus 8 crores, that is 2 crores. So we have calculated all the errors that Shubham's model has made. So for 5 houses, how many errors he has made? Now we would see what is the total error he has made. So I would take here the square of the error. First I would take the square and then I will explain you why. 0.6 into 0.6, that is 0.36 square of it, minus 0.5 square is 0.25, 0.4 square is 0.16, and then 1.7 square is 2.89, and 1.2 square is 1.44. So we have taken here the squares. And now we are going to take the sum of these values, like this sum. So 0.36 plus 0.25 plus 0.16 plus 2.89 plus 1.44. That is 5.1. Can anyone tell me why I have taken the sum of the squares and not these values? Now, understand it why we are taking square. To concise the value in small digit. Very, very good, Shatrugana. Okay, there are two reasons. all of you have said is very perfectly, Mahesh, Deepak, Tanaza, and Shatrugana. The reason here is, now understand it. If I say that, okay, now let's consider that Mahesh has made a model. First house he has predicted 7 crores, another house he has predicted 4 crores. Both the actual price of a house is 7, both the actual price of a house is 10 crores here. Okay, actual price is 10 crores, and here the actual price is 1 crore. Actual price is 10 crores and predicted is 7. So 10 minus 3 is 10 minus 7 is 3. And here actual house price is 1 crore, but he's predicting 4. So again the error here is minus 3 crores. Now if I sum them normally, okay, if I sum them normally, so 3 plus minus 3, that is 0. Does it mean that Mahesh has made a 0 error here? Does it mean that? No, perfectly not. In both the houses, Mahesh has made the error. So when you take a sum normally, it gives you the wrong interpretation. Now, second thing, you would have taken absolute values. So I would take here 3 plus 3, this absolute value of minus 3, I would get 3 plus 3, 6. Yes, this is also a solution, but this is not used. Why? Because when you take square, so see, first reason to take square. Why we take square? The first reason to take square is to remove negative values. Remove negative values. That's 100% correct. There is one more reason also that perfectly says, like, high mistakes are penalized more. High mistakes are penalized more. Now, what does this mean? What does this mean? Let's say now Venkata made a model. Now, and Venkata is predicting a model price as 9 crores, but the actual price is 18 crores. So he made a huge error of 9 crores here. But at the same time, he made another model and he is predicting the actual price is 17 crores. So he made just an error of 1 crore in this case, or let's consider at 16. Okay. Let's consider this as 16. So 18 and 16, you get here 2 crores difference. Now, when a model sees such a huge error, if you take absolute values, it would be 9 and 2. But when you take a square of 9 and you take a square of 2, it is 81 here and here it is 4. Which means that if the mistake is small, like chotu motu error, if the mistake is very small, then the penalty for that would be small. So your model would let go that. Okay, it's okay to make small mistakes. It's okay to make small mistakes. You are getting some reliable model. But if you have made such a big error, your penalty would increase a lot. Just relate it with a story and you would never forget this. For example, if you are not wearing a helmet, okay, you would pay some penalty, right? And if you do not, and if you do a, let's say, a murder, that's a very extreme example, but it stands very perfectly here. Is the penalty same for both the things? No, the penalty here is high because the person should not make this type of mistake again. Okay, person should not make this type of mistakes again. So that's the reason penalty is very, very high. Exactly same thing happens here. If a model is making a huge mistake, we take square here and the number grows exponentially, like in a power 2. Okay, and the error is much, much bigger, and the model and that model is rejected, and you would get a better model. So that is the second reason that high mistakes are penalized more. This is called as, also this value that we have calculated, this is called as RSS. That is residual. Understand the term residual sum of square. What does this mean? Residual sum of square. You take residual means error. Residual means error. So you calculate the error. You take the square of the error, see error square, and you then sum all of them. That is RSS. It is also called as least square methods. Okay, that I have written here already. Least square method, because we take a square here and we find the least. Wherever there is least, we take that. So that is your RSS. Now there is 2 steps more left to calculate the R square. So first is you need to calculate here y minus y mean. We have already done that, so we would take it from our data set. Y minus y mean, we have already calculated that. Y minus y mean is 0.4. Okay, that is 0.4. Then you have minus 0.6. Then you have 0.4 minus 1.6. 0.4 minus 1.6 and 1.4. The last value you have is 1.4. So what we have done, the next step, y minus y bar. Y bar means the mean of all these values. So we need to calculate this. Now we are going to take the square of this. Okay, like we would take y minus y bar square. And that is again 0.4 into 0.4, that is 0.16. 0.36, 0.16, 1.6 into 1.6, that is 2.56. Okay, and 1.4 into 1.4, that is 1.96. Okay, so you got this basic values. Now again, like you do a sum here. Okay, like you do a sum here, you also take a sum of all these values that we have calculated just a minute second before. So you take sum here, 0.16 plus 0.36 plus 0.16 plus 2.56 plus 1.96. That is 5.14. That is 5.14. You calculate this. So in this way, the new value that you call, it is called as TSS. That is total sum of squares. Now, what is this total sum of squares? Let's understand that. In total sum of squares, let's take this image so that you can understand it much more better. Let us plot that values. Okay, now we would remove like the extra things from here. We don't need this. Okay, let it be. Okay, so now what your TSS means? TSS means total sum of squares. You can just keep in mind one thing, that TSS is allergic to X. Allergic to X. So basically you would remove all the values of X when you are calculating TSS. You would remove all the value of X. See, we don't care what is the X now. I'm completely removing the X here. And I have just plotted the Y values. So my Y value is 4. You can just say that it's 4. Whatever it is, here it is 3. Whatever here it is, and whatever here it is. So we are only focused on the Y values. Now see, the 2 steps that I'm highlighting here. Okay, that is this step. Okay, and this step is basically TSS. And if you pay minute attention, there is not a single use of X there. We have taken Y, subtracted it from Y mean. We took a square of it and we got the sum. Is X used in these 2 columns at all? Is X used in these 2 columns? Perfectly right. Even if I remove X, you can calculate TSS. So TSS gives you an average model, a base model. TSS is your base model. Like without X also, how better you can perform. So here you calculate the same way, the difference of the actual point and as the TSS model, you calculate the difference, this one. You take a square of it and you sum all the values. So you got TSS and you got RSS. Okay, so now we would calculate this values, the final values here. So you have here 5.1. Let me see if the calculations are all correct. Just give me a second. I'm just taking the sum and checking all the calculations are correct or not. So 0.36 plus 0.25 plus 0.16 plus 2.89 plus 1.44. That is correct. That is 5.1. Okay, let's see this part. 0.16 plus 0.36 plus 0.16 plus 2.56 plus 1.96. Yes, that is 5.2. Okay, so this is 0.16 plus 0.36, so 2.56, 1.96. Yes, this is 5.01, 5.2. Okay, so that is your TSS 5.2. So this is your TSS 5.2. So if you put that in formula, 5.2 minus 5.1, okay, that is 0.1. So 0.1 divided by 5.2, that is 0.09. Okay, so if we calculate this, so 5.2 minus 5.1 divided by 5.2, so that is your R square, and that is equals to 0.019. Okay, let me see if that is. So what's the value they have calculated? Let me just see that. 0.36. Okay, let's quickly see that if we have made any calculation mistakes or not. Okay, I think their y predicted, y minus y predicted, yes. So I think their mistake might be, just a second. So the y predicted is here, yes. I think they have taken the wrong y predicted here, 3.2, 3. There is 3.4, 3.5. So yes, okay. So this values would not make sense because the y predicteds are taken wrongly here, so the values would not match. But this is how we have calculated the complete R square. Now the same formula we are going to see whether we get 0.19 in your complete coding example also. Did we get exactly the same values? Now what is this R square? Someone asked me. Now R square is basically the goodness of your fit. R square is basically the goodness of your fit. What do you mean by goodness of fit? You made a model. Okay, now Ragul did all the stuff. He calculated M, he calculated C, and he did all the stuff. Now after that, he wants to see how good his model is. So to find how good the model is, we use here goodness of fit, that is R square. We use goodness of fit, that is R square. So R square has a simple formula. Whatever you have calculated, 1 minus RSS by TSS. Using this, you would get the value here. Now, for R square, you have one more formula, that is y predicted minus y and y minus y bar square. This is also another formula for R square. You would get exactly the same value by both the formulas. But again, they have taken here the wrong y predictions. That's the reason it is not matching.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, let's try to put the values here and maybe I can quickly see if that is making sense here. Okay, just give me a second. Just give me a second. I would try to find the R square quickly to explain you this stuff. First, let me just do this. Does this mean that less R square value accuracy is high? No. The interpretation, I'm yet to explain you that. I would explain you within a minute. Okay, that is totally opposite what you said. R square is low, which means that your accuracy is very bad. Okay, so we got this now in the data frame X and Y values. Let's see the regression coefficients here and the regression coefficient and intercept. Okay, it's 0.1 and intercept as well 3.3. It's perfectly matching. Now let's try to predict it using the same stuff and see whether it matches or not. Okay, so now we need a square of it. So Y predicted actual values. And now, okay, just we are very close to it. Just a second. This is your X and this is your Y. So we would need this Y. Okay, so this is your Y. And array, this is your data frame. Yes, and this is your Y predicted. So you would take the Y predicted as it is. Yes, perfectly matching. Now see, this is what I was trying to show you. I have explained you what was the R square that we got, guys. What was the R square? 0.019. Yes, correct. Now see, I was doing all these steps just to explain you that when you really go into Python, exactly that value you would get. Perfectly correct value. Very good, very good. So forget about the upper thing. We would start from here, line by line, each and every point I'm going to explain you. So what I did here, first I imported NumPy and Pandas, simple as that. Then I'm creating my data set. So I would create a simple data set using this stuff, pd.dataframe. Now I would make the code look so simple that you would dance on your chairs after this. So let's make a data frame here first. So this is your data frame. This is your how X looks like. So I would give this as a name, X equals to, this is our data frame, simple X. And you can give column names also so that it looks good for you. Columns equals to just X. And we need to give a yes in a form of list. So we have already seen all this. You have already seen that in your Pandas stuff. So X dot head, like we would just print the X. So this is your how X looks. It is exactly what was present on your PPT. X is 1, 2, 3, 4, 5. Clear everyone? The first step, how I created the X part. Very good. Similarly, I would create the Y also. Pay attention. This is my data frame Y, and I would give this as columns equals to Y. Now see, I am assuming that you already know what is this np.array pd.dataframe. Okay, so Y is exactly the same like we had in our PPT, right? Everyone clear? X and Y's. Now see how simple it is. Whatever steps we have done from yesterday, whatever I have explained you on this, like we have spent around 1 hour to draw this table and come to 0.019. That things can be done within a minute using this 2 lines, sklearn model. So we are importing this model now here. I'm restarting everything so that you know everything from start. So yes, this is our first cell that we are running. You can see that it's import NumPy first cell, second cell, third cell. And now we import here linear regression. See how simple it is. From sklearn.linear model, import linear regression. So we have imported linear regression here. Now we create an instance of this linear regression. regressor equals to linear regression. And after that, we use a method called as regressor.fit. And this method is so simple that you just need to do here, see, regressor dot fit, and you need to give your x comma y. So forget about this part, fit x comma y. And our linear regression model is trained. Trust me, all the things that we have seen, the formula, the 8-step procedure, calculating M and C, everything is done here step by step, and your linear regression model is fitted. What this fit method do? It trains your model. It trains your model. Perfect. Now, Akash, you said the model is trained, right? So we would also have an equation y equals to mx plus c, right? Everyone agree? We would have that equation. We would have some value of m and some value of c, correct? Right. Let's see in PPT what we got the value of m and c. Anyone remembers what was the value of m and c? Yes, your m was 0.1 and c was 3.3. Perfectly correct. So I would write here. Okay, what is a skeleton and linear model? I would explain you that deeper. So m was 0.1 and c was 3.3. That we calculated manually without using any model. Manually, by understanding, we calculated m value as 0.1 and c value as 3.3. Now let's see whether we got that values with the model also. Because when I say that my model is trained, that means that I got the value of m and c. So to check the coefficient, it is called as m is called as coefficient. You would use here regressor dot coefficient. Regressor is the model that you have trained, and dot coefficient is to find the value of m. So regressor dot coefficient, that is 0.1. It's perfectly matching. So you got your m. Let's see the intercept as well. Your intercept is also 3.3. That is also perfectly correct. This is your M and C. We got exactly same like we did manually. All the calculations now make sense? Perfectly clear? Yes. Now the last part here, that is sklearn matrix import R square. Now if you want to calculate the R square, you need to use that. Now what is this? What is sklearn? What is this linear model? I'm going to explain you. But for now, consider this is a magic for you. All the things that you have done on this PPT, and it took around half an hour for you, it would just take half second for the model to calculate that. So we would import this part R2 square, and then we would use, first we are going to predict. Okay, now everyone remembers that we have calculated some y predictions that was wrong in PPT, but we have calculated that, like this one, 3.4, 3.5, 3.6, 3.7, 3.8. Yes, but in PPT is what wrong, like 3.2, 3.1. Correct? Now see, the things that we have calculated, 3.4, 5, 6, 7, 8, that also would match. See that? So for that, I would do regressor.predict. And I'm going to predict on my X. You just need to mention, here X, that's it. So your regressor would predict the values that is using the equation y equals to mx plus c. It would use that equation. And your X values would be taken, what X values you give. And m value is this, c value is this. So you would get some y predictions. See that? And the y predictions are 100% matching. Make sense? What we have calculated in PPT? Make sense? Perfect. So this is your y prediction. Now, in R square, what you do? R square basically requires two things. First is your actual y values. So I would write here y. That is my actual y, which I have stored here. Okay. And the y predictions that our model has calculated. So basically Hemant was making this model. So y prediction that Hemant has calculated in this step, I'm going to provide that to my R square. and see the magic. Within a second, you got 0.019. That's the complete magic of linear regression. Now, two things are left here. First, now, what is first of all sklearn? Sklearn stands for scikit-learn. This is a library. So, for example, let's say one day Arihant was feeling that, okay, Akash, to solve this, we need to do so many steps. Like we need to calculate y prediction, error square, y minus y square. We need to do a lot of steps. So let's write a program for it where you just need to give the x, okay, where you just need to give me the x and you need to give me the y, and my program would automatically calculate y predicted, error square, y minus y dash square, RSS, TSS, and it would give you directly the R square. Also, to calculate M and C values, the formula that you have written here, that also my model would take care of. So basically, Arihant has written the complete code and he has given name the code as linear regression. So in your sklearn matrix, if you go, you would see a source code here, not for R square. R square, we don't need to do that. R square also source code you can see here. Okay. Like you would find somewhere the formula is written in the same way, numerator, denominator, and then the final output is calculated. This is for R square. Same thing you can find for linear regression sklearn also, the source code, sklearn linear regression. And if you see, there would be a source code for it. And in that, the complete thing, how to calculate the intercept, what is ordinary least square method. This is exactly what I've taught you, ordinary least square method. That is to minimize residual sum of squares. You remember the short form, what I said for it? Anyone remembers the short form? RSS, perfectly right. See in the original documentations, residual sum of squares. So we minimize RSS here using linear regression. So all the things for it, how to calculate it, that is mentioned in this, like how they calculate it, how they calculate the values, how to optimize it, that all the things are present in this library. So that is your sklearn. Sklearn is a package that has many things. Like in your sklearn, you have logistic regression also. See, in sklearn, you have linear model, linear regression. We can also calculate TSS. Ekansh, when you calculate R square, automatically it needs to calculate TSS. See, when you calculate R square, you need to calculate TSS. So it's yes, it's calculate TSS also. So basically, your sklearn is a big package. In that big package, you have many things like linear regression, logistic regression, clustering, whatever you have seen up till now. This everything is present inside sklearn. So all the things like supervised, unsupervised, everything is present inside sklearn. And from that, we take just one part, that is linear regression. Now, if you want to import everything, you would just do import sklearn. Now in this sklearn, see how many things it supports. So there is like linear models, there is matrix also there, model selection, pre-processing is there, many things are there. You are going to see that one by one. We took from this linear model. Now see in this linear model, how many models are there? Like this regression, one more model is there, gamma regressor, many things there. Your linear regression is there, logistic regression is there, many models are there inside it. Now, to make the session more interesting, we would take a real case study where we are taking the Boston house price data. So this is Boston, it is a place. We have the house prices there, many real world data we have. Now, this is one of the formula that we use to find the best fit goodness of R square. So let's try to use this formula also, 3.2, it is 3.4, 3.5. So let's use this formula here also. So here it would be 3.4. Here it would be 3.5, 3.6, 3.7. Okay, and this would be 3.8. So let's try to calculate with this formula also, because this is the easy formula for R square. You don't need to calculate RSS, TSS and all that stuff. Just by putting into this values, your part would be done. So let's try to get the formula with this also and see whether our answer matches or not. So we have Y predicted. Again, we need to change that 3.4, 3.5, 3.6, 3.7 and 3.8. Now the first thing that we do here is, the first thing that we do is Y predicted minus the mean. Y predicted minus the mean and mean of Y. So mean of Y was 3.6. Y predicted here is 3.4. So we first calculate this values, Y predicted minus Y mean. That is 3.4 minus 3.6. In this way, we will calculate the values here. Again, we need to change all the values because all these values are wrong. 3.4, 3.5, 3.6, 3.7, and then there is 3.8. Now 3.4 minus 3.6 is minus 0.2. 3.5 minus 3.6 is minus 0.1. 3.6 minus 3.6 is 0.0. 3.7 minus 3.6 is plus 0.1, and this is plus 0.2. Now, after calculating Y minus Y predicted, we calculate Y minus Y mean. Okay, that is Y minus Y bar. So 4 minus 3.6. So this values would be correct. We just need to copy this values minus 0.2. And we need to change that values here. Minus 0.2, it is minus 0.1. This is 0. This is 0.1 positive. And this is 0.2. Okay, Y minus Y bar would be perfectly correct. So we have calculated these values. Actually, Y and Y mean have same symbol. It's confusing. Yes. So basically there should be a bar, but that bar I think was not able to work on that. So that's why it is looking at the same. So that is Y bar. Okay. So it's Y bar. The Y dash. Yes, you can. That's a good idea. We can take Y dash. And that also would make sense. Yeah. So here also it would be like Y dash, but I need to change it at many places. So here also it would be Y dash now. Here also it would be Y dash. Okay. So now we got the values. So we got this Y dash and we got all the values. Now it's time to take the square and just sum it. So again, the values would be wrong here. We need to take the square of it. So the values here are just 0 minus 0.2 minus 0.1, 0, 0.1 and 0.2. So this Y dash values are correct. This also like 3.4, 3.5, 3.6, 3.7, and the last one is 3.8. Okay, now the last we take the square of all the values, 0.2 square. Okay, so same way we are going to do it. Now I need to change this complete stuff once again. Okay, so instead of that, I would try to copy this if I can copy this. Yes, I can copy this. Okay, so let's delete this first. Okay, now, so we have taken Y minus Y 0.2 square. So that minus 0.2 square would be just 0.2 into 0.2 is 0.04. So let me write that 0.04. Okay, we would remove all this stuff. 0.04. Same way, 0.1 into 0.1. 0.1 into 0.1 is 0.01. This is 0. Okay, let's make it in a proper position. 0. This is 0. This is again 0.01. And this is 0.04. Okay, so we got all the values here. Now we got the square of this. Again, in the same way, we will get the square of the next values as well. Okay, that is y minus y square. Okay, so we got that values also. And let's try to remove, if we can remove this stuff so that I can give you this PPT. I'm doing all that so that at the end, I can give you this PPT. Okay, so this values would again change. Now we are not changing that right now. Let's take the sum quickly and let's sum it up. So these are our final stuff that we have calculated. The sum of this is like 0.04 plus 0.01 plus 0.01 plus 0.04. That is 0.1 is the answer for this. So summation of all these values is 0.1. So you can check this afterwards. I would just write here summation of this is 0.1. Okay, so now we would just do here instead of 1.9, we would just do here 0.1. So 0.1 divided by 5.2, and this is exactly the same 0.0019. Did we got 0.00? We are getting one more zero here, 0.1, 5.2. Just a second, let me see if I have made all the sums properly or not. So this is the final value. 0.04 plus 0.01, that is 0.5, 0.6. Yes, that would be 0.1 only. So this is 0.1 and this is 5.2. Is y minus y dash score also correct, or is there any mistake? Y minus y dash square. 16, 36, 16, 2.56, 1.96. Let's calculate that quickly. 0.16 plus 0.36 plus 0.16 plus 2.56 plus 1.96. Yes, this value is also wrongly written. Just a second. 0.16. Okay, it's I have written here 0. Yes, it's 5.2. That is correct. So 5.2 square of all these values, and then we add it. This is correct. Okay, so answer is coming 0.0019. 0.1 divided by 5.2. So 0.019. 0.019. Yes. Okay. It's correct, coming correctly, perfectly right. So it should be 0.1 here. You can make the changes, rest of it afterwards. And the answer here for R square is, the answer for R square is 0.019. It is exactly same what we got before also. Okay, so this is your complete R square that we have calculated with this formula also. This is the statistical formula, and again 1 minus RSS by TSS, that is also one more formula. For both of them, we are getting perfectly the correct value. Now let's take a problem statement and let's try to solve that. Okay, and let's solve this problem, that is Boston house price prediction dataset. Let's move to the next part. Now we got this data set. In this data set, first thing that we do is we check what is how many houses we have. How to check that? I can use here. So I would not use here size. Okay. Because size would tell you the complete size, like how many values are there. 506 into 14. So what is size? Understand the difference. 506 into 14. You would get that size. I don't want size, I want how many houses are there. So I would use here df.shape. So there are 506 houses present in my data frame. So a good data frame to get started with. Now, first basic things we are going to see here, like you can do all that basic stuff. df.is null.shape.sum. This is used to check the null values. We don't have any null value in this data set. So that is super clear. Now, the next part that you pay attention here is what is independent variable and what is dependent variable. First, we are doing here just simple linear regression. Simple linear regression. In simple linear regression, what is our prediction and what is our... So now see, you can read about this data set later on this website. I'm going to give you this link. Let's give that right away right now. So in this, you can clearly see there are all the columns. So this Boston house data set is derived from US Census data. The following are the columns like CRRM, that is per capita crime rate, how much crime is there in that town, the proportion of residential area, how much residential area is there, many parameters are there. You can understand it later on. That is not required right now. What you need to predict here is you need to predict the median value of owner occupied homes. So this is similar to price, that is median value occupied by owner. So you can see that in your data set, that is the last column, that is MED-V. Okay, does it seems like a regression column? The last column MED-V, does it looks like a regression continuous column or not? Yes, it is. Yes, it is a continuous column. So that is our dependent variable. And we would take here randomly. We would take here randomly one column. Let's say, let's take LSTAT. That is percentage of lower status of population. How much is the lower status population? Like 4.9%, 9.14%. So this is one column. So what we are doing? See, pay attention. I am using here the column that is with the name LSTAT. Okay, this is my independent variable. What do you mean by independent variable? Like X or Y? Very good. So this LSTAT would be our X variable. Independent variable is it's X. And our dependent variable here is the MED-V. That is our dependent variable. And that is Y. Perfectly right. First of all, in this data set, you want to predict. Okay, let's move to the data set here. Let's go to the Boston house prices. Basically, in the context, they mention everything. So each recorded data set is from Boston subtown. The data was drawn in 1970, very old. Okay, and you have all these columns. Basically, we see that the input attributes are a mixture of units. So let me just see that if they have mentioned it somewhere. Okay, let me just show you this part. So this median value, I'm just trying to explain you. Calculations are the round off of nearest occupied a housing unit, owner occupied, if it is, yes. So basically this median value of owner occupied, this is like the price of a house in thousands of dollars. Basically, it is another way to represent the house price. Okay, I was just seeing the definition. If I can explain you that definition, median owner occupied house, let's write here definition. What does this mean? If we get a simple definition, value is responded estimate of how much would you sell it for sale. See, this is what I was explaining you. Basically, this is another terminology that is used in house price prediction. So median value of owner occupied housing units, this is another way of saying the sales. So this is basically the price of your house, the another terminologies. For example, you say sorry and you also say apology. So same way like that, you have price and then you have median house. So that's the reason we are using dependent variable as this. And rest all the things would be independent. And majorly when you use Kaggle, they clearly mention that which would be what you want to predict. And whatever you predict, that becomes your target variable. But in this, as this median value of owner is the another thing of price, that's why they have not mentioned it. Okay, so we got independent and dependent variable. Extract the two above columns. Okay, so you have like a data frame of 14 columns. I want you to just extract these two columns and place that in front of me. Write a code to extract the two columns. These two columns you need to extract. You can just store that in X and Y. So my X is equals to data frame name, that is df. And what we have in X, we have lstat. So I would just take here lstat. Same way for my Y, I have df and the column name is just mid b. So you got X and Y is ready within a second. You can check the size of it. Both of them would be exactly the same now. X dot shape, you would see 506 values for X and same way for Y also. Now you can import matplotlib and see this as well quickly. Import matplotlib.pyplot as plt. Okay, and you can just do plt.scatterplot, and in scatterplot we would just do here X comma Y. That's it. So you would get a matplotlib stuff. So I'm going to explain you that what is train and test split. Okay, so basically train and test is like your exam. So whatever I am teaching you right now, okay, just understand everyone. I explain you something in class. For example, I am explaining you 2 plus 3 in class. In your exam also, do you get 2 plus 3 only? Perfectly not, right? You don't go get that. So training is something where you understand the concept. So I explain you 2 plus 3. But in your testing, you can get 3 plus 4 or something like that. Similar to it, but not exactly the same. That is testing. Why we do this? Why do you have exams? Practice to test our knowledge. Testing. Correct? Yes, it is used to test how much we have learned. For example, now Venkata, in my training, I have said 2 plus 3 is 5. Now let's say if he has memorized that 2 plus 3 is 5. And no matter if I change here like 3 plus 1 or like in training, in testing also, if I give exactly the same thing to him, 2 plus 3, this same thing if I give him in testing also. And we don't know that whether he has memorized 5 for every answer he's saying, let's say 5. So this is not a good testing. Good testing is always on unseen example. Correct, everyone? Like Ratana, like mugging up. When you don't do the mugging up, that is the correct test, right? Everyone agree? You remember the Chatur from 3 Idiot? Perfectly right. Yes. So that's the reason our model should not get like, it should not mug up the data. That's the reason we do a train and test split. What we do? We basically, if we have 500 data points, we divide this 500 data points into 80 and 20 split. So we divide 500 data points. Let's consider 500. We divide this 500 data points into 80% of them and training. So I would train on 80% and on 20%, I would just test it. This is the perfect example. Yes, logistic regression. This is the perfect example of train and test split. So same thing we do here. We divide our data into train and test. We only train on the train part and we test on the test part. So now from sklearn.model selection, we are going to import train and test split. Now see, this is the function ready for us. You don't need to worry about it. Model would automatically divide your data set into 80 and 20%. So you need to import this. Wait for it. I'm going to give the time for you to code first, understand it. Now we need 4 variables here. First is x train, comma, x test. Then we have y train, comma, y test. Now what does this mean? Let's understand that. First, I would complete it, train and test split, and inside that I would put our x and y. So x comma y, and I want the test size as 0.2. Let's understand what this big line, what does this mean? It's very simple. See, I have, okay, in my complete part, I have x and I have y also. In my x, I have that lstat, and in my y, I have mdiv. Now what I do, I say that train and test split of X and Y. So it would do a train and test split of X and Y. I am saying that the test size should be 0.2, which means 20% should be test size. 20% from here, 20% from here. Basically, now if you pay attention, you got 4 things. Pay attention. This is your first thing. This is your second thing. This is your third thing. And this is your fourth thing. Yes, we got here 4 parts. The first part is called as X train. We train on this big data, that is 80%. Then this 20% is called as X test. You see the 2 things, X train and X test. Same thing we have for Y. This bigger part is called as Y train. And this smaller Chintu part is called as Y test. So you would have some values in X train. That is, let's see the shape of it now. So we would just do here X train dot shape. You would see there are 404 values in training. Okay, yes, I am showing you that only. And X underscore test, the size of it is 102. So out of 500, yes, 102 is 20%. So 20%, 100 examples are there in testing. It's just random. See, in X train, there are some random values. In X text also, you would have some random values. Now, exactly what thing we have done in the session, the same thing we are going to do now. That is, we are going to import sklearn from sklearn.linear model. Okay, now, before I move to this part, everyone do this step and just write done after that. Okay, so run these 2 things. Okay, run these 2 things and check the shape of X train. If you are getting 404, yes, perfect. Now run this command. Just change X and Y if you have used something else above. Okay, if you have not used X and Y, just change that. Rest, everything would remain same. Yes, perfect. Okay, now just do the last thing here, X dot shape. Are you getting 404? Yes, perfect. Now from sklearn, we have imported linear regression. We would create an instance of it using reg equals to linear regression. Simple. The most easy step in complete machine learning, you just need to do reg.fit and you need to give your X train, comma, Y train. That's it. So the moment you do that, your model would be fitted within a second. So it's showing that the shape. Okay, let me see what's the shape issue. X train and Y train, the shape issue. Yeah, it should be comma 1. Okay, so you need to reshape it. Just a second, so that this error is solved. Just a second. Okay, let's try this. This is one of the small error, X train dot reshape. So what is your X train now? X train, the type of it. Yes, it's a series. So we need to convert that into, just a second. It's a data frame. We need to convert that into data frame. Maybe here it was not a data frame. Yeah, so I think we need to do it like this and our problem would be solved. So we need a data frame, not a series. Okay, now we got one. This one is important, else you would get the same error. So we have plotted this again, nothing else would change. Sklearn X train word. Now this shape would change automatically to 1 now. See, 102, 121, and our problem is solved. Basically, it requires the sklearn requires a data frame, not a series. That's why we were getting the error. Let's run it. So we got our model fitted within a second. So reg dot intercept. So you would get the intercept of it. What is intercept? Intercept is C. Same way, if you want to see the slope, you just need to write here coefficient and you would get the slope for it. So you got slope, you got intercept. Now you would find the predicted values only on the test data. So reg.predict. So like you have reg.fit function where you train the model, Using red dot predict, you predict on the test data set. So you have x underscore test. Okay, we would store that in a variable called as y underscore predictions, which means that these are your predicted price on the testing data. This data model has never seen. Okay, and model is predicting on that. So we got y predictions. These are our y prediction. Let's see that. So y model is predicting 24, 8, 22, 11. Let's see the actual values of y. So you can do y underscore test. These are your actual values. And it is 19.3. It is 24.9. So something similar, but not 100% similar. Let's find here our R square. Everyone ready for it? R square. Let's see how our model is performing. Yes. So we would take R square from what we have seen before, the same line, so that we don't need to write that once again. R square, and we would just do here R square. Okay, and inside this we would just mention simple thing, that is y test, comma, y predicted. So all the calculations that you have done on this stuff, okay, and then you have calculated R square. Now within a second you would get that on your screen and see it is 0.49 R square. This is your simple linear regression. Now, what does this 0.49 R square means? Someone asked me how to interpret R square. So let's understand this with an example. Okay, I have a very good image for it. Let us take that R square image so that you can understand it better. Yeah, we would draw it by our hand. Okay, now how to understand R square? Let's see that. So basically you have a line like this. Let's say if this is the thing. Now your R square, this is R square equals to 1. The maximum value of R square can be 1. And the minimum value for your R square, let's say you have this type of data. The minimum value of R square that you can have is R square can be minimum to be 0. Let's say this is 0.1. The value when it is very close to 0, which means that your model is very, very, very bad. Your model is really very bad, then your R square is very low. This is how you understand the R square. More close it is to 1, which means that more better model you have made. Correct? Yes. Now R square you can consider as your school percentage, like 0 to 100. If it is very close to 0, which means that you did a very bad job. So now we got here 50%, which means that our model is 50% good. Now let's try to do the complete exercise on multiple linear regression and see what difference we can create here. So I'm going to do exactly the same exercise on multiple linear regression. Now see how simple it is. If you have understood simple linear regression, you would understand multiple linear regression in the same way, in a simplest manner. So same way we would take the data set, the same data set that we have. Okay. Now in this data set, in multiple linear regression, how many independent variables are there? How many independent variables? More than one. That's correct. That is more than one independent variable. It is called as multiple linear regression. So I'm saying that df.ilog, I want all the columns, all the rows, comma, all the columns, but not the last column. That is my x. Okay, let me explain you. Okay, so I'm going to explain you. Basically, I have a trick for it. It's very simple. In ilog, basically you mention two things. There is a comma. Before comma, it stands for row. Okay, before comma, it stands for row. After comma, it stands for column. Like when I say NumPy and Pandas, I explain this very easily. So that's the reason I'm explaining once again. Before comma, there is row. After comma, there is column. So see here, before comma, there is dot dot, which means I want all the rows. And after comma, there is column, and which says like till last column. I want every column, but I don't require the last column. So in my X, I have removed the last column. And in Y, I have said only I want the last column and all the rows. Now, once we got X and Y, our rest of the things would remain exactly the same. We would take our train and test split. Okay, where we would just do X and Y in the same way. We got X train and Y train. You can check the shape of it. X train dot shape. Okay, 404, perfectly correct. But this time there are more columns. Once we get that, now see, even the implementation of linear regression is exactly the same. I don't need to change anything here. And my model is fitted on all 13 columns now. That's the power of linear regression. You can see the coefficients now. Can you guess how many coefficients would be there? Quickly, everyone, can you guess how many coefficients would be there? When you had one independent variable, there was one coefficient. Now you have 13 independent variables, you would have 13 coefficients. You can check the shape of it as well. Dot shape, and there you would see 13 coefficients. So your equation here is something like this: y equals to m1 x1 plus m2 x2 plus m3 x3, and it would go till m13 x13. How many intercept would be there? No, understand, intercept would be only one, because the equation of line is plus c. See, understand the difference between multiple and simple linear regression. In simple linear regression, you have y equals to mx plus c. In multiple linear regression, you have m1 x1 plus m2 x2 till m13 x13. Okay, plus c. So c is always 1. What we are going to see? We are going to see how our model is predicting. So we would do the same thing. That is, we would predict it on the test data set. So where is our text? Here is our test. So here is our test data set predicting on that. And then we will calculate the R square once again. Now see, did you see the R square has increased from 50% to 72%? This is your complete linear regression. Linear regression live demo for that. Completely we have understood here, step by step, everything. Now logistic regression. Logistic regression is a classification algorithm. Where you are going to classify the things into category. That is the first point. What is logistic regression? Second is deal with categorical dependent variable. See, this is very important point. Categorical dependent variable. Now, what do you mean by dependent variable? So now, yes, dependent variable is something that is dependent on another. Like in y equals to mx plus c, which is the dependent variable? In y equals to mx plus c, which is the dependent variable? Perfectly right. Y is the dependent variable. Now, if your y is categorical in nature, keep in mind, see, this is how you understand the things. If your y is categorical in nature, then close your eyes and apply logistic regression. It is as simple as that. Now, could be binary, could be multinomial. Let's understand it. Okay, let's understand it word by word. Could be binary or multinomial. Now, what does this mean? Multinomial or binary? Basically, you can classify here binary things. Binary things means that has only two values. Bi stands for 2. So yes and no are two values. Yes, that is 1 and 0, you can say. It can be any other two things. Like, let's say if I want to distinguish whether a person is tall or short, again, it is a binary thing. Wherever you have two things, it is a binary. Multinomial, you have more than two things. For example, you have, yes, true and false also is an example of binary. In multinomial, let's say you are distinguished between a cat, a dog, and an elephant. Anything that is greater than 2, it is called as multinomial. So your logistic regression, see, now keep this in one thing in mind. the original form of logistic regression only works on binary classes. There is one technique called as OVR that we are going to see today. It's not there in your agenda, but we are going to see that in 100% detailed manner so that you understand what is multinomial as well. So OVR is something that would handle multinomial. So this is your complete logistic regression all about. Tools for applied statistics gives outcomes in probability in terms help you in classifying the data. Now, what does logistic regression does? Okay, let's answer the next question. What logistic regression does? What logistic regression does? Logistic regression would give you a probability. Logistic regression would give you a probability that would help, this probability would help you to classify the categories. Exactly, that was our problem statement, right? We want to classify the categories. Yes, we want to classify the categories. Categories can be simple binary or multinomial. Anything it can be. And probabilities would be going to help us with that. Now, we have done a lot of buildup of logistic regression. Akash, now can you jump to logistic regression? Yes. Let's understand it with a very, very interesting example. Spam email classifier. Very interesting example. So now all of you have seen this spam email classifier. Let me open that and let me show you that. So let's open this. So I'm opening my Gmail here. So you would see that in Gmail, you have an option here of spam mails. Now see, I have not said that this mail are spam for me. Okay, this something Elizabeth, the Paytms, they are sending me the mails, and automatically Google has recognized that, okay, bro, this is spam mails. This mails I have never read. And you don't know how many mails are already deleted from here. So we are going to understand a real case study problem, a classification problem we are taking in, where a model decides whether a mail is a spam mail or a non-spam mail. Now tell me whether it is a binary problem or it is a multinomial problem. Akash, so simple. It is just two numbers. It's a binary. Perfectly correct. 100% correct. Let's frame this problem and understand it. First step is to understand the variable. You know that we always do these steps. In linear regression also we have done it. Now we are writing here the steps. So let's write down the steps here. Yeah, continue now. So we have some steps. Basically, the steps are very simple. That first we understand the variables. We understand the variables here, whatever the variables we have. Understand the variables. What does this mean? Understand the variable. For example, in linear regression, we were having two variables. The first one was the price, the size, the square meter area of the house, and then it was price here on y-axis. So if I increase the square meter area, my price was increasing. We know that what is square meter area and we know the price. So we basically know, we know the variables. We have understood the variables. First point. Second point here is to plot the variables. Second point is to plot the variables. That is the second point, which means that we would take a simple plot like this and we are going to plot it. Then we draw a regression curve. Now here is draw regression curve. Now basically in that it was a regression line. We used to draw a line. Now here we are going to draw a curve. Step by step, very simple. Ki pehle samjho. Okay. Then banao. And then we plot the line. Then we find out the best line. Okay. Now we find out the best curve here. So can you tell me what was the ways to find the best fit line? Do you remember? Try to write it and explain me how did we find the best fit line? R2, R square. So going back to a little bit step, understand here there are two different things here. Don't get confused. R square was used to find how good your model is. How good your model is. So basically, if it is in 0 to 1, if it is close to 1, yes. Now, second thing, you had RSS. What is the full form of RSS? Okay, residual sum of squares, RSS and TSS. Now, this RSS helps us to find the best fit line. How we used to find that? We used to find the residual. What is residual? It is an error, that is actual value minus predicted value. So let's say Ekansh is predicting that the house price is 7 crores, but the actual price is 10 crores. So he made an error of 3 crores. Then we take a square of this. Why we take square? We need to magnify the big errors and to make it positive. So we take the square of it and then we sum all the values. That was RSS. With the help of this, we find the best fit line. Now, in the same way, you can't use the same algorithm in logistic, but we are going to follow the same type of approach to find the best curve. So you can see the best curve here. And we need to find how good that curve is. Let's get started now with spam versus email classifier. Okay. So now here is my data. Step 1 is what is my independent variable? Now, like you have independent variable in y equals to mx plus c. You have x as your independent variable. So x was your square meter area. Sometimes it was number of bedrooms in your house, the garden area in your house, number of pools in your house. This was your x. In this spam classifier, we have count of spam words. Like what are spam words now? Think from a human perspective. If in your mail is something like that, you are a winner, okay, of just understand a spam mail. What's there in maximum spam mails? Like you are a winner of $10,000. Okay, you get a guaranteed reward. Yes, prize money. Very good, Krishna. Lottery. Okay, unlimited offer, something like that. So these are all the some of the common words. There can be like millions. There is a list. There is a very huge list of all these common words. And what is your independent variable? The count of a spam words. Let's say Mahesh sent a mail to me. And in that mail, there are total, let's say, 70 words in the mail. And out of that 70 words, 35 of them are belonging to spam words. Do you think this is a spam mail or not? Probably yes. I'm not 100% sure, but yes, there is a chance that this is a spam mail because around a very big count. See, my count is helping me to predict whether it is a spam mail or not. Can you be 100% sure here? No, there is a probability associated with it. Like I am 90% confident, yes, that this can be spam. If the number is very less, like only one word is there, can you be 100% sure it would not be a spam mail? No, you would be like around, let's say 95% sure it is not a spam mail. You cannot be 100% sure. It's a probability thing. So the first and the foremost thing is independent variable. Let's write it down. So we have the first thing that we need to keep in mind is we have a independent variable. And what's our independent variable? It is a count of spam words. Count of spam words. Okay, and the spam words can be, you know, that it's a lottery, it's a winner, Okay, prize money. These are all your spam words. Okay, now the next step. Dependent variable. What is the dependent variable here? Think from a logic perspective. Here we need to predict the probability, because whenever it is a classification problem, you cannot be 100% probable. You cannot be 100% probable. 100% probable means that there is a no choice of happening the another stuff. For example, if there is a coin, it has heads and it has tails. What is the probability of heads? 0.50%. Yes, everyone knows that. But now let's say I give you a coin that has both the sides heads. Then what's the probability of getting a heads? 100%. So whenever a person says that I am 100% probable that heads would come, which means that in a coin there is no other side. So it's a probability now. Probability is 1 and 0. 1 means a spam mail and 0 means a non-spam mail. We have just done this coding because like encoding, because probabilities are always in the range of 0 and 1. Let's write it down. This next step for us. The first step is independent variable. The next step is dependent variable. Dependent variable. Now, what's the dependent variable here? We are going to predict a class. Predict spam or non-spam. So again, we are going to predict the probability for it. So for spam, we are keeping 1 and for non-spam 0. This basically are your probabilities. And you know that there is a rule in probability that it cannot be greater than 1, it cannot be less than 0. It's very simple now. You can see that if the count of the words are very less, like 0, 1, 2, 3, 4, 5, it is non-spam. But if it is 5, 6, 7, 8, 9, 10, there is a high chance that it is a probability. That is a high chance that this is a spam mail. Let's understand this much more better. If in a mail you have only 2 words that are spam, so you have 0 probability. Around 0, okay? So we are just giving 0 means that it's not exact probability, it is just a class that it is a non-spam. Now imagine the scenario, my business, let's say Savita is asking me that this mail is spam mail or not. And I'm saying her that it's 0.3. She would say me that don't give me this 0.3 and 0.1. Tell me directly whether it is spam or not. So 0 means non-spam. So if your word count is very less, it's non-spam. 1 means that it is spam. 8 again spam. 1 means non-spam, like this. Now, this is our data set. This is our data set. Just a second. Yes. So this is our data set. Once again, I'm explaining you what's our data set. We have independent variable. What is independent variable? This is your independent variable. That is, you have a count of words. What is your dependent variable? This is your dependent variable. Dependent variable has only 2 things, 0 and 1. Dependent variable has only 2 things, 0 and 1. Independent variable have a lot of things like 1, 5, 3, 2, 7, 8, 4, 9. Let's plot independent variable also. See, here is your independent variable. So you have here 1. So let's consider this is 1. This is 3. This is 5. Last one contain 8 words. It's a non-spam. Wait for it. Wait for it, Ragul. I am explaining you. 1, 3, 5. So we have plotted this. Then this is 8. 1, 3, 5 is done. 2. So this is 2. Okay, it's somewhere here. 4 is again 0. Okay, let me draw that just a second. So this is 1 is 0. So this is 1. 5 is 0. So this may be perfectly 5. 5 is 1. Sorry. Okay, just a second. I'm just plotting this. So we have 1 here, that is 0. Then 5 is for 1. 3 is for 0. 2 words. So this is would be 2 now. Then 0 is 4. So this is 4. And this is your 8. So we have plotted all the zeros. See, 8 word 0, 4 word 0, 2 word 0, and 1 word 0. So we have just do a simple plot, nothing else than that. Then for 1 also we have done the same thing. 5 is for 1. So this is 4. So this would be definitely 5. So this is 5. We have 3. So this is definitely 3 somewhere in middle of this. So you have 3 here. This stands for 3. So 3 is also done. 5 is also done. Then 7. So this is 5. So this would be 100% 7 then. This is 7. And now you have 9. So this is your 9 somewhere here, which is 1. There are 8 words here. And these 8 words are spam words. Don't you think it should be in the spam mail? This is the data set that is given to you. Understand the difference. What does this mean? This means that Ragul got, what does this mean? This means that Ragul got 10 mails. Okay, Ragul got 10 mails. Now in this 10 mails, basically, these are the word counts. Okay, now see, this is basically Ragul got 10 mails. The first mail that he got, in that first mail, only 1 word is of spam word. Then second mail, he got 5 words. Then third mail, in this way, he got a lot of mails. Now, Ragul has read all this mail and then he has given a label for it. That, okay, bro, Akash, the first mail is a non-spam mail. Second mail is a spam mail. Third mail is again a spam mail. So he doesn't care about the words, whatever the words are. That is something totally independent. Right now, we are just labeling it. Imagine that I give you a task that open this 10 mails and label it 1010. For you, it doesn't matter how many spam words are there. So in a mail that is non-spam, there can be 8 spam words, but the other words are not spamming. So if I'm saying you that, okay, you won a lottery ticket, but that is not a spam. After that, I have given you some, let's say, a coding material. I have given you something. Just to grab your attention, I have put that. Not in word count spam. So now we have plotted it, means there are 8 spam words, but it may contain 2 important words. That's fine. So there are 8 spam words, but there can be more non-spam words. And that's the reason it is showing non-spam. There can be 2 non-spam words. There can be 200 non-spam words, whatever it is. But the final output is, it is a non-spam. Now, after doing this point, what we are doing, we are saying that, okay, we have here, see, on this graph, we have 2 values, 0 and 1. Now we kept a threshold here, 0.5, which means I kept a threshold of 50%. So if Krishna says that I am 51%, I have a 51% probability, which means that it is greater than 50%. So I would say that anything that is greater than 51%, it's a spam. And anything that is less than 51%, I would say that it's a non-spam. So this is basically, we have kept by default, this is a threshold. You can change this, but I am writing that here by default, the threshold is 50%. You would understand that much more better. Now, what's our task? Our task is to fit a regression curve, which would be a best fit line here. Now, you cannot put a regression line here. See, if you put a regression line like this, you would find that these points are very far away, these points are very far away. So a linear regression line cannot go here. What is called a best fit line? The line that passes through all the line that passes through all the males. The line that passes through all the points. It is called as a best fit line. Everyone remembers that? Now, if I give you a data set, okay, if I give you a data set like this, which is points are like this, and I say you that, okay, tell me whether this yellow line is best fit line or this blue line is best fit line, what would be your answer? Yellow, perfectly correct. The line that passes through all the point, line that passes through all the points. Now, just one thing here. So, okay, Akash, if that is the case, we can make a line something like this, something like this, and something like this. We can make a line like this, a step type of line. Why we need to make a curve? No, you cannot make a step like this. This is called as a step function. See, understand the difference between a step and a curve. So there is a very huge difference. You are going to learn gradient descent with me. At that point, you would understand the concept of derivative. In derivative concept, you would understand that this is something which is not acceptable. For now, forget about it and make sure that in logistic regression, we take help of a curve and not this type of a step function. We make help of the curve. So now our complete rest of the 2 hours would be just to find this best curve. So Akash, how you said that this curve is best? Now, why not this curve is best? Not exactly like this. Why not this curve is best? Why not this curve is best? Why not this curve is best? Okay, we need to find that. Basically, our end goal is to find the best sigmoid curve. And that curve is called as logistic regression curve. So our next complete scenario, 2 hours, is completely spent on to find a best sigmoid curve. Now, like RSS was used in linear regression to find the best fit line. Okay. Now you have an algorithm that is called as very, very difficult name it is. Maximum likelihood estimation. Very big definition, very big algorithm. But now you would understand this algorithm in such an easy way that you will never ever forget this. Okay, we would make it really very simple for all of you. So let's get started with the first point of it. Now, how you are going to do that? Now there are steps for it. The first and the foremost thing here is we would take here the help of log odds. We would first understand here the logs part. What is the use of logs? What is the use of log odds? So logs is used for transformations of big numbers. Transformation.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Of big numbers. Now, what does this mean? So let's say you have a very, very big numbers. For example, let's say you have 100. Now, how 100 can be represented? This 100 can be represented as, so you can write 100 like this, log 10 to log base to the 100. Okay. Now the value for this is 2. How does it came to 2? Let's understand that. You can write log 10 and 100 you can write as 10 square. Now this thing can be written. Now these are the properties of log. This 2 you can say it goes down here. So it becomes 2 log 10 10 because this 2 goes down here. And log to the base 10, basically it is considered as 2 into 1. So that becomes your answer 2. So see that a big number 100 is converted to 2. Same way, if you have 1000, that would be log 10 to the base and 10, 3 here like this. So it would automatically become 3 here. Same way, 10,000 would become 4. 1 lakh would become 5. So this is C, transformation of big numbers. This is what I was explaining you. So whenever you want to change a scale, imagine that you have a very big scale, which is like 10, then 100, then 1000, then 10,000, like this. It is increasing. Instead of using this scale, you would apply log of base 10 here, and you would get a scale which is in the range of 1, 2, 3. Okay, this is very important because let's say your x values are very small. So the representation here becomes very difficult. In short, to summarize, log is used for transformation of big values. There are many other use cases. This is one of the use case. Now let's understand a concept of called as odds. This is very, very important. Now, what is odds? You might have heard this word sometimes, some or the other way. Can you tell me where you have heard this odds? In cricket betting, it is used a lot. In probabilities, it is used a lot, odds. Odds is a ratio of, very simple, it's a ratio of probability of success to probability of failure, that is 1 minus success. So basically, let's say we are saying that the odds are in 4:1. Our odds are 4:1. So the first part, the numerator stands for winning, and denominator stands for losing. So if we say that India has the odds of 4:1, which means that there is 4 times more chance of winning. There is 4 times more chance of winning. So this is how you understand the odds. So let's consider we have 5 chances. Okay, let's understand it. We have here odds and log odds also. Let me write that. Yes. So let's say this is probability versus odds. Let's understand that. What do you mean by probability? The guy went for fishing 5 times a week. What's the difference between probability and odds? So this person went for fishing 5 times a week. He caught fish 2 times and 3 times he came home empty hand. So 2 times he caught the fish. What is the probability and odds of getting a fish for a dinner? Let's understand this. Both the answer we are going to see today. Probability is favorable outcomes, that is chance of getting a fish, divided by total chance. Which means that 2/5 is the probability for him. Same way, what is odds? Odds is chance for, like I said, probability of success. So success is 2 times. And what's failure? How many times he has failed? 3 times he has failed, not catching the fish. So 2/3 is the odds ratio. So here he has more chance of failure. That's why the denominator is high here. That is called as odds. Now, these are very useful here right now. You would not understand how it is useful, but you are going to understand when we are going to see the problem for it. You can see more examples for it. Okay. We would understand here log odds and odds more in detail. Okay. Now, what we do, the first thing is we convert the log odds here into probabilities. Basically, we have this probabilities. We would convert that into log odds. See, this is the log odds scales. Let's try to understand that. Okay, just give me a second. Yes. So now let's try to find out that. So we have understood what is odds. On top of it, we apply log odds. Just understand what steps we are taking. The first and the foremost thing is we take log odds. Log odds formula is same. The log, what's the odds formula? The same formula. Probability of success divided by 1 minus probability of success. That is failure. Now, just see this. We have this curve here. Okay, we have this curve. Where our curve went? Yes. So you can see that where it is. Yeah. So we have a curve here. Let me take that curve so that I can explain it. Yeah. So we have this curve. This curve has values like this: 0.5, 1, 0. Then in somewhere here between 0.25, 0.3, 0.4, like this. These are the probabilities. Pay attention. These are the probabilities. Now we convert this curve into log odds part. How? We would just put the probabilities here. So log of probability, let's put it 0.5 here. 1 minus 0.5. So that is log of 0.5 upon 0.5. That is log of 1. Okay. Log of 1 is basically 0. So that's the reason you can see here, when we convert this curve, you got a 0 point here. So 0.5 is changed to 0. How we change it? We just applied a log odds here. What's the formula for log odds? We would just do P upon 1 minus P, and we put that in log. So P value is 0.5 in between. So when you put 0.5 upon 1 minus 0.5, that would be 1. Log of 1 is 0. So you got here 0. Is this part clear? First of all, everyone, that we are converting this curve into this straight line. Same way, when you put the more values inside it, okay, for example, in the same formula that we have, log of P upon 1 minus P. Now in this, we have put here 0.5. Let's put something 0.73 here. Okay. So if we put here 0.73 upon 1 minus 0.73. So in this way, when you would put into this, so it would be 0.73. So 0.73 upon 0.3. When you would solve this, you would get, let's say, 1. So one value you got 0 here. Then you would get 1, then you would get 2, then you would get 3, like this when you keep putting the values. Let's say Ragul says that put 1 there, Akash. So log of 1 upon 1 minus 1, that is 1 upon 0. Now this 1 upon 0 can be written as log of 1 minus log of 0. Your log of 0 is basically minus infinity. And minus minus, this gets plus. So you would get a plus infinity there. So pay attention. Any points that are on 1, that are plotted here as positive infinity. Any points that are on 1 are plotted as positive infinity. Same way, any point that is on 0, you can put that log of probability 0 now, 0 upon 1 minus 0. So that is 0 upon 1. So that is minus infinity. So any value that is in 0 line, it is in minus infinity. Coming to the next part, we have understood this. So our first step, so I'm writing here the steps also. So our first step, what was it? We have not written the steps here anywhere. Let me write that. Okay. So the first and the foremost step is to take a random curve. Okay, like we have taken. So basically, we would just convert it into log odds. You convert your probability to log odds. Now, why we do this? This I have kept a question mark for you right now. At the end of the session, we are going to see this. But this is our rule. Let's consider that we convert probability into log odds. That would give us the value from minus infinity to plus infinity and a straight line joining that. Like we got this here. Now, we need to again convert this Okay. Yes. Now we need to again convert this log odds into a curve like this. Basically what we want a curve. How we will get a curve? First, we would plot a single straight line. First, we will plot a straight line, and then we will convert that straight line into a curve using sigmoid function. What is sigmoid? We are going to see that. So our first step is to take the data set and convert it into log odds. Second step is to take the log odds, that is your straight line. You would take that from minus infinity to plus infinity, and you would convert it into a classification problem 0 to 1, that is a curve. The next step, what they do is they plot these probabilities on this line, and that line is converted to curve. How a sigmoid function works. The only question mark that we have is, this is very clear. We have put the values in the formula and we got that. Now the only major important question is, Akash, how a sigmoid function converts a line to a curve, and that too the curve in 0 to 1 range, because this was from minus infinity to plus infinity. Yes, let's understand how it does that. Okay, now this is the equation of sigmoid function. Let's try to understand how this equation came. E raised to power x upon 1 plus e raised to power x. Let's understand that. So simple mathematics is there. I'm going to frame that mathematics in front of you. So we have log of, all of you know this formula, p upon 1 minus p, that is called as log odds. This is the formula for log odds. Now what I do here, basically when you want to remove this log, okay, you can apply here the exponential. So you would get here this e and this log get cancelled, so you can say that, and here it remains p upon 1 minus p, and here it becomes e raised to power log odds. Basically it becomes e raised to power log odds. For simplicity, we would write this log odds as x, so that we don't need to write again and again this log odds. So now what we have p upon 1 minus p equals to e raised to power x, where your x is equals to log odds. Now we can just multiply this. This is the next step. Okay, pay attention. You don't need to do this maths. You just need to understand this maths. Now the second and fourth class maths, this 1 minus p goes into multiplication here. So p equals to e raised to power x into 1 minus p. Then again, second level maths, this e raised to power x is multiplied inside this both. So it is equals to p equals to e raised to power x minus p into e raised to power x. This e gets multiplied inside the bracket. Now you have here this minus goes into this plus direction when it goes towards equals to side. So p plus p e raised to power x equals to e raised to power x. Now we take p common from this. So p gets outside and we have 1 upon 1 plus e raised to power x equals to e raised to power x. Now this 1 plus e raised to power x goes into denominator. So your probability equals to e raised to power x divided by 1 plus e raised to power x. This is the exact same formula we were talking about, e raised to power x upon 1 plus e raised to power x. Understand what we are doing here. This steps are not important for you right now. This is a simple mathematics. The most important thing for you right now is that we took the log odds. This x is log odds. We took the log odds and pay attention. We took the log odds. This is our log odds, and we converted them into probability. See, this is your probability. P is your probability. E raised to power x upon 1 plus e raised to power x. So when you put the log odds into this, you would get a probability. Basically, you would get this curve. That's the complete understanding of your how a log odds is converted into sigmoid curve. So basically, this is your sigmoid curve where you take the log odds, put that into a sigmoid function, and you would get the probability of your males. What does this mean? So this is the formula E upon. So now guys, for your understanding, what we did, we just simply derived this formula, that is P equals to e raised to power x upon 1 plus e raised to power x. In that we put the log odd stuff. Okay, we put the log odd stuff and we get the probabilities. Same way you can put it for all the values, like for minus 2.1 we have kept. Same way you can keep it for, let's say this is -1, this is minus 0.75. In this way you can put the values and you would get the curve here. So for this minus 2.1, we got a 0.1 as probability. For this, we would get around 1 as a probability. So that is your sigmoid curve. See, we have kept here minus 3.2. And we got, when we do all the multiplications and all that stuff, we got here 0.03. So that is a probability of a male classifier. Same way, when you put a 5.6, this value, okay, that is converted to 0.99. So that is on the top. Same way, when we put this one value, it goes to 0.01, which is very low. So in this way, we are plotting all the values. So now let me summarize what we have done up till now so that you are having a crystal clear idea. We had a simple data set where we have 0 and 1. We have some points here. We have some point here. We apply a log odds on top of it. So that would give us a line here. But the problem with this line is we have minus infinity and plus infinity like things. So we apply log odds and we get a line. Now this line have minus infinity and plus infinity. So we use a sigmoid function here. Okay. We use a sigmoid function here and we get basically this curve. We get this curve. Now, this curve, basically, when you put all the values here, basically this infinite values, when you project that on a line. For example, this, when you put that here, you get minus 4.5. You put minus 4.5 here, e raised to power minus 4.5. Then upon 1 plus e raised to power minus 4.5 in the same way, you would get something 0.01. So you plotted the point here. In this way, you got this complete curve. Basically, this curves give you the likelihood. What do you mean by likelihood? Likelihood simply means the chance. So your sigmoid curve, pay attention. So your sigmoid curve would tell you the chance of a thing happening. Sigmoid curve would tell you the chance of something happening. What does this mean? This means that, for example, Shubham says that the likelihood of today's session that it would be very interesting. The likelihood is 0.9, which means that there is a 90% chance today's session is interesting. So same way, for the first mail, the likelihood of being a spam. Okay, pay attention now. For this first mail, the likelihood is 0.01, which means that there is 1% probability that it is a spam. Then for second mail also 0.1 probability. Third mail 0.03 probability. Fourth mail it is 0.5 probability. Fifth mail it's 97% chance that is a spam mail. Then sixth, seventh, eighth, ninth. This is basically your likelihoods. Now what you do, you basically multiply this likelihood. Let's understand what does this mean. So for example, we have this line. This is minus infinity to plus infinity. Shubham did all the things of sigmoid here. He applied the sigmoid and he got a curve here. Let's understand this curve. So for example, In linear regression, if you want the square meter is this, if you want the price, you used to predict here and you used to predict here, right? And you used to get the price, correct? Now for same thing goes for your logistic regression also. So if you have a count somewhere here, you would project that on the point and you would project it here, which means that there is a 0.3 probability that it belongs to spam class. 0.3% probability that it belongs to spam class. Same way, if point it somewhere here, you would plot it here and you would see that there is a 0.9% chance that it belongs to class 1. Now what we do, all the males that we have, we take each of them probability, okay? We take each of them probability, like the probability of first male, the probability of second male, probability of third male, like this. We take all the probabilities and we multiply them. So it is not drawn here correctly. Just a second. Let me explain you this part. Okay, now, so basically the values that are belonging to class 1, you want that their probability should be very, very high. So if you have a curve like this, let's understand this logically. You have some points here and you have some points here, let's say. Now, you want that. So for example, I have drawn this curve. Let's say that. According to you, is this a best curve? How this is a best curve? Tell me. Now this is 1. If I draw a next curve for you, which is like this. Now, which curve is best? The second one or the first one? Second one, everyone agrees. So this is not the best curve. Okay, why you said this is not a best curve? Because now this curve, this distance is reduced, correct? Yes, perfectly right, which means that the curve that is passing through all the points. So what we want finally, we want that the points that are belonging to class 1, the points that are belonging to class 1, they should have the highest probability. Like they should be close to 1, correct? As this probability is less, this is not good. It needs to be highest, correct? Everyone agrees with me? Yes, that's correct. So whenever you want, so this probabilities was 0.7, you want that it should go to 0. Like this should go to 1. So the values that belongs to class 1, you multiply them as it is. It's like 0.73. Okay, for example, let's remove over this curve, and this, and this. Okay, now what we did all the same steps. Like we took our data, we apply the log odds on top of it, and after doing the log odds, we have applied a sigmoid function and we got this curve. Now we want to find whether this curve is best or not. How we are going to find out that? Pay attention. Very, very interesting it is, and it is the last part. So we would plot the probabilities here, this probability here, and we would plot it here. This probability on this curve, we would plot it here. This probability on the curve, we would plot here, and this probability on the curve, we would plot here. So let's consider this values are 0.7 into 0.8 into 0.99 into 0.9. Let's consider this. Now, same thing we are going to do for 0 pot as well. So we are going to project that on the curve and project it here. So this is 0.3, let's say. So 0.3. Same way, this point we are going to project here and we are going to project here. So it's around, let's say 0.2. This point here, it's 0.17. And this point is, let's say 0.1. But here there is a catch. You would not multiply these values directly as it is. You would subtract that from 1 minus. This 0.2 also you would subtract it from 1 minus 0.2. This 1.7 also you would subtract it from 1, and this 1 also it would subtract it from 1. Why we are subtracting it from 1? Because imagine this scenario that this curve, you are pushing this curve from the downward direction like this. Imagine that Ragul, Bheem, Ayush, this all are pushing the curve from this direction. So just tell me, we have 4 people. Let's understand that. We have here Ekansh. Okay. We have here, let's say, Ayush, Ragul, and Bheem. Now, all 4 of them, if they push this curve on the top, we would get the best curve here if they push it hard. Is that correct? Like if they use their maximum force, they would get the best curve. Yes? Correct. Exactly right. Now, let's say that we have again 4 people. This time, let's say we have Krishna. Now, Krishna is also pushing this curve from the downward direction here. And same way, we have Venkata also. Venkata is pushing also here from the downward direction in the above, okay? Upar push kar raha hai. Same way, we have, let's say we have here Arihant and Mahesh also. Okay, Arihant and Mahesh, and let's say Arihant is also pushing here and Mahesh is also pushing here. So if they also apply the maximum force here, will that be good? No, perfectly not. Imagine that you would get a curve which is something like this. Do you want this curve? No, you want that this 4 people, Krishna, Venkata, Arihant, they should push the curve from the above direction. Yes or no? You want that they should push in the above direction? Yes. The maximum force should be there in above direction. Correct. That's the reason we take it from 1 minus, because we take the opposite direction here. For this positive values, this is upward direction. So we multiply all these values together and we get a maximum likelihood estimation. This algorithm is called as, see, we are multiplying here, we get the likelihood. This is called as likelihood, basically the probability. We got this curve. Now we projected that curve here and we multiplied the values. We multiplied the values. Everyone understood that. And we got this values 0.1, 0.1, 0.3, 0.5, 0.9 like this. We multiplied all these values. The values that belongs to 1, that belongs to 0 class, we subtracted it from 1. And the values that belongs to upper class, we have multiplied that as it is. So in this way, we would get the likelihood of the curve, log likelihood of the curve. That is, the value that we got here is minus 0.04. Okay, which means that after multiplying all the things, we got 0.04. Now, the next thing we are going to do is we would rotate this line further. So one line we got, which was this. Now we would rotate this line further. Again, we would keep rotating the line. And at the line where we will get the maximum, the line where we would get the maximum log likelihood, that is considered as your, again, we will calculate the log likelihood. We would multiply all the things in the same way and we would get the log likelihood in the same way. The point where, okay, so let's understand it. Bheem got the likelihood as minus 0.2 and Ekansh got it as 2. Which one you would select here? You would select the maximum of it. See, understand, that's the reason I was saying you that all of you are applying the force in the max direction. So the value which is maximum is considered as your best sigmoid curve. Okay. So now, logistic regression, we are going to first understand the sigmoid function here. Okay, now sigmoid function can also be written, that was in the logout form, the things that you have written up till now. Okay, this part you have done. So you have written this sigmoid function in a logouts form. Okay, now you can write that also in a same format, which is something like this. So it is equals to y equals to 1 upon 1 plus e raised to power minus mx plus c. Now, when you put the values of mx plus c, you would get the sigmoid curve here. This is basically your sigmoid function, 1 upon 1 plus e raised to power minus x. Okay, let's try to understand this with an example. So you can use the graph equation here and try to understand it. Let's say we use the graph demo. So this is a sigmoid formula as well. When you put that into log odds, it would come out to the same that we have already calculated. Let me close this. And yes, okay. So now in this equation, I would just put y equals to, just your simple y equals to 1 divided by 1 plus e raised to power minus mx plus c. Now see the power of it. Mx plus c. Now, when you add a slider for all of them, you would get a sigmoid curve here. Let's zoom in that so that you can understand it much better. Now, the moment you change the m values, your curve would change. C. And when you change the c value, your curve would again change. Majorly, our major task is in this quadrant itself. This is your sigmoid function. When we zoom in, you will understand that. See. So exactly this curve we were drawing, right? Using all the log odds, doing all the things, we were drawing this curve.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, any value you put inside this mx plus c, you would get this curve itself, nothing else than that. You can try that. Let's try to plot a curve here. So you would write this as logistic regression. Let's try to see that whether we get it or not. So we would create first a sigmoid function here, simple. Okay, so we are creating a sigmoid function for your demo, just sigmoid function. Let's create that. So the formula is very simple. We would write here a sigmoid. Let's create a sigmoid equals to, let's do here import of math. And we would import from math, basically E we would import here. So let's import directly E. From math, we would import E value. Okay, and now we would define a sigmoid function here. So sigmoid function, you know that the formula of it is 1 divided by 1 plus e raised to power minus x. Okay, you can write it also as e raised to power mx plus c. For simplicity, we would keep it as x. What I want to show you here is, so 1 upon 1 plus e raised to power minus x I have written. So this x, you can write this also as 1 upon 1 plus e raised to power minus mx plus c. It would be same. Now, in this function, we would put the values one by one and we are going to plot it. We are going to put the values one by one and we are going to plot it. So for example, if you do sigmoid of 10, you would get a very high value. We need to return this. So 0.99. In the same way, instead of 10, if you do here 100, you would get a complete 1 value. If you make it very big value, the maximum value would be 1 here. If you take a very small value, let's say 0.11, in that case, you would get 0.5. So the moment you start decreasing the value, you would get here the less values. Let's try to plot that using matplotlib. Import matplotlib dot py plot as plt. Now we would just do here a simple scatter plot, plt dot scatter plot. And in scatter plot, we need to give x and y axis. So our x axis, let's consider it a range from minus 10 to 10. Let's try to put the values from minus 10 to 10. And our y values would be the sigmoid values. Again, a list. And in that, we are going to pass it to sigmoid function for I in. I would explain you this code just a minute. Let me write it first. And we would pass it to sigmoid function here. Now see this. So basically this is what I was explaining you. This is your sigmoid curve. What I did here, let's try to understand this stuff. So basically I said that I want to do a scatter plot. You know that in scatter plot you require two things, x and a y. So I said my x is in the range of -10 to 10. So you can see that x in the range of -10 to 10. And for my y, you put the values into sigmoid function and plot that values here. So you got this curve. This is basically your complete sigmoid curve. You just try to change this curve again and again. Like for example, one curve is this. Now Mahesh would try some different values. Let's say he got a second curve like this, third curve like this. In this way, you can change the different curves here. So let's say, for example, instead of -10, we make it as -5 to 20. So you would get a little bit of, okay, we need to change that also here also. -10, -5 to 20. So you would get a curve. See, your curve has been changed down. So this is your sigmoid function. Now the next important question was why we are using log odds. Let's understand this with a very interesting example you will never forget. Okay, so we have now a room. In that room, let's say there is 100 people. Out of that 100 people, let's say 90 of them are male and 10 of them are female. Let's calculate the odds and log odds for them. So we have odds of male. That is probability divided by 1 minus probability. So probability of male is, let's calculate that, 90 by 100 divided by 1 minus 90 by 100. So when you solve this, it would be like 100 minus 10. So that is 90 by 100 divided by 10 by 100. That is equals to 9. So you understand here what do you mean by odds of male? It means that there is 9 times more chance that you are a male. If you randomly choose a person from here, there is a chance that it would be a male, like 9 times more chance that it would be a male. Odds of females in the same way, you will calculate the probability of female, that is 10 by 100. Okay, and again 1 minus 10 by 100. So when you solve this, it would be 0.11. You can solve that later on. But these odds are not making sense. Akash, I still not understand why we are using here odds. Now, see the magic when I apply log odds on top of it. When I apply log odds on log of 9 and when I make log of 0.11, just try to guess what will we get. We will get here plus 2.5. Okay, and here we get minus 2.5. Now that's the major reason why we are using log odds. The reason is when you have two classes, male and when you have female, when we convert that into a log odds ratio, you get a symmetry around 0. Like this is also with the same distance, this is also with the same distance. You simply get a positive class and a negative class. Remember, in our line, we got a 0 here and some values on the top, some values in the bottom. Due to this, the classification becomes very, very, very easy here. You can clearly see that if the value belongs to positive class as a male, if value belongs to negative class as a female. So that is the reason we use log odds in this. Okay, coming back to our point now, we are going to do a demonstration here of a logistic regression. So for that, we would take a data set, we would work on it. So let's get started with this. Okay, so now we are going to take a hard data set here. We have a hard data set. Let's try to understand what is the data set all about. So we are going to import here pandas, numpy. So we are going to do that. Now, The very interesting thing here is we would take a data set, that is data set equals to pd.read underscore CSV, and we are taking here, we would go back. We would take the hands-on data set, and inside this we have, just a second. Let me see where the data set is, hands-on on data set and heart1.csv. What is the name of it? Heart1.csv. So heart1.csv. Yes, so we got loaded it. Now we would see what is this data set all about. So let's print the head of it. So the data set is a very big name. We would keep it a df.head. And let's see. So we have this type of columns, all different columns here. Age, please upload the data file here, sir. No problem. Okay, so we have here age, gender, CP, some more information like cholesterol level, FBS. So this is some terms which are used in medical. Okay, so basically how much shape, what is the shape of our data frame? We have here 303 rows and 13 columns. Last thing that we have here, target 1 or 0, whether a person has a heart disease or not. So you can just simply check df.target and you can check the value counts of it, whether your data set is balanced or not. 165 values belongs to class 1 and 0 values, like 138 values, belongs to class 0. You can do all your data pre-processing steps. I'm not doing that right now. Some pre-processing steps you are going to see in the later part of it. Okay, like basic things you can do. If I import cborn here and show you cborn as SNS, and if I do sns.countplot, and inside that I just need to give df.target, and that's it. I would get my count plot ready. So all these basic things you can do, all the exploratory data analysis. Major part that I'm doing here right now is split the data into features, that is X and Y, exactly like we have done in linear regression. So X equals to df.iloc, and you would give the values like I want all the rows and not the last column. So we would do this with X, we would do it this Y. The next step also I've explained you in linear regression. It is exactly the same here. We need to split the data into train and test split. So split the data into train and test split. Okay, so let's do that. So we are going to use here in the same way what we have used before from sklearn dot linear model. The model selection we take here. And in model selection, we are going to import a train and a tester split. Now, if you know about train and test splits, that's perfect. If you don't know about it, you can use the help function and you can read about this train and test split. Now we use it to copy this line here so that we don't need to type again and again. Train and test split. So this is exactly same thing which we have done in the previous session, where we give the 4 values: train, x test, y train, y test, train and test split. You need to give your x and y's that you have created here, capital X, small y. See how simple it is. Now, after doing this, we just need to import from sklearn again your logistic regression. From sklearn dot linear model, you need to import logistic regression. You would create the instance for it, for logistic regression. Okay, and then you are just going to do lr.fit. You give your x train to it, comma, y train to it. That's it. And within the second, it would find the maximum likelihood estimation and it would fit the curve for you. Now see, this is a very important point. Everyone pay attention. Increase the number of iteration or scale the data as shown in the figure. Now, this is a very important step that we have not done in machine learning. Do anyone knows about what is scaling? So basically, we are going to understand that these are some of the terms that are used a lot in machine learning. I'm going to explain you this some concepts, that is a scaling concept. The next concept is why we need dummies. What is this dummies? We are going to see that. Okay. Along with that, we are also going to see what is outlier, how to treat outliers, missing values we are going to see. Okay, these 4 things. After these 4 things, we are also going to see here. Once we have fitted all this thing, this 4 are the major things that you are going to understand with me. We don't have a specific session for it, but yes, in one of your session like gradient descent session, we are going to understand these things a lot in detail. Why do we need this? How we need to treat these things. These are very important in your any coding algorithm. This is very important. So now we got our logistic regression trained within a minute. The 2 hours we spent to understand it, and in just 2 seconds we got the model. Now you can just use your logistic regression model like we have done before, dot predict, and you can predict it on your trained dataset. Sorry, test dataset. So you have your X test. So we are going to predict on that, and we would store that in y_predict. Okay, so now can anyone tell me what would be there inside yPredict? Whether it would be probabilities, whether it would be 0, 1, whether it would be heart disease, what it would be. Your final output is from this logistic regression. So basically, you would get the output that are the probabilities. Where that curve went. Yeah. So basically, you would get the output as probability. For example, your male is somewhere here. Okay, so you would project that here, you would get this. So your probability is 0.4 now. As 0.4 is less than 0.5, you would get 0 there. If a value is greater than this 0.5, you would get 1. Okay, anyone has a doubt in the mind that Akash, can we see the probabilities? You said that 0 and 1, but Akash, can I see the probabilities? What are the actual probabilities? Anyone wants to see that probability? So you can use a function called as predict proba. Predict proba means predict probabilities. And now see the magic. Now see the magic. In this, we are going to put our X text in the same way and see you get the probabilities. Now, Akash, what is this 2 arrays? I don't understand what is this. Let's understand that. So first probability, pay attention. The first probability that you see here is the probability that it belongs to class 0. This probability that you see is that it belongs to class 1. In logistic regression, keep in mind, we don't focus on probability 0. You can completely ignore, trust my words, you can completely ignore this 0. Now, you got here a probability 0.02 predicted. Can you tell me whether it is less than 0.5? Yes. So what it should be, 0 or 1? Perfectly right, 0. See, the first value is 0. Let's check the second, 0.83. 0.83 is greater than 0.5. Yes, we will get 1. See, we got 1. Let's check the next, 0.9. We got the 1. Let's check this next, 0.04. You got 0. Make sense? Everyone understood how we got the probabilities, how we got the classification here? Are we taking max of both probabilities and then taking that classified value? No. I can't understand here. Logistic regression is like this. The equation of logistic regression is probability that y belongs to class 1 when X is given to you. So simply probability that Y belongs to spam or probability that Y belongs to a heart disease when X is given to you. So in this way, we will only focus on one. So 0 is completely ignored. So now this was your complete case study. Now we just need to check how the model is performing. So you can use the accuracy for it in the same way. Okay, you can just use here LR.score. That is would give you the accuracy score. And in that, you just need to give your Y test, that is the actual values, and your predicted values. And you would see that we got a error here. What's the error? Expected 2D array and we got 1D array. Okay, so we need to put that X test and Y test. Did we made the mistake here? Y test and Y predicted. Okay, I think let's see the score function, what it does. X and Y we need to give. Okay, X test and Y test. Okay, we would not use this. We would use a simple from sklearn. We are going to import our matrix sklearn.matrix. And we are going to import here accuracy score. Okay, that is simple one. In accuracy score, we would give our Y test, comma Y predicted. Okay, and we got a 85% accuracy here. That's a pretty good model we got it. So now in this way, there is one more thing that I'm going to explain you along with this 4 things. The next thing that is confusion matrix. Again, very important stuff. Okay, pay attention. I'm going to explain you what is random state. So everyone agrees that when we do a train and test split, it would be totally random. It would be totally random. Like I would get some different training points and you would get some different training point, right? Yes, that is shuffled. Now, let's say Shatrugana wants that my result should be same as Akash results. I don't want to change my results. So in that case, we both of us, Shatrugana and me, would use the same random state. Random state equals to 42. Now you can take any number. You need to decide a common number. It can be 142, 552. It can be any number. So taking the same number would give you the same shuffle. Taking the same random state would give you the same shuffle. So for me, now all of you who would use 42, you would also get the same accuracy that I'm getting, that is 85%. So this is used to replicate the results, because what would happen? Let's say now today Deepak made a train and test split. In that train and test split, he got 86% accuracy. But now next time he runs that, the model is again shuffled. And next time he only gets 82% accuracy. Then, so that's why we use a random state, so that we get a consistent result. So you would get coefficient here also in the same way like you got for linear regression using the coefficient stuff, and you would get the intercept also in the same way like you got that in linear regression. The equation here is exactly the same. Y equals to 1/1 plus e raised to power minus mx plus c, like this. So you would get all the m values, all the x values. So coefficient means here you have an equation 1/1 plus e raised to power minus m1 x1 plus m2 x2, okay, plus m3 x3. So this values, this is for m1 value, this is for m2 value, this is for m3 value. So coefficient, there is no limit. It can be anything. Coefficient can be. That would give you always the output 0 and 1. Okay, now coming to the last part, do you guys remember what was multinomial? More than 2 categories. That's perfectly right. So to explain you that, that's beyond the today's session. Okay, that is not there in your agenda, but let's understand that it's very interesting. So for that, I am taking a data set, and that is a IRIS data set. So from sklearn, I would explain you what is this dataset also. So from sklearn.datasets, import load IDs. So let me load this dataset and explain you this. Load IDs dataset. So in my dataset, now my complete dataset has been loaded in my data variable. Okay, now if you see data.description here, so you would see that this is a description about Iris flower. Let me explain you that first. What is this dataset about? This Iris dataset is a flower dataset. Okay, now you have here 3 flowers basically, and some information about that flower is mentioned here. Like the flower sepal length. See, these are the 3 flowers: versicolor, setosa, and virginica. Now for every flower, they have calculated the sepal length and sepal width. So you see sepal length and sepal width. Same way, now you would see here petal length and petal width. So which is for this petal length and petal width. So for all the 3 flowers, they have calculated this. And after calculating these 4 values, they have written whether it is a setosa, versicolor, or virginica. This is multilomedial. Let's create a data frame for it. pd.dataframe. And in that, we just need to mention data equals to data.data. Okay. And the column names here are. So this is, I'm just creating the data set for you. Nothing more than that. So this is how our data frame looks, where we have sepal length, sepal width, petal length, petal width. 4th column we have. And the last target column, we need also that one. So we would store this in X. So X equals to this. So in this way, we would create the last column also. This is our X column. Now we would create the Y column also. So in Y, we have Y equals to pd.dataframe. And in that, we would mention just data dot target. So that has a target variable. So in Y, we have this data frame. Okay. Now we can name this as target columns as well. Columns equals to target. So what we have done, just understand it. We have X. In X, we have basically all the 4 values: sepal length, sepal width, petal length, petal width. And in Y, we have like whether it belongs to class 0, class 1, or class 2. The last part of it, we would again do. Now see how simple it is. We would just use here the same logistic regression. We would create an instance of it, LR equals to logistic regression. Let's do it LR and 2 equals to logistic regression. Okay. And now I'm just going to do LR2.fit. Okay. We need to do train and test split also here first. So we have a train and test split. We have the same X and Y's here. Again, X is small, so we would make the X small here. So we got train and test split. We would just do in the same way, LR.fit. Okay, X train, comma, Y train. That's it. And we would get our first model ready. Okay, now pay attention here. What we are going to do, the next thing is LR.predict. And we are going to pass here. Let's do predict proba this time. And let's understand the concept here. Okay, now see, this time you are getting 3 probabilities. Let's understand what are these 3 probabilities. Let's understand what is this 3 probabilities. Okay, now, what happens when you have more than 2 classes? For example, let's understand this. We have, Ragul has created these 3 things. Let's say he has circle. Okay, he has triangles. Okay, and he has boxes. Now see the concept here for multilomedial. Basically, first you would make a model for circle class. So you would create a classification model that would classify a circle versus rest all the things. So rest all the things. So no matter whether it is triangle or box, I would just classify whether it is a circle or it is a not circle. Yes, it becomes a binary problem. Same thing I'm going to do with triangle. I'm going to predict whether it is a triangle or not a triangle. And same thing I'm going to do with this boxes, right? Whether it is a box or not a box. So in this way, I'm going to make 3 logistic regression models here. 3 logistic regression model. And which one model is giving the highest probability, we would take that. Let's understand this with a very clear example. So lr.predict, and inside that I'm giving some values. Some unseen values are giving. Okay, let's do predict here. 3, 4, 23, 2. Now, what does this mean? These are the 4 values that we have in our training data set. That is sepal length, sepal width, petal length, petal width. So I have given some random values here. Let's give a small value. And it has predicted that you need to give that in square brackets like this. So we got that array 0. Let's understand this now. So if I make 3 models, how many probabilities I would get? For every model, 1 probability, that is 3 probabilities I would get. Yes, perfectly right. We got here 3 probabilities, 1 for versicolor, 1 is for setosa, and 1 is for virginica. 3 flowers probabilities we get. Now, which probability is the highest here? See that. This is e raised to power minus 1. This is e raised to power minus 2. This is e raised to power minus 4. So what does this mean? E raised to power minus 1, which means that it is the first value is 0.97. This is 0.002. This is 0.0001. Which value is the highest here? Yes, that's the reason you got here array 0. Because this is 0, this is 1, this is 2. That's the reason you got 0 here. You can try and see the values would change if you try to predict something different. Let's try to take a smaller value this time. Minus 3, minus 4. Let's see if, yes, it is now 2. Now see the magic. We would do here predict proba. This is the last part now. Do you see the second value is the highest here? 0, 1, 2. Do you see that second value is the highest? Yes. This concept is called as multinomial logistic regression, where we use a concept of OVR, that is 1 versus rest. Now see how simple it is. You have circles, you have boxes, you have triangles. You make a class for circle versus rest, triangle versus rest, and a box versus rest. So that is 1 versus rest. Now, if you have 4 classes, it would become 4 models. If you have 14 classes, it would become 14 models.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Let's get started with the main agenda for today that we are going to cover is a new module for all of you, that is tree models. And in tree models, we are going to cover the first thing, that is decision trees. So first of all, the question is simple, that what's the difference between classification and logistic regression? So it is not about what's the difference. Classification is basically whenever you have categories in your data, it is called as classification. So if I want to categorize, if I want to classify whether a person is male or female, I want to classify whether a mobile phone is Samsung, Apple, Oppo, like this. This all are different categories. To do this classification, to separate the categories or to predict the categories, keep in mind here, to predict this, to make a model for classification, we use logistic regression. To do this classification, how you are going to separate that a person is male or female, how you are going to separate whether a person is basketball player or not, you would use the model for it, and that is logistic regression. Now coming back to our tree models, a very interesting things you're starting today, that is a tree model. Let's understand what is this tree model. And the first part we are going to see today is decision trees. Let's understand decision trees in 100% detailed manner. Before moving to decision trees, we have regression data set. For regression data set, wherever there is like continuous values, we can use linear regression. Whenever you have classes in your data set, that whenever you have classification in your data set, you would use logistic regression. Now, both the things are easily solved. What is the need? Why is the need? And which type of data this decision tree would classify or predict? Do you have all this question in your mind? First question, what exactly decision tree would do? So decision trees are used for both of them. With the help of decision trees, you can do both. That is, you can do regression as well, and you can do classification as well. Both the things you can do with a decision tree. That's the power of decision tree. That when I can do separately linear regression, I can do logistic regression. Why do we need decision trees? So let's understand that in detail. We are going to very, very minute details of it. And that is, we are going to understand here logistic regression limitations. First of all, let's imagine that your data set is like this. So you have a data which is like this. Now you want to, can you apply a logistic regression on top of it? No, you cannot do that, because logistic regression only works on a linear type of data. Linear type of data means linear data type. This is the assumption that your data is linearly separable. Linearly separable means that a straight line can separate your data. Now here, no matter what straight line you draw, you cannot separate the data. So logistic regression has a limitation. The first limitation is that it can only work on linear data. So for this it would work, for this it would not work. So this is the example for linearity. Linearly separable means a straight line can separate that. Second assumption is that, second problem is all your models like linear regression model, your logistic regression model requires scaling. Okay, when we understand all this concept, we are going to understand scaling in detail. What do you mean by scaling? I would simply explain you. In short, I would explain you, pay attention. Imagine that you have a data set. Here is the house price. And in this data set, your first column is square meter area. And the second column is bedroom, number of bedrooms in your house. So let's say square meter area is 700 square meter area, 1500 square meter area, 3000 square meter area. Number of bedrooms can be like 3 bedrooms, let's say 10 bedrooms, maximum, let's say 14 to 15 bedrooms. That also I have said you about a complete villa. In that it can have maximum 14 bedrooms. Can you clearly see the difference in the range of values? Like this starts from 500 and this value can never go above 15. Can you see the difference in scale? The range for this is like 1 BHK to 15 BHK, the range is. And here the range is from, let's say, 250 square meter area till 25,000 square meter of area, let's say. Do you see the range difference? Yes, this range difference creates the problem in the model. Your model would not predict the proper values. It would give more importance to this column because the values are high for this. So to solve this problem, we apply scaling on it. Remember, when I explained you this point, I said you that we are going to take scaling. What is exactly scaling as well? So scaling is required in linear and logistic regression, but apparently in your decision trees, you don't require scaling at all. Third point where your linear and logistic regression fails is a very important point. Interpretability. Interpretability. Now, what does this mean, interpretability? Imagine that you have a linear regression model. You have made for this a linear regression model that is y equals to mx plus c. Yes. So for this, you have made a linear regression y equals to mx plus c. How much? Okay, let's understand this question like this. For example, you are making a decision tree where you can clearly set that if the value is kept less than this, then this would happen. Okay, let's do one thing. We would understand interpretability with an example. So we would see that when we would make our first decision tree. So for now, forget about interpretability. These are the three problems that are there with linear regression, logistic regression, and that is solved by decision trees. The most important point here is it also gives you the importance of the feature. Which feature is important? You can get that also. And it identifies the complex relationship. For example, decision trees here would make boundaries like this. So one boundary it would make like this. One boundary it would make like this. And you would have, you can easily classify this when you have decision trees. So decision tree can identify complex relationship as well. So if I just summarize what are the problems that are solved by this, you can understand, you can interpret what a model is saying. That you cannot understand by linear and logistic. We would understand this with an example later on. Then scaling is not required in decision trees. You can get the fourth thing here, that is important features. Which feature is most important for us? You can get the importance of features in decision trees. That also we are going to see the demo of it. And it can identify complex relationship as well. So these are the five major things that decision tree solve. Next, let's move to the next point now. So I'm drawing one data set. Simple, I have here a column called as gender. I have a column here called as occupation. And I have a column called as suggestion. Now I want to do simple three things here. Basically, I have some gender here. The gender here is female, female, male, female, male, male. Okay, occupation also I have some. The first one is a student. The next one is a programmer. The next one again is a programmer. The next one again is a programmer. Then again we have student. Then we have student. And suggestions based on their occupation and gender, we want to predict the suggestions. That is, here the student is playing PUBG. Okay, then we have, for programmer, we have GitHub, WhatsApp, GitHub, and PUBG. Okay, now just look at this data set and can you find any patterns here? It's very interesting. It's a matter. This is the analytic skills that you develop. So basically, the first thing that all of you majorly have developed is that when it is a student, so let's highlight the student. Whenever it is a student, it's always a PUBG player. So no matter what the gender is, we don't care about whether it is a male, female. So see that here the gender is female, here the gender is male, here the gender is male. So no matter what the gender is, if so I'm writing a rule here. If occupation equals to student, okay, then I would just print here simple that it's a PUBG. Now, else part here. Let's see the else part. That also very, very beautifully you have analyzed it. Well done, guys. You have checked here that this programmer and this programmer is for GitHub. And that is if they are simple females. So else, if the occupation is not student, then it would be programmer occupation only. And I would check here one more condition, if gender is equals to female. If the gender is female, then I need to print that it would be GitHub. And the last scenario, if the gender is not female, in this else part, we would print that it's the only thing, that is the WhatsApp. Visualize what decision the models are taking. You cannot visualize these decisions in linear regression. Tell me, if you make a logistic regression model here, can you say that, okay, if it is a programmer, then it is a GitHub? Can you say this type of thing? No, you would only get here the probabilities based on the equation that we have seen, 1 upon 1 plus e raised to power minus mx plus c. You would put here x, your x is gender, you would put here gender, you would put occupation, and you would only get whether it is PUBG, GitHub or WhatsApp. Exactly same thing we did for iris flower. See, we predicted the iris flower here. It only said that it belongs to second class. Now, why it belongs to second class? Was there something else that it depends on X class? It has never said that. But in decision trees, you can clearly see that based on occupation, it is predicting PUBG. It is nothing like a probability thing here. It's clearly saying that occupation is this, your answer is this. The same thing, the if and else statement, I would create a tree for you and you would start dancing on a chair after this. It is so simple. So we would create the first root node, that is the top node. The first question I am asking here is, what is the occupation? I would just check if occupation equals to student, or I would just check a simple question instead of this, is occupation student? I would check this. If the answer for that is yes, then it's pretty straightforward for me that this is my final node, and this, if occupation is student, then this player is PUBG. In the case of no scenario, I need to ask one more question to that person. Is the gender female? Is the gender female? I need to ask this. And if she says yes, which means that she is a female, in that case, we would go with GitHub. In case of no, okay, we would go with WhatsApp. So if I summarize what we have understood for decision tree, programmatically speaking, decision trees are nothing. Then can we conclude that decision tree are nothing but a giant structure of nested if and else statement, nested if and else statement. Can you confirm, is this point correct, everyone? Yes, that's perfectly correct. Decision trees are nothing, just a nested if and else statement. And the beauty is you don't need to create this. Your models would going to create this nested if and else statement. So this is the simple introduction of decision trees. Let's understand some terminologies, and then we are going to see the maths behind it, how that works. So there are some terminologies here. Ab trees mein kya terminologies hoti hai? In trees, what are the things? You have a root, right? You have the branches, you have the leaves. Same three things you are going to see in decision tree. The first question that you ask, this question is called as a root node. The most important in tree is what? It is roots. People use roots, trees use roots to have their food. So roots are the most important point. Okay, but yes, like if your data set is really very, very, very complex, like millions of rows, and you have like 15, 20s of more than that of categories, then in that type of scenarios, you don't use decision trees. But if your data set is like small, 20,000, 30,000 values, okay, enough categories, like 10, 15 categories around that, so that would be okay. You can work with decision trees. Yes. Now, the first question that you ask is the root node. Like root is most important. Keep in mind, like root is most important for a tree. The first question that you ask is very, 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 again 2 times, very, very important for a decision tree. Then you split this first question into 2 parts, yes and no. And then you again ask one more question, that is, let's say, the second question. Basically, the second question is your branch, and this part is called as your decision node. This is called as your decision node. Now, on this second question, you would again have yes and no's. On your second question, you would have again yes and no's. Now, on this second question, when you finally don't keep asking the question and you get your answer, like here, I got a clear answer that PUBG. In that case, that part is called as, so let's say here it is written PUBG. This part where you get the final answer, you don't need to keep asking any more questions. This part is called as a leaf node. Like in a tree, there is nothing after a leaf. Imagine that this is your tree in front of you. So the moment you have the leaf here, there is nothing other than this on the leaf. So no roots, no question, nothing other than that. So leaf means the last point of a tree. Same way here also this is also would be your leaf node like this. The moment your tree ends, that is your leaf. And this part where you create another branch. So see, this is when you say no, you create another branch here. It is just called as the branch of a tree. Simple as that. You don't need to memorize this. Simple, by seeing that you can say that this is a branch of a tree. So if I give the same notations to our first example, as this is your first question, this is called as your root node. This here you get the final answer. I want to finally classify PUBG, GitHub, and WhatsApp. Here I am getting the final answer. So this is your leaf node. Can you tell me whether this is also a leaf node or not? This part, is this a leaf node? No, it is not a leaf node. It is, again, we are taking a decision here. So this is a decision node. And you finally get your answer. The moment you get the answer, that is called as leaf node. Let's understand here, very important part. Okay, one more drawback is there. Have you guys identified one more drawback here? I would give you one hint. This data set would help you to remember that. Okay, do you guys remember what was OVR? Can you find the error here? Like error in case, can you find the problem that decision tree solves? Okay, I would explain you that. Just suggestion based on gender. So I have here how many classes? How many outputs are there? 3. Now, when I make a OVR model, okay, how many models this logistic regression would make? 3. Remember the example for this circle, triangle, and box I have explained you. It would make 3 models. 1 model for circle, 1 for triangle, and 1 for box. 3 models it would make. So here also it would make 3 models. And just tell me, by looking at this data set, for decision tree to classify these 3 things, how many models decision tree made? This complete itself is a 1 model. We are just asking a couple of questions here. So that's the power of decision trees. Even if you have 15 classes, it would not make 15 models, but logistic regression would make 15 models there. Very good, very good, very good, very good. Now let's move to a very important concept. Only this concept is very, very important here. How to decide now? Here is your question for everyone. Let's understand, and let's understand this part. Just keep one thing in mind, guys. This I have showed you a small example. But even when you have 10,000 data points, your machine learning models would write this type of decision trees only, like it would write if and else statements only. So keep that in mind for sure. Now let's understand the very important thing here, how to decide the first question. Can I keep the gender question on top? Now let's assume that we would keep a gender question on top. Let's assume that. So first I would ask a person if a person is male or female. Let's try to frame this. Okay, let's try to frame that. What would happen if we take a question on the top, the gender question on the top? So now I would keep first the gender question. So here I would ask, is gender male? Okay, like this, I would ask here if the gender is male. So I would get two answers here, yes and no. Now, based on this, I need to again ask a question here. That if the gender is male, in that case, if the gender is male, in that case, again, I need to ask one more question, because there is three males are there here. And based on just gender, I can't take any decision for males. So I need to ask one more question. What's the occupation? If occupation equals to student. If it is student, in that case, if it is yes, then it's a PUBG. And if it is a no, then in that case, WhatsApp. Clear? This part is simple. Everyone can understood this WhatsApp part. This part is done. Quick. It's very simple. Now let's see the female part. We have three females here. We have three females, 1, 2, and 3. Again, I need to ask here whether a female is a programmer or student. So I need to check one more question here. Because see, programmer is GitHub. So I would check here if female, if occupation equals to student. Again, I would check this if occupation equals to student. If the case is yes, then again it would be PUBG. And if it is no, then it would be GitHub. Correct? We got the 100% accuracy, the same thing. Yes or no? Yes. Can you see a drawback here? I made a decision tree for you once again. I changed the question here. Can you see the drawback? It's very clear. No. The leaves would always be same, Shatrugana. One more thing is there. See, one more thing is there. If you see at this, can you see that? Yes, that's perfectly right. Decision nodes are more. Branches are more. In short, I need to ask more questions, right? See, here I was asking one question. Let's go back to our part. Here I was asking one question, and here I was asking second question. Two questions, दो question में काम खत्म. And here I need to ask one question, two question, and three question. So understand this scenario. Abhi, for this data set, it may seems that, okay, what happens if I ask one more question? Akash, no problem. No, but when your data set increases, if you take a wrong question on top, if you randomly take a question on top, that would unnecessarily create a very bad decision tree, and you cannot make a good model. Keep in mind, lock it, hammer it in your mind that the first question should be very, very clear cut. That gives you a proper decision. Imagine this scenario. Let's take a real world scenario. Let's say Venkata goes to a doctor. Simple. Venkatas go to a doctor. Now he has some stomach ache. So doctor would ask him first thing that, so first question for a doctor would be, did you eat outside junk food? Or the second question, here there are two questions. Tell me which question would be the first. So the first question is, did you eat outside junk food? And the second question is, did you played mobile a lot? Did you played mobile a lot, or just simple, I would keep it here, did you sleep well? Okay, according to you, which question would be the first? Very simple. How you decided that first question? Now, imagine, let's get into your mind and understand how you decided that this question is on the top. Simple, because this question, if the answer for this, if Venkata says that yes, if Venkata says yes, then the decision is very pure here, that because of outside food, your stomach is paining. I have a clear-cut solution in my mind that if this is the case, then I don't need to ask any other question. That simply means that yes, Venkata, you have eat outside food and you got some food poison. That's the reason you have stomachache. Now, just imagine for a minute if you ask this question. This question may be important. Okay, maybe your stomach depends on how well you sleep, but that is very, very low priority. Again, doctor, after 10 questions or 15 questions, he need to ask this question. Do you agree that this question cannot be skipped and it needs to be asked? Yes, that is the power of asking a relevant question on top. Else it would be unnecessary exercise that would not give you the solution. Same thing happened here. This is a practical use case of it. I have not asked a proper question on the top. You can see that unnecessary, I need to ask that question again and again 2 times. If that question was on the top, like it had it here, okay, my decisions become very good. See, this is called as pure decision. I don't have any other doubt. I clearly know that if the person is student, then he would play PUBG. There is no looking back to it. So simple, it's a very simple, I would just now summarize it. You decide the first question, the top question would be the question that gives you the maximum pure decision. Like in this scenario, if he has eaten a junk food, I have a pure decision that, bro, it is because of junk food. Because it is a student, it's very pure that it is a PUBG player. Now, based on gender, I have again some impure things. Like in gender, I have 2 things more. So for gender, I need to ask more question, but the first question is very, very pure. Now we are going to see the weapon for this. A weapon that can help you to find this purity. Now see, up till now, what happens is you have a small data set, so you can do that manually. But when your data set increases, you would not have a bandwidth. You would not have, you cannot do just simple. If you have a big data set, you cannot write this rules manually. If I give you like 100 lines of data, can you do this manually? Tell me, can you do this manually? No, perfectly not. So for this, you have a very, it depends on situation. No, Shibrat, for 100 lines of code, it would be very difficult. You can do it, but it would take a lot of time and it's unnecessary. Coming back to our point. Now we have here a solution that is called as Gini impurity. Gini impurity. This measure helps you to understand how much impure your decision is. This helps you to understand how much impure your decision is. You would understand this with an examples so that you never forget this concept. So Gini impurity has a very simple formula. Very simple means the simplest formula it has, that is Gini impurity. So let's write the formula. It is just simple 1 minus summation of all the probabilities square. Now it would seems difficult, but it is a very simple thing. Let's try to understand this with a very simple and clear-cut example. So imagine that I have 100 people in our class. Simple. We would take a real world data set. You would never get confused at any point. We have 100 people in class. Out of that 100 people, 20 of them are smokers. And 80 of them are non-smokers. I want to find out how much impurity is present in this. How much impurity is there in this? So for that, I'm going to use here Gini impurity. Let's understand that. I would just simple do here 1 minus summation of all the probability square. This probability of y1 square means the probability of 20. So that is 20 by 100. We would take a square of it plus 80 by 100 square of it. So let me do that just quickly. 20 by 100, that is 0.2 square is 0.04. So here it is 0.04 plus here it is 80 by 100, that is 0.8 into 0.8, that is 0.64. So here it would be 0.64. Simple. I'm just solving in front of you so that it becomes very easy for you. Now we would sum this 0.64 plus 0.04, that is 0.68. 1 minus 0.68. 1 minus 0.68 is 0.32. So we got an answer here, simple 0.32, which means that the Gini impurity for this is 0.32. Maximum value of Gini impurity here is 0.5. So 0.32 is a very, like it's a bad value. You can consider that there is some type of impurity present inside it. Let's see another example. Now, we have 100 people in the school in the session. Now here change the scenario. 50 of them are smokers and 50 of them are non-smokers. Now, before we move to the formula, so here it should be non-smokers. Now, before I move to the formula, see at this data set and tell me, here we have 20 smokers, 80 non-smokers. Here we have 50 smokers, 50 smokers. According to you, which data is more pure? First data is more pure. Why I am saying this? Imagine this scenario. I would give you the example that all of you can relate. If I have here a glass, in this glass, 80% is milk and 20% is water. I have another glass. In this, I have 50% milk and 50% water. Now tell me, which one is more pure? This one is more pure. How you made that decision? Relate that with the same thing. You can clearly see that in this scenario where one class is dominating, that clearly says that there is a purity. Let's say in our class, 80% of our team, 80% of our class is voting for BJP and 20% is voting for Congress. So here is a clear, you can see there is a pure, that this is a high purity. If we have 50-50, which means that the impurity is increasing. See, here the impurity is increasing. One scenario I would frame in front of you. This is the scenario where learners get confused a lot. So you have here situation 1. This is situation 2. Now one more situation I am creating in front of you, the third situation. In third situation, I have here 20% milk and 80% water. Now tell me, this third is more impure than second, or what is the scenario now? Now see, this is the point. That is the reason I made you to understand this exercise. No problem if you have not understood this. This is a human tendency. Like we think that, okay, 80% water is there, which means that there is more milawat. No, we are not thinking in terms of milk and water here. Think it in terms of dominating. Like here, what if I am saying that purity of water, someone came and added 20% of milk in your water bottle. Will you think that you would say that this is a pure? No. You need to understand here one point, that here one class is dominating. Water class is dominating. So here the purity would be high. This purity and this purity is exactly same from model perspective. Understand it from model perspective. Think for it a minute, that in this now I have here, instead of 80 smokers, I have here 20 non-smokers and 80 smokers. Do you think this formula would change? Only thing would change is this would be as 80 by 100 square plus 20 by 100 square. That's it. Nothing would change. You would exactly get 0.32. Everyone agree? Yes or no? Yes. So always keep in mind how to check the purity. When one class is dominating, that means that there is purity. Understand purity as majority. Simple as that. Jahan majority, wahan purity. So here there is no majority. There are equal votes. So definitely this is highest impurity. Highest impurity. Now it's time work according to majority. So we have now 50-50 smokers. I would put that in the same formula. 1 minus summation of probability here, that is 50 by 100 square plus 50 by 100 square. Formula simple, right? Everyone, very simple formula. Even simple than logistic regression. Yes, the formula is really very simple. So 1 minus summation of 0.5 square plus 0.5 square. Okay, that would be equals to 0.5. You can put that in calculator and you can find that it is 0.5. Can you clearly see that this value is high, 0.35, 0.5? Yes, this is a clear indicator that this is Gini impurity. Understand the term, this is Gini impurity. Impurity is high. It simply means that this is an impure decision. Perfect. Now the third case would make you start dancing on your chairs. Just see the third case. In third case, I have here again the class of 100 people, and this time this class is absolutely like an ideal class. All 100 of them are non-smokers here. And 0 of them is smoker. What's the impurity here? Let's try to see whether our formula make them 0. So 1 minus summation of again 100 by 100 square plus 0 by 100 square. So 100 by 100 square would be 1. 1 square would be 1. So 1 plus 0 square would be 0. So 1 plus 0, 1 minus 1, that would be 0. Make sense? Your impurity came to 0 for this situation. This is what we were hunting for. Perfectly correct. This is your complete Gini impurity. Now you put the values into the Gini impurity, that's it, and you get your model ready. This is the power of your Gini impurity. Purposely, I have taken here a very difficult data set. Difficult in sense, it's not only binary 0 and 1. It is not just like smoker and non-smoker. We have here 4 things. One is cinema, then you have tennis, then you have stay in, and then you have shopping. So 4 things we need to make the decision here. And parameters also we have multiple, like weather, parents, money. We have 3 parameters. We need to decide which question would be on the top. Let's move to the next point now. There are particular steps in it. One by one, we need to follow the step, and we are going to follow that. So now the first and the foremost, everyone pay attention. We are starting this exercise, and it's really very interesting and exciting. The first step in whenever you get a data set, I would explain you what is this data set. We have 3 columns, the weather column, the parents column, and the money column. And we need to take a decision whether whether a person would go for a cinema, whether he go for a tennis, whether he stay in, or whether he would go for shopping. We have to decide within 4 decisions. We need to take a decision from these 4 values. We need to take a decision from these 4 values. So now the first and the foremost thing is find the Gini impurity of your total data set. Gini impurity of total data set. Understand the steps. Steps are a little bit lengthy here, but you would understand that in very simple way. We are going to cover each and every point here. So Gini impurity of total data set. How we are going to calculate that? It's very, very simple. You need to count here. How many cinemas are there? 1, 2, 3, 4, 5, 6. 6 cinemas are there. Let's write it down. So cinema, there are 6. How many tennis are there? Tennis is just first and the last one. That is 2 tennis are there. Tennis are 2. How many stay in is 1? Stay in is 1. And shopping is also 1. So we got this distribution of the values. Let's see how impure the data is. Let's see how impure the data is. Same gene impurity formula we were going to apply here. Okay. So now the gene impurity formula, all of you remember that. I hope it's very simple again. 1 minus summation of. Okay. So now it's just simple 1 minus summation of all the values. And inside that there would be probabilities. So probabilities here are 6 by 10. So 6, 7, 8, 9, 10. So 1 minus summation of 6 by 10 square. That is the probability of tennis. Plus 2 by 10 square. Plus 1 by 10 square. Plus 1 by 10 square. So in this way, when you put all these values, you would get here the final answer as 0.58. That is the Gini impurity for your decision column. For second thing, we need to select the root node here. For root node, we would calculate Gini of all the columns. Gini impurity, I would write GI now. Calculate Gini impurity for every column. Let's count it out. Let's calculate this. Gini value for every column. Gini value for every column. So we would first do here for money. Okay, let's do it for money column, rich and poor. So first thing we are doing here for Gini impurity for money. Gini impurity for money. So let's count it. What are the unique values in money? So we have here, everyone pay attention. You don't need to do that. I am doing it for you. So pay attention on screen. So we have here 1, 2, 3, 4, 5, 6, 7. 7 rich are there. As there are 7 rich and total values are 10. So there would be 1, 2, and 3 poor. So in simple, we have here rich are 7 and poor are 3. I would just simply do here, pay attention. I would again simply apply the same formula. 1 minus summation of 7 by 10 square plus 3 by 10 square. No, understand. Wait. This is the reason I made this mistake, to explain all of you. This is a wrong thing. Why wrong? We have done the same thing above. Understand the difference here now. Do you want to find the Gini impurity of money, or do you find the Gini impurity of money on the decision? Do you want to find the Gini impurity on money, or do you want to find the Gini impurity on money from money on the decision? There are two different things. Pay attention here. Do we need to find how much impure the money is, or do we need to find how money is affecting the decision? What we need to find, first or second? How impure the money is, how money is affecting the decisions. This is the point I wanted to explain you. That's the reason I made that mistake. See, the same thing we have done in our small example also. We identified that how occupation is affecting the suggestion. Then only we can keep that as a question. But if you do understand the Gini impurity, it is nothing to memorize here. If you do this 7 by 10 and 3 by 10, or whatever the answer it would come, let's not write whatever the answer would come, 0. something xx here. Now this value, yes, 0.42. So I was sure 0.5 cannot come, 0.42. Now as the value came as 0.42, this value says that how impure your money is in rich and poor. How impure is that? We don't want to find that. We want to find how it would affect the decision. And pay attention how to do that. We are going really slowly. Now you need to find What's the impurity inside rich? So let's find that. So in rich, pay attention. This is the rich. I would just mark it. This is rich. This is rich. This is rich. Rich, 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 rich. Now in this, we need to count how many cinemas are there. So in rich, there is 1 cinema, 2 cinema, 3 cinema. So let's write it down. Rich is divided in such a way that cinema values are 3. Okay, let's see the next. Then we have tennis. Tennis is 1 and 2. So we have 2 tennis. Tennis is 2. So 5 values are done. Only 2 values are left. Let's see that. Which are the 2 values? One is stay in and one is shopping. Rest all the values are done. So now we have here 1 stay in and 1 shopping. So this is how we calculate the rich, how much it is affecting the decision. Now after this, the formula is again very simple, straightforward. 1 minus summation of how many total values are there? 7. So 3 by 7 square plus 2 by 7 square plus 1 by 7 square plus 1 by 7 square. So in this way, when you would solve this complete part, you would get an answer here as 0.69. Very good, very good, very good. Now the same thing that we did for rich, we need to do exactly the same thing for poor as well. So let's count what are the values in poor. You would again start dancing on your chair after this. Let's see the poor values. So we have here 1 poor, 2 poor and 3 poor. And see the magic, all 3 of them are cinema. Can you say what would be the impurity in pure? This we have already seen. 1 minus summation of 3 by 3 square. So that would be 1 minus 1. That would be 0. So impurity here is 0. So should I make this as the root node? Should I make this as a root node? The money, should I make that as a root node? We should not make it. We have not checked the Gini index. We need to check that, find the lowest, and then we need to take the decision. But wait, our Gini impurity for money column is not completed. We got the Gini impurity for rich. We got the Gini impurity of poor. Do we want this? We want the combined Gini index, right? We want the combined Gini index. Yes. So for that, you need to do last step in this. This is the last step where you find the weighted Gini. How you find out that? It's very simple. Rich, how many are there? Rich, there are 7. So rich has 7 by 10. This is the weight of rich. मतलब 10 में से 7 rich है. So the weight of rich is more into whatever the Gini impurity of this is, 0.69. Plus for poor, what is the count? That is 3 by 10 into the Gini impurity of it, that is 0. So this is called as your weighted Gini. And the answer for this is 0.486. So what I did, I simply first calculated the Gini impurity of decision by putting the formula. Then I need to find the Gini impurity for money, how that it affects the decision. You cannot do it just simple that 7 rich and 3 poor, 7 by 10, 3 by 10. This would give you impurity in money. We don't want to find that. This gives you impurity in money column. Impurity in money column. We don't need this. This part we don't need it. Then what we did, we saw that how rich is affecting the decision. So if a person is rich, how their decisions are changing. If a person is poor, how the decision is changing. We find the impurity for rich, we find the impurity for poor. But we want a combined impurity here. The combined impurity of money. This is the combined impurity of money. So when I did that, what we need to do? The weights, that is 7 by 10. This is just simple weights. The weights of money and poor multiplied by their respective Gini index. And you would get the overall Gini index. Now, the same thing you would do for next 2 columns also. We would not sit and calculate all of them. The things would remain exactly the same for both of them. but I have the values for you. I can show you that values quickly. We have 3 columns here. We would not take the weekend column, weather, parents, and money. Weather, parents, and money. So finalize after doing all this. You can check it when you go at home. Try with parent and money, parent and weight. So sorry, parent and weather column. Try with that. I have already calculated it. So for weather column, it is 0.41. For parent column, it is 0.36. And for money column, we have already calculated above. We can take it from above. That is 0.48. So it is 0.48. Now, according to you, which one should be the root node? The parent is the correct choice. Parent is the correct choice. Why parent? Why not money? Because this is the Gini impurity. The impurity where it is the least, you take that. And the least value is 0.36. That's the reason we would take parent as the root node. Get ready for the suspense. That is absolutely correct. Here is your decision tree made. The first question we are asking that whether it is parents or not, whether parents had said yes or no. If a parents had said yes, then the decision is, see how much pure it is. This part, this table which I am selecting here, whether it is a root node, leaf node, branch node, what it is, they are the leaf node. Why leaf node? Now I don't need to ask any question. My decision is completely purely taken here that bro, I will go to cinema. No more questions I would ask here. But this here, I would ask more questions on top of it. Now, this is my new data set. Again, I need to find the impurity for this. Not for this because parents, we have taken it. Impurity for money and weather. And then I need to ask one more question. So same exercise what we have done. Now this tree would go beyond this. So this is called as a decision node. This is perfectly correct. Many of you have said is perfectly right. This is a leaf node. So Gini impurity says how much impurity is present in your decision. So if the impurity is high, the bad your decision is. So even if I'm asking you, let's say a question, and after that also I don't have a clear decision, that is called as impurity. So as this number increases, which means that there is very high impurity. So the most impure decision is the money. Then the impure decision is the weather. And then it is parent. As parent is the least impure decision, we consider that as the root node. Whether parents are saying yes or no. If they are saying yes, you have all the decisions as cinema. If they are saying no, then you have a mixed decision again. So you need to again keep on asking here the questions. That is how your decision tree works. So the making of decision tree is simple, very, very simple. You can just see that in 15-20 minutes, we would complete the code. It's really very, very, very simple. So let's see that how to make it. To make the things exactly same and you don't get confused, like Akash is teaching something else and we are seeing the code of something else. We have taken the same data set. So here is our data set. CNET tennis.csv. So I have given it a name as cinema_tennis.csv. Same data set we have, exactly same that we have worked on. So let's run it one by one. First is import pandas as PD. Then we read this data set and we have this values. See, there is simple thing. In weekend, every value is a unique value. If you pay attention, every value is a unique value, W1, W2, W3, W4. If you pay attention, it is nothing like, it is just a simple index. If you pay minute attention, it is just an index like 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you use index serial number in your machine learning models? No, not at all. That's the reason we are not using weekend here. Let's get back to the code now. we have this data set which clearly says that the same thing, the three columns, parents, weather, and money, and we need to take the decision for it. The first and the foremost thing here is we don't need to do any stuff here. Okay, so I would just import here a sklearn tree. So from sklearn, we are going to import tree, that is the decision tree. Then you need to make the instance of it, that is decision tree classifier, the instance of it. So we have made the model here. Now the moment I run this, I would get my model ready inside model. Now I would just now see first the error. I would first make this happen, the error for you, and then I'm going to explain you this part. Just a second. Okay, now let me just take it here. Let me take this X and Y. Okay, now see, up till this point, we have just created a model. Now we would create X and Y. How to create X and Y? This is exactly same like we have done in your previous module as well. We took a data frame. We applied a iLock on top of it. And I said that I want all the columns till -1. I want all the columns till -1. -1 column is basically your last column. That is the decision. So decision column we are keeping in Y. Nothing change in that, like we have done previously also. X and Y we have separated. The moment you got X and Y, and we need to make here df here. The moment you got X and Y, we need to remove this weekend column also first. So df dot drop weekend, and we need to write here xs equals to 1. And at the end, we need to write here in place equals to true. So we have dropped our column. Let's run it from scratch. We drop the column. We got X and Y. So in our X, we have 3 columns, weather, parents, and money. And in Y, we have 1 column just, that is cinema, tennis, cinema, tennis, cinema, tennis, whatever it is. Now it's time to just put that into our model, that is model.fit X and Y. And now see how tight it would slap you with an error. I want all of you to understand what is this error now. See, basically keep in mind, this error would always remind you of one thing. Computer cannot understand strings. Computer cannot understand Sunny, the first value. That's the thing you got here. Cannot convert string to float. Computer does not know how to convert Sunny to a float value. Which means your computer needs a floating value. Your computer needs a floating value, an integer value or a float value. So we need to convert all these things, yes and no's, rich, poor, windy, sunny, cinema, tennis, everything into numbers. Keep in mind, computer does not understand string. It requires numbers. Okay, now let's see the solution for it. We have a data frame. Let's go back to our original data frame. Without splitting into X and Y, we have this thing. Weather, parents, money, and decision. We have this 4 columns. Now what I do here, I use label encoders. What this label encoders do, I would explain you. But first, let's understand the code. We need to create an instance of label encoder. Okay. We first need to create the instance of label encoder. Then what I do, I just use this label encoder. Now pay attention, step by step we are going here. We created the instance of label encoder. What is this label encoder? It is used to convert string to numbers. So for that, we are going to use this label encoder. Then we created an empty data frame here. Created an empty data frame. We created an empty data frame here. Then what we do here, we have 4 columns to convert. So we use this LE, that is label encoder, dot fit transform. Give your column name to it. Basically, this part is not required here. Even if we don't do that, it's totally fine. So this is your data frame. This is your data frame. That's it. You don't require this. So basically, what we are doing here, we are converting this weather column into numbers, because using this LE, we are converting this weather column into numbers. Same way we are doing it for parents. Same way, see, the code is exactly same. LE.fit transform, and then you just need to give the column name to it. Rest, your complete code is exactly same for all the 4 columns. See that? And that 4 columns we have stored into our new empty data frame, that is df_convert. Now, if you pay attention, if I show you the new data frame for us, you would find it very interesting. See that. Let's first understand the weather. Weather has 3 things: sunny, rainy, and windy. So you got here 3 values, 0, 1, and 2. Same way for parents, there were 2 unique values, yes and no. So you got here 0 and 1 in parents. Money also has rich and poor. So you got 2 values here, 0 and 1. And decisions has 4 values. So you got 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3. So this is how we have converted into numbers. The next part of it, we converted everything into integers. That was our problem. We solved that. We would again get the x and y's here. We got the x and y. You can see the y. Same way you would see the x also. In your x, you would have just this thing. So x and y's are done. Now you would use the same model.fit. You would fit your decision tree. Within a second, your decision tree model has been made. Let's check the accuracy for the model using model.score. You need to give your x and y in the same way. Your training accuracy is 100%. Your model is perfectly able to classify all the values. Let's understand this in more little bit of detail. Okay, I don't need this part. Let's comment it out for now. We would see this later on. I don't need this also. So let's comment out this part also here. Now, these 2 things we don't require. We are not focusing on this right now. We would focus on some important stuff here. Let's keep it, not this. Okay. So now let's do this one by one. So what I'm going to do is, all of you know matplotlib we are using here, and we are seeing the figure sizes 25 cross 25. Now see how simple it is to visualize, to interpret. Akash, you said in starting, it's easy to interpret the decision trees. So what you are going to do, we just need to do tree, okay, which we have imported here. See that we have imported the tree in the first thing. From sklearn import tree. Now we would use this tree model, and we would say that tree dot plot tree. Tree dot plot tree we are going to say. And inside that, whatever model we have trained here, this model we would pass to it. And see the magic. This is really interesting. Within a second, you would get your tree ready. And this is your decision tree. The complete tree that we were drawing here, this tree is present within a second. Does it do cools? Yes, it's really very cool. Let's understand how to understand these values and what are these values. So first of all, this x1 stands for the first feature, x0 stands for the 0th feature, x2 stands for the second feature. But Akash, can we get the name there instead of this? Yes. For that, you can simply use feature names equals to x dot columns. Feature names, you just need to give one more parameter here. That is feature names. Instead of giving x1, x2, x3, x0 like this, give me brother the column names. So I would run this now. Now see, instead of x1, you have here parents. Do you remember what was our first root node that we have calculated? Parent? Yes, it was parent. We have also came to a conclusion that parent would be the root node. And we also find out that there would be 5 cinemas, and in no part there would be like this mixed values. Let's see whether this is matching or not. So we have asked here a simple question, whether the parent is less than 0.5. Now, what do you mean by parent less than 0.5? Basically, parent has two values, 1 and 0. 1 and 0. 1 stands for, you can clearly see, 1 stands for yes and 0 stands for no. 1 stands for yes, 0 stands for no. So 0 is for no. If parent is less than 0.5, this is yes, this is no. So if parent is less than 0.5, which means that it goes to the yes part. Okay. Which means that basically the parent is saying no. Because 0, see, if parent is less than 0.5, which means that it is 0. And parent is greater than 0.5, which means that it is 1. Instead of yes and no, just see like this, 0 and 1. 1 stands for yes, 0 stands for no. Very simple. See that. For yes, there were 5 cinemas. See here also. For yes, you have 5 samples. Okay, you have 5 samples and value of them is 5000. This 5 stands for 5 values of cinema. First, there were 6 values. Now it is came down to 5 values. So 5000. So 5 cinemas and rest 000. All these 3 values are 0. So this is how you can read it. The genie of the leaf node, always the genie of the leaf node would be completely 0. Which means that this is an impure decision, completely pure decision. This is completely a pure decision. Same way you would now keep calculating for the right side, for whether you have asked another question, for again for money you have asked the question. In this way, at the end, you would get the genie for all of them as 0. Now, if you want to make this graph look more beautiful, you would just use the last parameter here, that is filled equals to true. This is used to just make your tree look beautiful. That's it. So it would color your boxes. Now let's see, last 2 or 3 things are left in this decision tree part, which are important for you to understand. The first one is the entropy. Now this is the new concept for all of you. Understand here. The next concept here is of entropy. Entropy is also a measure of impurity. It is basically a measure of randomness, you say. Okay, it again stands for impurity. So basically, just the little bit change in formula here for calculating the entropy, little bit change in formula. Let me explain you that. What's the change in formula? So the formula here for entropy is minus P log of P. Okay, minus 1 minus P log of 1 minus P. So basically this formula looks difficult. This is just don't so here we just use log with the probabilities. And for example, you have this data where you have, let's say, 3 circles and 3 triangles.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
3 circle and 3 triangle. So you would put the values here. So probability minus of this, minus is outside. This is completely inside. So minus of probability here. So probability is 3 by 6 log of 3 by 6 minus 1 minus P. Okay, that is 1 minus probability. Again, it would be the same thing. 1 minus P is basically your second class. Like you have the 2 classes here, circle and triangle. So it would be exactly the same. 3 by 6 into log of 3 by 6. So it's simple as that. It would be minus 0.5. If you solve this, you would get the answer as plus 1. So the maximum value in Gini, understand the difference between Gini and entropy. The maximum value in entropy is 1. How plus 1? Solve this. When you solve this equation, it would be plus 1. You just need to solve this. 0.5 log of 0.5 minus 0.5 log of 0.5. Sorry. This is plus. So I've written, so we have taken the minus outside. So this is plus. No, it's plus, plus, plus. By mistake, I have written that. So 0.5 plus 0.5, that would be 1. Okay. Yeah, the formula is plus because I have taken the minus common outside. That's the reason. Okay. Now see, for your Gini impurity, for your entropy, the maximum value is 1. You can see here the maximum value is 1. For Gini impurity, your maximum value is 0.5. Okay, that is the major difference between entropy and Gini index. This is the major difference. That Gini index, the maximum value would be 0.5. Entropy, the maximum value would be 1. The procedure remains exactly the same. What you have done in Gini index, similar type of approach you do here. What is the approach? You first calculate the entropy. So here the information, so what you do in entropy here, basically you find the entropy of a parent, like you have done that. There also we have done the same thing. Parent Gini we calculated, here we will calculate the entropy of the parent in the same way, minus the weighted impurity, the weighted entropy. So exactly weighted, you remember the concept, right? I have explained you the weighted Gini index. The same concept, this is weighted Gini. Same, you calculate the weighted entropy. You subtract it from parent entropy. Okay. This is called as information gain. Information gain. Now understand what I'm teaching you. This is a new concept for all of you. What I'm teaching you, if you want to calculate impurity, you can use Gini index. We have seen the formula for it. We have calculated it one by one. There is one more method, that is entropy method. The formula for this is this. And the formula for this is this. You calculate the entropy for every in the same way like you have calculated for parent, for children, for parent, for rich, poor, like that you would calculate the entropy. Two things you need to do extra, that is you need to subtract the entropy from parent entropy. This part we have not done in Gini index. This would give you the information gain. Information gain means that how much information you got after selecting that node. So which one has the highest information gain, you would select that. So that is basically your entropy. So whenever you make a decision tree, you have the option to select that. See, if I show you, I can select here where we are. Yes. So here when we make the decision tree classifier, let me go up where we made the model. Yeah, this part. At this part, we can mention here specifically, see, the criteria here is Gini. By default, sklearn gives you criteria equals to Gini. Now you can change this criteria. Let me show you that. Right now, I have explained you the entropy part. So you can change that. See, you can select Gini, you can select entropy, and there is one more log loss. Log loss is not in our agenda. So right now we would not talk about it, but you can select entropy also. So exactly like I have explained you entropy, it would apply that formula, and based on entropy, it would calculate the information gain. This is what I was explaining you, information gain. And that is how it would select the best node. That is how it would select the best node. So basically, this is your decision tree. This is your decision tree. You select always Gini index here. There is a simple thing that in Gini index, you don't have log and everything. Okay, it's just simple probability. So the calculations are much faster in Gini index. Log is computationally expensive. It takes more time. So you use by default Gini index. What is imbalanced dataset? Imbalanced dataset means that, let's assume that we were predicting. So we started with heart diseases. Okay. We started our classification model with a heart disease. We made a logistic regression model. We make a logistic regression model that can predict the heart diseases. So whether a person has heart disease, yes, or whether he has no. Now let's assume that in our data set, you have 60 yes, 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 yes. So you have 100 patients. Out of that 100 patients, 60 are yes and 40 are no. Like 60% have heart diseases. Understand this point. This type of data set is called as balanced data set. This is balanced. Understand the balance exactly same as like Taraju. If you have seen that, the balancing thing, okay, where you have weights on both the sides, okay, and you balance this. So if it is little bit up and high, see, this is little bit up than that. So if this is a small distance, we can say that they are balanced. But now Ragul comes to me and say that out of this 100, 10 of them has heart disease. Yes. And 90 of them has no, there is no heart disease. I would say that this data is now imbalanced data set, where one value is dominating completely to the other. This is basically called as imbalanced data set, where one category, one class is dominating. This is called as imbalanced data set. This is called as imbalanced data set. Now this imbalanced data set can create a lot of problems. Skewness is totally different from this. Skewness means that one type of value is dominating. For example, if I ask what is the salary of all of you, now some of you may say that, okay, we have 40,000 per month, 60,000 per month, 80,000 per month, 75,000 per month, 80,000 per month, 90,000 per month, 1 lakh per month, 1 lakh and 5 per month, okay, 1 lakh and 2 per month, 1 lakh and 7 per month, like this. So now here the major values are dominating in this side. So if you see that, the values would go more towards 1 lakh side and very less people are there in 40%. This is called as skewness. The imbalance is a real world problem. In many scenarios, you have one class dominating. And to solve this problem, we have a simple algorithms for that. 3 simple things are there. See, very simple it is. Just with logic, सिर्फ logic लगा के हम यहाँ पे solve कर सकते हैं इसको. See how simple it is. I have the data set. In this data set, basically there are 2 classes. This is, let's say, a fraud class. This is a non-fraud class. I have 99 transactions here. 1, 2, 3, 4, 5, 6, like this, 99 transactions, 1 to 99 that are non-fraud. And only, let's say, 2 transactions are there of fraud. Yes, perfectly right. This is an imbalanced data set. You can consider any example like this. Now, what we do, the first approach is oversampling. Very simple it is. Think for it logically. How you would solve this? One thing, if I replicate this to one more time, like if I create the duplicates of this, do you think we can get the, if we can create the duplicates of this, we would have the balanced data set? Do you think that? Like imagine that Anand has 10,000 papers to check. Okay. Anand is, let's say, our TA, teaching assistants. He has 10,000 papers to check. Okay. At the same time, Mahesh has only 10 papers to check. 10 papers. This is imbalance. Perfectly. There is an imbalance here. Now, what I'm saying that Mahesh, if you want to make this balanced, no, this is imbalanced, right? Everyone, Ragul, agree this is imbalanced? 10 paper and here there are 10K papers. Correct. Now, what I'm saying that Mahesh, if you want to make this balance, just make the Xerox of it. Just make the copy of it. Okay. Like 1,000 times make the copy of this. If I make the 1,000 copy, will I reach the 10K papers? Yes. And both of them are balanced now. Does this logically make sense? This process is called as oversampling. See how simple it is. Nothing to memorize. Just creating the duplicates of it. That is called as oversampling. Correct? Make sense? Okay. Now the opposite of it. See, once you have understood oversampling, you have another technique here also called as undersampling. Now, instead of Mahesh saying that I would make a 1,000 copies of this, Mahesh says to Satrugana that you just delete, you just burn your papers and bring it down this 10K to 10. Now, can you see that both of them are balanced if you just remove the extra values? Yes, makes sense logically? Yes, this is called as undersampling. So this is basically some of the techniques, oversampling and undersampling. One more technique is there, that is SMOTE. So what happens in this? What happens in this SMOTE? So imagine you have this data set and you have another data set, which is, yes, there is a clear imbalance here. Now see what's the solution for it. Very interesting solution it is. Logically, that would make a lot of sense. So what we do here in SMOTE, that is synthetic generation of data. We generate a dummy data here. How we generate it? We take one point, we connect it to the nearest neighbors. This is the close to this point. This is close to this point. First step, we connect this like this. And then between this connection, we randomly generate the point like this. We randomly generate the points. Same way, connection for this and this, we randomly generate some points here, some points here. Same way for this or this also, we would generate the points here, generate the points here. So in this way, we would keep generating the points. Now I would remove this connection and tell me whether this makes sense for you or not. So now I would again generate the points in between them. Make sense? Our problem, whatever was the problem, do you think that this would be solved by this? See, this is the perfect example for this. So SMOTE, it connects the dot between the point and it creates the point on that line. It creates the point on that line. Forget about this borderline and all that stuff. Just focus on this SMOTE technique. Synthetic minority oversampling technique. So here also we do oversampling, like we are increasing the scats, but by using synthetic. We are not randomly just duplicating the values. We connect the dots and on dots we create the examples. Simple thing is both of them, entropy as well as Gini, both are measure of impurity. Just understand this. I have a very good example for you. To earn money, you have two ways. You can be a CA, let's assume that, or you can be an engineer. Both the ways you would earn money. Okay, but it's dependent on you what you want to select. Simple as that. You can consider CA as entropy and engineering as Gini. Gini is little fast, okay, computationally less inexpensive, and entropy is expensive because it calculates logs. Log take time. So we select by default, that's where there is Gini. Let's understand disadvantages of decision trees. Very, very important. So let's assume that we have this data set where we have points like this. So this is our data set. Now what happens with your decision tree? So first of all, a good decision tree should be created like this. Okay, a good decision tree should be created like this. Even 1 points go outside, no problem. But what happens in overfit? Your model tries to fit each and every point. So instead of this is, you can consider that, okay, this is a okay type of model. Instead of this, what a decision tree actually does, decision tree would try to capture this single point also. For example, what it would do, just let's understand that. So it would try to cover like this, create a decision boundary on top of it like this also. Okay, and let's say your some point is here. For example, here. So it would again create a decision boundary, one more here like this. So this is called as overfitting of data, which means that each and every point your model is trying to capture. So this situation is like just a mugging up the data, which means as in Hindi, ratna. This is called as mugging up a data. Simple as that. Each and every point which I'm training, there is no general ability. The model is trained for each and every point.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
You would understand how bad it is. For now, just understand that it is trying to capture each and every point. So let's say if your circle point is here, okay, one circle point is here. This is a very good example. See, if one circle point is here, ideally the model should ignore this circle point, but it would try to capture that also by creating a decision boundary here. Decision tree is very, very unstable. Unstable means that, let's say in your data set, the data set which was taken here, let's take our data set. Any data set you can take, we can take this big data set also so that it's there in your mind. Let's take the big data set now. So in this big data set, just try to explain me one point. Just try to tell me one point. If I just change one value, if I just change this cinema value, and if I make this tennis, do you think my decision tree that we have done yesterday, it would change or not? Yes, it would change a bit, because your log probabilities would change. Okay, your maybe your first top question can change due to this one change. So your model is a lot changing just by a small change in your data set. So decision trees are very unstable, which is the implication of overfitting. And this clearly says that it is overfitting. If by changing 1 or 2 points, your model is changing, it is called as overfitting. Now, the third point, I have already said you that the mathematical calculations that we have already seen, mathematical calculations, they are too expensive, like calculating the entropy, calculating the information gain. This all takes a lot of time. Okay, and to perform the split every time, perform every split, every question, so it takes a lot of time consuming. It is energy consuming, time consuming. The last point here is decision trees are greedy algorithm. This is a very good point. This is an interview based point. Okay, what do you mean by greedy algorithm? What do you mean by greedy algorithm? Greedy algorithm means, you can understand that a simple thing, that greedy algorithm works like the current situation, it wants the best. It wants the best. The current situation should be best. For example, there is one learner, okay, and that learner in the current situation, he wants to enjoy. And for that, he is using continuously his mobile. We can take a rough, very, you can say harsh example also. This person wants to enjoy. So he is starting taking the drugs also. Now see that for this moment, for this current moment, this is the best thing for him. But in the long run, is this good? Long run, it is bad. Exactly same can happen with decision trees. Just imagine that decision tree, what it wants. Decision tree wants that right now the question that I'm asking should be the best. No matter after that, what is the question? For me, the question that I am asking right now, like we have selected here the parents question. How we selected the parents question? Because at that time, the genie was the least. But let's say after asking a parents question, after asking one more question here, one more question here, okay, and asking this question, this may come a situation that at this point, it becomes a very bad decision tree. So decision tree does not care about the future questions. In the current moment, I want the best thing. So this is called as greedy algorithm. If you have heard about that, Abhi, I want the best. I don't care about the future. That is your greedy algorithm. So now to solve this problem, okay, we need to solve also the problem. We have two approach. Okay, either we can solve overfitting. So we need to solve these two things. Solution to do overfitting. The first problem that we have for overfit, because this overfit, if we solve, we have solved instability also. So both the things would be solved. So overfit can be solved simply by two methods. That is truncation, and the next one is pruning. Truncation and pruning. The pruning was the word you have seen, I think, in the PPT also. So both we are going to see here. And the one more solution is there for this, that is random forest. This is how we are going to start today, random forest. But first we would understand this small two topics. We would understand what is overfit, and then we would start with random forest. Very interesting it would be. So let's get started with the truncation. It's very simple. First, you need to understand why overfit happens. If you understand the problem, you would understand the solution. Now see what's the solution here. The first solution is truncation. Truncation means that stop the tree while growing. Stop the tree while growing. So basically, it has a very simple approach. Look at the data set that I have shown you, how you can stop it. So I'm explaining here stopping condition. So this is our data set. Okay. So for this data set, how the decision tree would be created. Just see that how the decision tree would be created. It would not be created directly like this. Let me remove all this and let me plot it again here. And we have the blue color here. So let's make it blue color. So this is a point, this is a point, this is a point, and some point here. Okay. So now we have this data set. How decision tree would work? It would not create all the boundaries within a minute. It would start with one boundary like this, right? First, it would create this type of boundary. Like it would ask first question. So like it would, based on that first question, it would create a boundary. Yes. So it has created the boundary. Now, after that, so first question it has asked, based on yes or no, it has created this boundary, let's say. Another question it has asked, based on that, it has created one more boundary like this. Now, to solve this X also, to solve this also, it would ask one more question. Basically, let's say it is asking one more question here. One more question it is asking. Now, what I would say that, okay, bro, you need to stop at this point. You need to stop at this point so that it would not ask this question. If that question is not asked, our model is stable. It is not overfitting. So like, for example, someone is saying me that Akash, explain deep learning. I would say that, bro, stop. I need to stop that. That is called as stopping condition. On how I would decide the stopping condition. The first and the foremost point here is max depth. Max depth. Max depth means that this depth, like I would say that, okay, my decision tree should not go more than 4 depth. So this is depth number 1, depth number 2, depth number 3. Okay, this is depth number 4. At this point, it would stop. After this, it would not ask any question. How to decide this depth? Majorly, it is decided based on the data set. So some data set can have a depth high, some can have data set low. Around 4 or 5, we keep the depth. And again, you can increase or decrease this depth very easily. While code, I'm going to explain you. While we code, I'm going to explain you. First is max depth. Second is very interesting. If you just think for it logically, okay, you don't need to understand the concept. If you just think for it logically, you can come to a conclusion. For example, minimum points. I would say that, bro, if in my split, the split that I'm making, for example, I'm making a split here. And after making that split, there is only 1 point. Then no, there is no need to do that split. So I would set some minimum point threshold. I can say that, okay, if there are 20 points, less than 20 points in that split, don't do that split. That's a problematic situation for me. So minimum points are also decided. Based on the minimum points, you decide to split or not. That is the second condition. And third one is always there, like the pure one. If you have already reached a pure node, that is the leaf node, you automatically stop at that position. You don't further divide it. So this is how there are 3 stopping conditions you can solve the overfitting problem. In short, you decide the length of a tree. Your length should not go very big. Imagine that you have a very big tree in your house. So you would keep cutting that tree. That is called as truncation. stop the tree before growing. Like, okay, wait for it. Truncation and pruning are different. Truncation means that you don't allow the tree to grow. You keep that in, let's say, a box. You keep that in a window. You do not allow that tree to grow. That is called as truncation. If it is growing, you keep cutting that. That is called as truncation. What is pruning? Pruning is let the tree grow to any depth. So I would say that, okay, so in pruning, what you do, you allow the tree to grow to any depth, like this, like this. So it would keep growing on this. So it keeps going, the tree keeps growing. Like this, the tree keeps growing. And what you do, then cut the branches of a tree in bottom up fashion, starting from leaf. This is called as post pruning, pruning the tree after it is grown. So which means that, okay, you find out that here the examples are very less. One example here, one example here, two example here, like this. So you would cut this branch and you group all of them together. Basically, you cut that branch. This is called as pruning. Tree एक बार बड़ा हो गया, उसके बाद में you would cut that. That is called as pruning. Cut the tree after it has grown. Now, before creating a decision for this, X like this, I would check after creating this boundary, there are only 2 points here. There is only 1 point here. So I would keep a minimum point threshold. So generally we keep a threshold around 20 points or 10 points, again belonging to dataset. So based on that, you would decide if it is less than 20. See, this point, this is only 1 point, it is less than 20. So I would not create this decision boundary. Again, these are only 2 points. I would not create a decision boundary. So these are the all things how you handle overfitting. Let's understand exactly what is overfitting with a very good example. So I would draw some data sets for you and let me explain you what is overfitting. And don't worry, everything we are going to see in a practical use case also. So we are taking this data set to explain you the same data set I have taken 3 times. Let's try to understand each one of them in a clear and a great manner. Pay attention. So in my first data set, the 2 things are there. 2 things are there that is very important. And trust me, guys, when you go to interview, I am 100% sure you would get 1 question on this. So make sure you ask me 15 times, but get this cleared: bias and variance. What are these 2 topics? You understand that in a 100% detailed manner: bias and variance. Let's understand what do you mean by bias and what do you mean by variance. Very simple definition. Bias is basically your training error. Now pay attention. This is why I am focusing a lot on this, because even after completing like 4 or 5 months in data science, even after being a data scientist, many data scientists don't understand these topics. So training error. Bias is called as training error. Keep in mind, bias is called as training error. What it is, I'm going to explain. Variance is called as change in model if your data is changed. Let's understand this definition in detailed and the best manner possible. So now this, I'm making one model here. So this is my scenario number 1. Consider this as case 1. This is case 2. And this is case 3. I am making 3 models here. It can be any model: linear regression, logistic regression, any model. I am making a model here. So this is my first model. This is my second model. Imagine that this is a linear regression model for your simplicity. This is my first model, this is my second model, and this is my third model. Okay, now I have made here 3 models: model 1, model 2, model 3. Let's understand what is bias. I trained a model here. This is my trained model. Pay attention. This is my trained model. Can you tell me this error in this model is high or low? So your error is very, very high in this case. Your bias is very high. Simple as that. हमको क्या देखना है? हमने जो मॉडल बनाया, is that good or not? That is bias. So what I am teaching you, I am training all of you. If you are understanding that training, your error would be low. But if someone is not understanding the training, it is like very high error. It's a simple thing. Like whatever I am teaching you, like I have taught you decision trees. Now, exactly like this, I have trained you I have trained you on gene impurity. When I ask you a question, see, when I was testing it, this is called as testing. When I was testing you on the same question which I have taught you, nothing unseen, koi naya cheez nahi hai, same question I am asking you, that is called as training error. Now see the bias in the next scenarios. So medium also you can say, or low also. There is no situation of medium here, only high and low. So we can say this as low. This is low error. Why low? Because now the data, the difference, you can see that here the difference is very high. Here the difference is very low. So it is low error. In third scenario, it's negligible, like zero error, you can say. In simple words, we have only two options, high and low. So again, this is also low. Very good. Let's understand variance now. What do you mean by variance? Variance means if your data is changed, your model would change or not. If your data is changed, whether your model would change or not. So variance, now see, now in this scenario, I'm framing very interesting scenarios for you. Shatrughna comes and okay, and he says me that, okay, Akash, I have added some points here, 1 point here, 1 point here, 1 point here, 1 point here. Do you think my model would change? Will it change very high or it would change low? In the case 1, I have added 4 data points. I have changed my data. What would happen? The simple answer here is model would not change much. Why? Why? Pay attention. Why? Because these 4 points that I have added, already my model is not paying attention to this. Whatever the model is, it's not paying attention to my data. So even if I change the data, my model would not be that great. Model can change a little bit, only very small change it would be. So I would write here low change. So same in the second scenario now. Change in model if your data is changed. So what I did, I changed my data set. Basically, this were my 1000 points. I added some 4 more data points to it. Imagine that you have a data set and it has 1000 rows. And your 1000 rows, your model is performing, let's say, 23% accuracy, only 23%. So your training error is high because your accuracy is low, correct? So in that case, just tell me, in this 1000 data points, if I add, let's say, more 10 data points, only 10 data points, do you think this accuracy would change a lot? No, accuracy would not change. See, on 1000 points, it is not performing. 10 points, this accuracy might change a little bit, like 24%, 25%. That is a very low change. But this 10 points cannot make this 22 to 73 like this. So that's why variance is low. Variance means what is the change? Change is very low. In the second scenario now, in second scenario also, if I add one more data point here, if I add one more data point here, or if I add one more data point here or here, again, do you think that the change would be very high or very low? Tell me. Again, very good. My model is generalized. Okay, my model is generalized. So the variance would be very low. Now you would understand it much, much better in this scenario. Now see the variance in this case. Again, I am adding some extra data points here. 1 data point here, 1 data point here, and let's say 1 data point here. Just 3 data points have changed. Because my model is changing with my model is capturing every data point. It is not generalized. It is capturing each and every point. So now my model would change here a lot. See, let me use a small eraser here. Yeah. So instead of this, now my model, what it would do, my model would go to this blue point. It would get that. Same my model would do here in this scenario also. It would go to this point. It would try to capture that. Same for this point. It would try to capture this point here, which it would go like this and like this. So just by a small change in data, pay attention, such a small change in data, my model is changing a lot. My model has completely changed here. This is called as high variance. Comparison of actual and predicted value in graph is bias on training data. Keep in mind, on training data, not on testing data. So when you are training the model on this, you test also on this. Now, I would explain you this very interestingly. We would understand this with an exercise. See, I would make it more simple for you. Pay attention. This type of students, we would understand it with the story that you would never forget. Imagine that the case number one, there is case number one, and we would see that the hero of our story is Gajodhar. Why I'm explaining you with this story? Because this question would be definitely asked. Okay, Gajodhar goes for a tuition, and in his tuition, basically, he is being taught by his instructor. Let's say Shibrat is the teacher. Shibrat is the teacher for Gajodhar. Now Shibrat is teaching Gajodhar to write an essay on his favorite animal. On his favorite animal. So Shibrat has done a very excellent task. He is trying to explain Gajodhar in a very good manner that how to write an essay, what are the general things, what you need to write. Everything he is explaining Shibrat. Shibrat is explaining everything to Gajodhar. But now this Gajodhar is like type of a backbencher student. Okay, he is like a backbencher student. So this student, he is not paying attention in the class, not learning anything. So Shibrat basically took a test in tuition. Understand that, test in tuition, and he got out of 10, he got just 2.5 marks. Next day, Gajodhar goes to class. Understand the story, very important. He goes to class. In the class, understand this two test difference. What test Shibrat has taken? Shibrat has taken a test, same. He told him to write an essay on favorite animal itself. So whatever Shibrat has taught, he asked Gajodhar to write the essay on that only. In that, he got just 2.5 marks. In class, when he went, he has, let's say, Arihant as his teacher. Now, Arihant took a test. In this time, he asked Shibrat to write an essay on his friend, his favorite friend, his best friend. Now, Arihant has not, Gajodhar has not performed very well on tuition, also not during the time of his training. So he has done very bad in the school test also, and he got just, let's say, 2 marks out of 10. This is called as low bias and low variance. Sorry, high bias and low variance. Why high bias? Pay attention. This is the training phase. This is the training phase of a student. And this would be low variance, because no matter what happens, this person would not change. So this is low variance. Now see the take number 2 here. Okay, take number 2. I am giving, this is case 1. We are directly jumping here to, let's say, case number 2. Let's understand case number 2. In the case number 2, same scenario. This time again we have the same hero, Gajodhar. Now what Gajodhar does here is he goes to the tuition. In tuition, again, Shibrat is teaching him how to write an essay for his favorite animal. He has done very good. He is performing very good. And out of 10, he got, let's say, 8 marks. He has done very good job. Then he went to school in the same way. And he was asked, because he has understood everything, he know that, okay, essay should be written first, the introduction. Then after that, you need to give some qualities. And then you need to conclude it. So he has understood this, and he has generalized it. So during the testing time, when a favorite friend essay was there, on that also he performed very well, and he got 7.5 marks out of 10. So this is like a good student. Now let's see the climax of it, the case number 3. This time we would make Gajodhar the villain for our session. Let's see that. So basically, again, the same story part that he goes to the tuition. This time, again, Shibrat is teaching him, and he is writing the essay. And this time he performed very well in the tuition. So he has written a favorite animal essay on his favorite animal, like my favorite animal is cow. Cow is a holy animal. Cow gives this liter of milk every day. So whatever Shibrat has taught him, he has word to word memorized it. Keep in mind what I'm saying, word to word, he has memorized it. And he got 10 out of 9.7, let's say, in the test. Akash, you said well, and he performed very well in the training. Yes. Now, here comes the last part of it. When he goes to school, again, he got an essay on his favorite friend. And guess what Gajodhar did at this time? He has just changed, instead of writing a favorite, writing an essay on favorite friend, he just changed, instead of cow, he has written his favorite friend name. So let's say Raju. Raju is a holy animal. Raju gives 4 liters of milk every day. Like this, he has written the essay. So in training, he got 9.7, but in testing, he got 3 out of 10. I don't know how he got 3, but he got 3 out of 10. Yes, this is the climax of the story. So this type of student, you can say that, if I just summarize it, if you have watched Three Idiots, you know that this type of students are like Chatur, where they very much overfit on the data, okay, where their training accuracy is good, but the testing accuracy is very bad. The main thing to keep in mind here is how you would identify whether it is overfitting or not. If your training accuracy is, let's say, very good, 95%, and your testing accuracy, there is a huge gap, let's say 72%. This is called as overfit scenario, when there is a huge gap in training and testing. Training accuracy is, let's say 85%, and testing accuracy is, let's say 83% or 82%. This is an ideal scenario. This is called as best fit. So this is like a front bencher students. This is like the mid bencher students. Okay. And the last one that you have is a back bencher students, the case number 1, in which your training accuracy is also very low and your testing is also very low, let's say 20%. This is called as underfit scenario, where your model is underfit. Here it is overfit and it is best fit. Now, this is the major problem in decision tree. What is the problem in decision tree? Decision tree gets overfit. So overfit mein kya situation hai? That bias is low and variance is high. So if I make this variance low, my problem would be solved. Before going to random forest, one more story time. So imagine that now we are, yes, stories time. So imagine that again we are 30 in the session and I want one of you to be class monitor. We are going to very school level examples, but this is something you would never forget. I can guarantee that. Try to forget, you would never forget this. I am asking that one of you would be class monitor, but I have some my own rules. Let's see what are the rules. The rules is I have already selected 2%. Randomly, I have selected 2%. So out of 32 are selected for here. Let's say that 2 of them, I would take any one of this Johnson, Abhijit and Abhishek. Okay, I'm taking here Abhijit, Abhishek and Abhijit. So we have 2 candidates. Now, what I'm saying is, okay, from this 28, I'm selecting one of them random. Let's say I have selected one of them random, and that is Ekansh. I have selected randomly Ekansh here. And I'm saying, Ekansh, that you select one of them as your class monitor. Now, let's say Ekansh has selected Abhijit. Is that correct? How it is correct? That is totally wrong. This may happen that Ekansh is Abhijit's friend, and then he has taken this decision. Yes, Ekansh is totally like in a favor with Abhijit. So will that be good? No. You cannot rely only on one to make a decision for rest 28. Right? Yes. So that happens with decision tree. What happens is you have one data set completely. You have completely one data set and you make a tree here. Okay, you make some tree here and you completely rely on that tree. So what may happen that this tree is completely focusing, or this tree is completely biased. Don't get confused the bias with this bias. I'm talking about English bias term, which means that this decision tree is giving more importance, like Ekansh was giving more importance to Abhijit. So same way, this tree can give more importance to one feature. That is the problem. Instead of just asking one person, I would say that I would ask this 28 of them. So all 28 of you would vote, and from 28 we would take here majority. Or simple, I can say that aggregation is also majority or aggregation. And based on that, now let's say all 28 of you select anyone, that would be our final decision. This is again a very favorite topic for interviewers, bagging and boosting. So you have just now understood a concept called as bagging. Now let's understand what is bagging. Bagging is a short form of bootstrap aggregating. So combining these two words, B and this bag, from here, this bagging word came. Bootstrap aggregating. Let's understand each and everything here. What is bootstrap and what is aggregating? Very simple, really very, very simple it is. So let me see if I have some diagrams here so that I can explain you. Decision trees have been around a long time to suffer from bias and variance. We will have a large bias with simple trees and large variance with complex trees. Ensemble methods combine several decision trees. Ensemble methods combine differences to proceed. Yeah. So I would explain you what is ensemble methods. If I have any example, yes, this is the bagging. So now see, this is the bagging thing. What is bagging? First of all, before understanding bagging, you need to understand one more thing. First thing that you need to understand here is ensemble techniques. The right now that you said a big yes here, that yes was that you have understood bagging, and the bagging is a part of ensemble. Ensemble, it is also called as ensemble techniques. What do you mean by ensemble techniques? Ensemble means assemble, which means that grouping the techniques together, grouping all of them. See what we have done here. We took all this 28 instead of just one person. We took all this 28 and we combined their voting power. Instead of taking one voting power, we took here 28 voting powers. We took 28 voting power and we combined that 28 voting power. That is called as ensemble. So imagine this in a minute that Tanaz has made right now 4 models. Okay, just think for it a minute. So Tanaz, instead of making one model, he has made 4 models. Model 1, Model 2, Model 3, Model 4. And then he is trying to combine the predictions of all the 4 models. Do you think that this would be more powerful than only doing one model? Which would be more powerful, taking 4 models or taking one model? Combining all 4. That's perfectly right. Here, yes, teamwork, perfectly right, Mahesh. So here we make 4 models and we combine the power of all 4. Like you have seen Power Rangers. You combine the power of blue Power Ranger, green Power Ranger, and they make a team here instead of one model. So ensemble techniques are used a lot. If you see the Kaggle competitions, if you see in real world, this ensemble techniques are used a lot. One technique is bagging that we are going to see today in detail. And another ensemble technique here is boosting, bagging and boosting. They go together, like like you have Abbas and Mastan. They work together, Abbas, Mastan, Neil, Nitin, Mukesh, like that. Here you have bagging and boosting. So this bagging and boosting is Abbas, Mastan for machine learning. They work together. So now we are understanding one part of it, that is bagging. Bagging stands for bootstrap aggregating. Now, trust me, only this name is difficult. The concept is really very, very, very simple. Trust me, simplest concept that you have learned, it is bootstrap aggregating. Let's understand this with an example. So I would do one thing here. Yeah, let's take this just a second. We would take that in our sheet. So this is your ensemble techniques. Let's understand that. So what happens in ensemble technique and basically in bootstrap aggregating, you have a big data set. So you have a big data set. Imagine that Mahesh is working on, you have 1000 rows here, 1 to 1000 rows, and you have 20 columns, 1 to 20 columns. Now this is your big data set. What you do first, you create a training sets here. Training set 1, training set 2, training set 3, like this. Bootstrap, this is called as, these things are called as bootstrap sampling. So we would take the data set that we are very much fond of, that we are working from first day. this data set. Let's come to this. So I'm showing you the real example for this. I have this data set. Now, I have here index 7, 5, 9, 10, 8, 10, 10. We got 7, 5. We have taken 7, 5, 10. Let me see. We have taken 7, 5, 10. Then we have taken 9 also. Then 8 also is taken, 10, then 3. So I took here 7th row. So basically my new data set would include 7th row. So my first row would be the 7th row. What it is, like I have here, let me write that 7, windy, no, poor, and cinema. Then I have 5. So this is my 5th row. So this is 5, that is rainy, no, rich, and stay in. Then I have here 9. So I have here 9, that is windy, yes, rich, and cinema. And then I have here 10. So 10 is this 10, sunny, no, rich, tennis. Then I have 8. So 8 is this sunny, no, 8 is windy. So windy, no, rich, shopping. And then again I have 10, sunny, no, rich, tennis. Then I have 3. So 3 is windy, yes, rich, cinema. Now why I did this, again, the small things that I'm doing in session, you would never forget this question at time of interview. So basically this complete process that you did a minute before, this is called as bootstrap aggregation. Basically, what is bootstrap aggregation? It is sampling with replacement. This is called as bootstrap sampling. Now you have seen a lot of new words. Let's try to understand what does this mean. Sampling with replacement, which means that if you have paid minute attention here, that someone said 10 and I have again included 10 here. This means that when first, for example, let's say first value was selected by Ekansh. So Ekansh selected here 7. So it means that it doesn't mean that once Ekansh has selected 7, no one else can select it. So I have selected 7 here and 7 is back again into this data set. So even Shatrughan can select 7 now. Like Ekansh has selected 10 and Krishna also selected 10. This is called as sampling with replacement. Okay, sampling with replacement. So you randomly select some samples that can be repeated also again here. Okay, and you get a small subset of data. See, all the data points are not included here, but some data points are included. Again, there is one change in this. We randomly select this and we randomly also select, this is for rows. Okay, now you also select randomly the columns. One more thing, you randomly select the column, but columns are without, there's a difference, but the columns are without replacement. So which means that now, for example, let's say Krishna says that I want to keep a column of weather. Okay, now again Deepak cannot say weather because weather is selected once, it cannot be replaced now. So this means that you cannot have a duplicate column here. The column would only be once. So weather is there. Now I would remove some column here. Let's say I'm removing this column, the money column. So I have removed the money column. Same way, I can remove one more column if I want, but our data set is very small. So I would just keep this like this. Let's say this is also one of our column. I'm removing this also. So I have kept a data set with 2 columns that is going to predict my C. This is called as the complete in-depth with story example of bootstrap sampling. So you create this is called as bootstrap sample. You create one sample like this. Okay, this is my one sample. So I would write it here. This is my, I would write it in very bold. This is my sample one. This is my sample one. Same way now you can select anything randomly. Okay, this time I would remove this. Just a second. This also I would remove. So now I would select some randomly some other points. 2, 8, 6. So I would also select, let's say 2 once again. 1, 3, 2. Okay, this like this. So see that 2 is repeated again and again. So this is my new data set. This time I would again remove some columns. We have removed parents that time. This time we would remove this no column. What is this no and yes column? And we would remove, let's say, Windy column also. So this is how I have now new other columns, and this is my sample data set 2. Okay. So in this way, you create different bootstrap samples. Like you may create like this 100 samples till S100 and see the magic. Now you would create for every sample. Let's come back to our point. So this is how you have created training set 1, training set 2, training set K. For every training set, you would create one more tree, one tree here, one tree here, one more tree here. Like your decision trees that I have taught you yesterday, you would make that decision trees, and then you combine the prediction of all of them. This is called as random forest. Okay, so this is the overall concept of decision trees. Okay, if this is the overall concept of decision tree. Now nothing is left in, overall concept of random forest. Random forest basically use the technique of bagging. Bagging helps you and can helps in reduction of variance. Why it would help in reduction of variance? Let's understand that. So if I change my data set, how much my model would change? Now imagine that I have this data set. What I do in bagging, instead of working on this one data set, I create like chintu data sets here, like small data set for them. Data set 1, data set 2, data set 3, data set 4, data set 5. In this way, I would create, let's say, 100 data sets like this. So I would make here 100 trees now. So one tree, second tree, third tree. So in this way, I would make here 100 trees. Now imagine that Shibrat comes and makes some change in this data. Let's say he has randomly changed 100 rows. From 1000, he has changed 100 rows. That is 10% change in data. So this 100 would be changed, like some part would be changed here, some part would be changed here, some part would be changed here, some part would be. So overall, your impact would be distributed. When your impact is distributed, your variance would be very low, which means that your model changing would be very low. This model would not change much. A small change in the model it would be. This is called as very low change in variance. Okay, now let's get started with the first part of it, that is scaling. What is scaling and why do we need it? Scaling comes under, this topic comes under data preprocessing. Data preprocessing means that we make some changes in the data set before giving that to the model. We make some changes, or in simple, you can say that we manipulate the data before giving it to the model. So before giving it to the machine learning model like linear regression, logistic regression, decision tree, any model, before giving to them, we make some changes in the data set. And that depends, first of all, which type of data you have. Right now, we are working on two types of data. First is numerical data, and next one is categorical data. What all steps can be there inside data preprocessing? Let's try to understand that. So we are scaling is only there for numerical data. So whenever we say scaling, we only do it on numerical data. So let's try to understand what is this scaling. Imagine this, you have a data set, okay? And that data set has two values. like it is written in kilometers. So you have kilometers like this, 5 kilometers, 6 kilometers, 7 kilometers like this. And you have here the same thing in meters. So it would be 5,000 meters, 6,000 meters, and 7,000 meters. Now, these are the two columns for you. Again, you can consider instead of this another data set also. That data set has again two columns. Let's assume that again it has two columns, and two columns here. One column is age and another column here is salary. Now, age is in basically we are talking about any employee. So age would be, let's say, keep here age is 50 and 59. And the salary here is 4,500. And here is 4,500 and so 4,500, 4,000, 45, sorry, 45,000, 45,000 and 100. So these are the salary of 2%. So it's very clear that just think for it logically. What is the age range of employees? 20 to 60 is the age range. Like normally people start in 20 years and till 60 years they work, correct? So any value cannot be greater than less than 20 and greater than 60, like around that range. Some can be there 15, 16, no problem. Some can be 65, 70, but I'm saying that the range is always 20 to 60. Salary range, now there is a very big salary range. It can start from 20,000, let's say, till it can go to 20 crores also. So there is a very, very big range in this. Okay, if we consider a normal range, 20,000 to it may be around, let's say, 2 lakh rupees. Okay, something like that, we would keep a range here. Now see that this two variables has a very different range. Very, very different range. Whenever you would use the algorithms like distance-based algorithm, pay attention now here, distance-based algorithm. Distance-based algorithm means in algorithm in which we calculate the distance. In linear regression, while calculating RSS and all that, we calculate the distance. So all the distance-based algorithm like linear regression, even in logistic regression, you would understand gradient descent. Okay, I would explain you gradient descent. In that, you would understand how it would affect the logistic regression also. So all this algorithm, linear and logistic regression, which are distance-based algorithm, are affected by this range. How they are affected? Let's try to understand. If you want to find the distance between these 2 points, let's assume that we have them on X and Y axis. So this is like X axis is the age and Y axis is your, let's say, salary. So here something is 4,500 and here it is 50 years of age. It's 59 here. So 1 point here and 1 point some, let's say here. So if you want to calculate the distance between them, just keep that in mind. If you want to calculate the distance between them, how it would be? You would first calculate the X distance. So that is, so there is a simple equivalent distance formula. If you know that, it's basically 59 minus 50, 59 minus 50, square of it, plus this 45,000, and here is 45,100. So 45,100 minus 45,000. So this is the formula to calculate the distance. You might have seen that in your school days. So it would be around 9 square plus 100 square. If you take the distance, 59 minus 50 is 9. 4,500 minus 45,000 minus 45,100 is 100 square. So this is how the distance would look like. Basically, in this type of scenario, your model would give more importance. Keep my words, mark my words, understand my words. Model would give more importance. Model would give more importance to the feature with high range. Okay, because the distance of them would be very high, like the distance is 100. So more importance would be given to this variable because their scale is very high. But while predicting salary, age is also important. So this is giving a wrong interpretation to the model. Imagine that, just think for it logically. Nothing rocket science here, just simple is. Now, if you don't have any knowledge, Okay, if you don't know anything about them. And if I say you that, okay, tell me, Mahesh, give me this answer. 5,000 is greater or 5 is greater? Which one is greater? Perfect. So like Mahesh said, 5,000. Now it's very simple that computer would only understand the numbers. And as this number is greater, it would give more importance to this. But actually that is not the case. As a human, you can clearly understand that it's a kilometer and it is in meter. Actually, both of them are exactly same. Everyone agree that both of them are same? Yes, both of them are actually same. So this is the problem that scaling solves. One more. I would explain you this. Now, for example, what I'm doing, I'm changing this data set a little bit. Pay attention, what is scaling now? So what I'm doing, I'm just changing this data set and I'm saying that salary in, the new thing I'm adding here in salary in thousands. Okay, salary in 1,000. Basically in that, I would remove this 3 zeros and I would remove this 2 zeros. So it would be 45.1.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, it would be 45.1 and it would be 45. So I have just changed that the column name to salary in thousands instead of normal salary. So it representing exactly the same, just this range has been changed here. Again, calculate the distance now. This time it would be 59 minus 50 whole square plus 45.1 minus 45 square. So that would be 9 square plus 0.1 square. So you can clearly see, now clearly see that here it came down to 0.1 square and here it was 100 square. So your model can change a lot if you do not scale them properly. It would give more importance to the variable with high numbers. That is the reason you require scaling. Scaling means that all the value, now what is scaling? Scaling would solve that problem. Okay, Akash, if you have this problem, we have scaling. Scaling will bring all the values in same range. So your problem is solved. Correct? If I bring this 59 to 15 in the range of, let's say, 0 to 1, and this 45 also in the range of 0 to 1, my problem is solved. Yes. So that is called as scaling. Basically, whenever you have a huge range in values, for example, if you have two columns in your data set, one column is age and another column is salary. Age, maximum range of age is from 20 to 60. Okay, like a salaried person I'm talking about, 60 years of age. And salary can be from 20,000 to 2 lakh rupees. So there is a huge difference in the range. If you give this type of columns to your data set, to your machine learning model like linear regression and logistic regression, your model would perform, your model can give more importance to this salary column and your results can be wrong many times. So what we do, we apply scaling on top of it. Scaling is, it would bring all the values in the same range. There are two types of scaling here, mean max scaling. And the next one here is standardization. We would understand both of them. Mean max is also called as normalization. Mean max normalization it is called, and this is called as standardization. So what is mean max normalization? Very simple formula is there for that. That is xi minus a min divided by a max minus a min. Let's understand this. We have a data set that is 5,000. We would assume this data set 5,000, 6,000, 7,000 and 8,000. Okay. Same data set we have here, which is 5, 7 and 8. So see how interesting it is. I'm doing the complete maths in front of you. This is meters. This is kilometers. Now see, we would put that into the formula. Pay attention how I'm putting it. The first value, we would first convert this kilometer. So we need to take this 5 we would need to put as x. So 5 minus What is the minimum value here? That is 5. So 5 minus 5 divided by maximum minus minimum. What is the maximum value here? You need to do it column wise. So forget about this column. Completely forget about this. So what is the maximum value here? 8. So 8 minus minimum value is 5. So that is 5 minus 5, 0 by 3. So that is 0. So first value that came to you, I am creating a new data set here. So kilometer, first value we have converted, that is 0. Then let's put the next value. X value would change this time. It would be 7 now. So 7 minus minimum is again 5. Maximum minus minimum, that is 8 minus 5. So 7 by 5 minus 2 by 3. So that would be 0.66. So 0.66. Same way, third value we would put here 8. So 8 minus minimum is 5 divided by 8 minus 5. So that is 3 by 3, that is 1. Same we would do for meters now. So we would put 5,000 this time. So 5,000 minus, what's the minimum value here? Again 5,000 divided by maximum value is 8,000 minus 5,000. Simple maths. So that would be 0 by 3,000, that is 0. Same way for 7,000 we would do it. Now here it would be 7,000. That would be 2,000 by 3,000, that is 0.66. Same way. Then again we would change this to 8,000. So that would be 3,000 by 3,000, that is 1. Yes, that is the power of mean max normalization. One more thing to note here, that mean max normalization always keep your values between 0 and 1. It cannot be greater than 0. It cannot be less than 1. Sorry. It cannot be greater than 1 and it cannot be less than 0. Always the values are between 0 and 1. So whenever you want to scale your data between 0 and 1, you are going to use mean max normalization. Now, the next point of it. This is little bit math heavy, the standardization part. Before understanding standardization, you need to understand 3 things. That is mean, variance, and standard deviation. So for this, we would cover our get a one data set. Okay, I would explain you in the simplest manner, so that after that you would never require the revision for it. So let's consider that we have a data set. We have values like this 1, 2, 3, 4, till we have this till 10. Let's write that simply. 4, 5, 6, 7, 8, 9, and 10. So we have this 10 values in our data set. So first thing is we need to calculate the mean of it. Mean is very simple, straightforward. All of you already know that. We sum all the values. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. And we divide it by the total number of values, that is 10. So the mean of this is 5.5. Perfectly correct. Now, once you got the mean, let's understand the variance. We would understand a bit detail about variance. So what is variance now? First, we would write a formula and then we are going to understand this. So variance formula is basically summation of all the values. Okay, so let's forget about this. What you do in variance, we take the first value, that is x, minus mu, that is your mean. This is called as mu. So x minus mu, okay, and you take square of that. X minus mu, you take square of that. And you do it for all the values. So x would be your 1, x would be your 2, 3, 4, 5. You would put that here. You sum all the values and you divide it. So simply what we are doing here, let's do that. X is your 1. So 1 minus 5.5. You take square of it, plus 2 minus 5.5, square of it. And you do till this 10 minus 5.5, square of it. And you divide it by n, that is 10. So you got here 9.6. What is this 9.6? If you minutely understand here, you would understand the variance, that you never need a revision for it. Let's try to understand. So imagine that you have this circle. You have some data points here. What is this mean? Mean is basically the center of this. You can simply say that here. This is called as your mean. Now, what is actually the variance? Just visualize this. Okay, variance mean Various means how much your data is spread. So basically, if you see that the spread of the data is like this, it is little bit far away. Okay, that is called as variance. Variance means how much it is variated from mean, how much it is away from the mean. Imagine that I have the similar type of data where I have, instead of this, let me erase this now, and I have some data points like this, where I have 1 point here, 1 point here, 1 point here, 1 point here, some points here. Okay, some points here, some points here, some points here. So, and if you take a mean of it, let's say the mean came out to be here. Now you can see that here the spread is very high. Variance means the spread. Some points are very close, but some points are very far away from here. That is called as the spread of the data. Variance say you that how much your data is spread. Perfect, perfect, perfect. So that is called as variance. Now what is standard deviation? Standard deviation is just under root of your variance. That's it. You just take a under root of it, and that would be a standard deviation. So if your spread is very high, your standard deviation would be high. If your spread is very low, your standard deviation would be very low. That's it. Now what you do in standardization, we were on the topic of standardization. So what you do in standardization, there is a simple formula for it. You need to use Z equals to X minus mu by standard deviation. So that's the reason I have explained you all these 3 points, because you now understand that this is mean and this is your standard deviation. So you would put the values inside this and you would get your data standardized. You would put that into this and you would get your data standardized. For example, let's try to put that. But we need to calculate mean and okay. So we have for this, for this data, we can do that. So this is D 1, 2, 3, 4, 5, 6, 7, 8, 9. Mean is 5.5 and standard deviation is under root of 9.6. So we would put that into the formula. The new Z value, the new column would be, so Z value is equals to, first value is 1 minus mean is 5.5 and standard deviation is under root of 9.6. Same you would do for the second value. That is 2 minus 5.5 under root of 9.6. So in this way, you would get 10 values here. If you put that into like Z1, Z2, if you do till Z10, that would be 10 minus 5.5 under root of 9.6. So this, the data that you get here would be standardized data. Basically, the scale of this data is such that your mean is 0 and your standard deviation is 1. After you would do all these operations, you would get 10 values, Z1, Z2 till Z10. For this 10 values, the mean is 0 and standard deviation is 1. So this is basically your data set. When to use which method? When to use which method? So basically, in general, we use mean max normalization. Okay. But if your data, so there is no rule for it. You can use anything anywhere. But if your data is normally distributed, you know that in statistics class, I think everything is covered for you. If your data is not skewed and if your data is normally distributed like this, you would use standardization. If your data follow normal distribution, if your data follow normal distribution, then you would use standardization. Else you use mean max normalization. Different techniques you are going to learn with me, like PCA technique. In that you need to use standardization. What is PCA? You would see that when you are working with images, let's say you are doing some deep learning projects, OpenCV projects, you need to use mean max normalization. So I'm writing that here. In future, it would be helpful for you. In the case of images, you go with mean max normalization. In a case of PCA, you use standardization. In future, you are going to understand that in more detail. So this is all about scaling. Encoding, why it is needed. So whenever you have a data set, now you clearly know that you have here categorical values. The main problem right now is computer Computer cannot understand anything other than numbers. Other than numbers. So computer cannot understand anything other than numbers. So your sunny, windy, rainy, it is not number. Yes and no, they are not number. Rich and poor, they are not numbers. Cinema, shopping, tennis, stay in, these are not numbers. So it's simple that you need to convert them. You need to convert them. And this conversion is called as encoding. So there are two types of encoding. There are two ways you can encode the categorical data. The first way is one hot encoding. This is also this is similar, or you can say exactly for now you would see this. You can see that it is exactly like dummy encoding. What is the actual difference between one hot encoding and dummy encoding? I would show you later on. But for now, both of them are same. You can use them interchangeably. And the next one here is label encoding. Let's try to understand that. Really very interesting. Really very interesting. So, for example, I have a data set where I have here sunny, rainy, and windy. Sunny, rainy, and windy. Let's try to understand that. We have sunny, rainy, and windy. Okay, or we would start with a simple one. Let's not go to the hard one. Let's start with the simple one. We have gender here. Now, gender is male here and female here. So I would have male, female in the data set. I have these values. Now, if I want to convert that to integers, I use dummy encodings, one hot encodings. You can also call them as one hot encodings. So what we do, instead of gender, we create a column called as male underscore gender. And I would create one more column that is female underscore gender. Now understand this. In my data set, wherever there is a male, okay, I would write 1 here and 0 here because this is a male. If it is a female, I would write here 0 and I would write here 1. If I write here male 1, 0 here. Female 0 here, 1 here. Now this is male, so 1 here, 0 here. This is male, so 1 here, 0 here. Do you think that encoding is done? Seems like encoding is done. So instead of this, tell me, instead of this, if I remove this column completely, and if I give you this 2 columns, can you tell me what is this person, whether this person is a male or female? You can clearly say that it is a male. This is called as dummy encodings, or it is also called as one hot encoding. Why one hot encoding? Wherever there is one, which means that that person, that is the category present, male category is present here. Now Tanaji says that, Akash, why you are doing so much? We can do a simple thing here. That computer do not understand the number. So Tanaji says me that, okay, if computer cannot understand the number, just let's do one simple thing. That is, male is encoded as 0 and female is encoded as 1. So instead of doing all these 2 things, I would have a new column that would have 0, 1, 0, 1, 0, 0. Again, from this, now can you tell me, is this person a male or female? Is this encoding done? Yes, it is done. Understand, there's a difference here. Here we are encoding here male as 0 and female as 1. When it goes to computer, tell me, 1 is greater than 0. This is correct, right? So in your computer, it would be interpreted as female is greater than male. Is that the case? No, actually here there is no order. Female and males are same. This type of features are called as nominal features. Nominal features means when there is no level, there is no order in that. Black and green are both exactly the same level of color. So black, green, male, female, this all are nominal features. Perfect. Everyone agrees with me. Now I am giving you one more challenge. If I remove any one of this column, let's say I remove completely the female column. You don't know anything about this column. And if I ask you based on this one column only, tell me whether this person is male or not. Can you tell me that? Perfectly, yes, you can do that, because here male gender, so wherever there is 1 it is a male and 0 it is a female. So you don't need the second column here. Same way for female as well. You don't need the male column here. If any one column is there, your problem is solved. So what you do in dummy encodings, first you create the one hot encoding, and then you remove the extra column from it. It can be female or it can be male, no problem. Any one column you remove, and that is called as your dummy encodings. Label encodings are used wherever there are ordinal features. What do you mean by ordinal features? If I say you that we have a grading system. We got here the first student, second student, third student, fourth student. First student got A, second got B, third got A, fourth got C. Now, if I give them a label as just simple 0, 1, 0, this would be, and this is 2. Now this order makes sense. 2 is greater than, okay, I would give it in the opposite case order so that it makes sense for you. This is 2, this is 1 and 0. Now, can you make the sense here that 2 is greater than 1 and 1 is greater than 0? This makes sense? Grading system? Yes, whenever your features have specific grades, like not grade only, whenever there is an order in your data set, like A is always greater than B, in that case, you use label encodings, where you don't need to do anything. You can just note it 210 and your part is solved. One more example. Now, if I ask you what is your qualifications, So someone says that my qualification is MTech, someone says that I am PhD, someone says that I am BTech, someone says that I am BCA, like this. So you can clearly see here a level like PhD is greater, then MTech is smaller, and BTech is much smaller than that. So in this type of scenarios, you use label encodings and not dummy encodings. Whenever there is an order in your data set, like whether it is a grading, in grade you have a specific order, A grade is better than B grade, like that if you have an order. Or if there is an education column, again there is an order, like BTech is smaller than MTech, PhD is greater than MTech. So whenever there is an order present in your data set, we would use label encoding. What is label encoding? Label encoding means that you directly give the values like this is 1, this is 2, and this is 0. So here is a specific order. In dummy encodings, you can only give just 0 and 1. And that too, 0 can be there for male also, 0 can be there for female also. So there is no order in your get dummies. Trust me, this is the most easiest algorithm that you have ever seen, like more easy than your linear regression as well. It is just the probabilities that we are going to see today. It is just like simple probabilities that we are going to see today. So first we are going to understand the mathematics behind it. And then I have really two beautiful case studies for you. That is the coding case studies. One is text classification. Another one is your normal, like you can apply this on any data set. We are going to try that on multiple data sets. This Naive Bayes Classifier today. That is Naive Bayes Classifier. So up till now, we have covered decision trees, linear regression, logistic regression, random forest. Linear regression, we used it for, let me open up our notepad and let's start in that. And this is Naive Bayes here. Let's see this in detail. Okay, so let's get started now. So in Naive Bayes theorem, basically we have seen one very so up till now what we have covered linear regression. Linear regression was used for classification dataset, regression dataset, that is continuous dataset. Then we have logistic regression. Then we have covered random forest and decision trees. So logistic regression also works on classification dataset. And basically random forest and decision trees, they both work on linear continuous as well as classification dataset both. So they work both on that. We have seen the complete part of it, the coding exercise, the missing value treatment, the outlier treatment, the encodings, the normalizations, the evaluation matrix, that is confusion matrix. We have seen all that. Now, today we are going to see a new algorithm, that is Naive Bayes. And you have already seen that it is used for a classification. So it is another algorithm that is used for classification. And it is the most easiest algorithm just based on probabilities you would have, very interestingly. So let's start this. Naive Bayes classifier assumes that presence of a particular feature in a class is unrelated to the presence of any other feature. This part I'm going to explain you in detail. And we would start it with a simple formula first. And then we are going to see it one by one, how to calculate all these probabilities, what is conditional probability. Okay, how to calculate these probabilities, that also we are going to see in detail. Conditional probabilities, okay, and Bayes theorem. Everything we are going to see today. Okay, and then we have a data set as well. We would try with that data set as well, how to calculate the probabilities of each of them, and then the hands-on on it. So the first thing, let's start with the probability here. So now, all of you know that probability has a simple formula, that is divided by total outcomes. That is the probability formula. Now we are not going to learn everything in scratch from probabilities. Whatever is an important part, that I'm going to explain you in a 100% detailed manner. So for example, we have a coin. Coin has heads and tails. So total outcomes in a coin is 2. This is 1, this is 2. So your total outcomes are 2. And favorable outcome. So for example, Ekansh wants a head. So he would write here probability of head. How many heads are there? Just 1. So 1 by 2. So probability of getting a head is 0.5. Same way, probability of tail also would be the same. There is 1 tail and total outcomes are 2. So it would be 0.5. Now let's try to make a little bit of complex example so that you can understand it much better. So now I'm giving you a new situation. Try to answer this. I'm saying pick a diamond. So all of you, so first let's get the cards. So let me show you that card of deck. So I'm going to show you some cards. Let's try to understand the probability in detail because this would help us a lot. This, you should know this terminologies. So let's take that. Yes. So this one we are going to take. Okay. So these are the namings that in interview also, if you get this type of questions, so remember that. What are the names? Because these names would help you a lot. There is spade, hearts, diamond, and clubs. Now, if I say you that pick a diamond, now that is a queen. Now see, understand what is my question. I'm saying you that you should pick a diamond. How many diamond cards are there? There are 13 diamond cards. Now, I'm saying you that from this diamond card, I want a queen. So understand, this is a conditional probability. This is a little bit different of what you have learned up till now. So now what you have seen up till now, that was a normal probability. Now you are learning something new, that is conditional probability. What do you mean by conditional probability? Conditional probability means that based on some condition, you are going to calculate the probability based on some condition. So for example, I said you probability of you have all the diamond cards. Pay attention how it is read. What is the probability of queen when you have a diamond card? Understand how to read this. How you read this? This is the condition that is given to you. And this is the probability. This is the probability that you need to find. Simple as that. This condition is given to you, and this is the condition that you need to find. That I know that I have all the diamond cards. Now, what is the probability that I would get a queen? This is called as conditional probability. There is some condition. It is not like a normal probability of heads and tails. It is a conditional probability. First of all, what is conditional probability? Is that clear? The formula for that is, we would write a simple formula first. I'm going to give you a trick so that it's very easy to remember. And A is to be calculated. Now, the first thing that you do for this formula, there is a very simple formula here. Pay attention. The formula is probability of B given A. So this can be written as B given A into probability of A divided by probability of B. So Akash, how it is simple? It's tough. I would make it simple for you. See how to remember this formula? Very easy. First, you reverse this part. See, it is A given B. Sorry, B given A. Here B was given to you. You need to calculate here now A given B into probability of A divided by probability of B. So the numerator, the thing that is the first. Okay, A is your first thing, B is your second thing. So you take A on the top and B in the denominator. Simple as that. Can you tell me now, based on this, can you tell me what would be the formula for this PQ diamond thing? Try to write it. Okay, you need to write the formula based on this, the trick that I have explained you. Let's understand this. It is exactly same like I have explained you. If you have just paid attention to this, you would be able to solve this. What I said, the first thing is to reverse this. So P of queen is here, diamond is given to you. Now you would write here diamond, and you know that queen is given to you. Okay. Now after that, you are going to multiply that with the numerator, the first part, that is P of queen, and divide by P of diamond. So this is how you write the formula. Now see, it's very simple. You just need to put the values here. What's the values? Let's try to put the values now. And it's really very simple. How to calculate the values, that I'm going to explain you now. Okay. So now, like I said, we would put the formula here. Okay, let me write that once again. So what it was, P of queen given diamond is equals to P of diamond given queen into P of queen divided by P of diamond. Now see this formula, why I need you to remember and recognize, and why I have given you this trick, because this formula would be used throughout the session. Now P of diamond given queen. Now you know that you have queen. How many queens are there? What is the formula for probability? Total outcomes divided by favorable outcomes. So here now queen, what's the formula for that? Queen, there are 4 queens. So your denominator is 4 here. Out of that 4 queen, how many of them are diamond? Just 1. So your this answer is 1 by 4. Then probability of queen. How many queens are there? There are 4 queens. And total cards, how many of them are the total cards? There are 52 cards. So 1 by 4 into 4 by 52. Just simple. You need to think for a denominator, like what is your total outcomes, and the numerator. Now I want diamond here. How many diamonds are there? 13 diamonds are there. And how many total cards? 52. So that is 13 by 52. When you solve this, it would be 1 by 4 Now this is 1 and this is 13. And this is 13, 1 and this is 4. So it would be 1 by 4 into 1 by 3 into 1 by 30, 1 by 4. Okay, that is this part. So 1 by 4 into 1 by 3 is 1 by 12, 1 by 12 by 1 by 4, that is 1 by 13. So it would come out to be 1 by 13. So this is the final answer. When you solve this, you would get 1 by 13. I said 1 by 30. Oh, sorry, it would be 1 by 13 here, not 1 by 3. Being given that B is true, so it is given to that B has already happened. What is the probability that A would happen? That is conditional probability. This is also called as Bayes theorem. The probability, first you calculate the reverse probability, then you multiply the probability of A and probability of B, you divide it. This is called as Bayes theorem. Understand from the two words why I was focusing a lot on this formula, because from Naive Bayes theorem, Bayes theorem I have explained you in detail. We have seen a problem for it. So calculating the probability of second event, given that first event A has already happened. Consider so see, it is said that A has already happened. So it would be A given B. So you need to calculate this probability here. Drawing a second ace from a deck that we got an ace in first attempt. So it is clearly given you that the first card is ace. So what would be the probability of second ace? In this way, there are multiple probabilities. See, finding the probability of having a disease that we are tested positive. Now, let's say there is one person. Let's assume that we have Gajodhar with us. So Gajodhar is found to be COVID positive. Okay. Now tell me, if a person is tested COVID positive, does it mean that he would be having the disease? No. Understand, here is the thing, what I'm trying to explain you. So there are many scenarios like after 14 days, you start getting the disease. Okay, sometimes the results are also false. There are wrong results of COVID test also. Okay, so basically finding a probability of having a disease given that you are tested positive. So Gajodhar is tested positive. I want to find a probability that whether he has a disease or whether he not have a disease. This is a real case study industry level problem. Finding a probability of liking Game of Thrones given that person likes fiction. Let's say Ayush like fiction movies. Okay, science fiction movies. So what is the probability that he would like Games of Thrones? This is called as conditional probability. Every time some condition is given to you and you find the second probability for that. So event A is a probability that we are trying to calculate. Like I have already said you that, I have clearly explained you that A is a probability that we are calculating. B is a condition that we know has already happened. हो चुका है भाई, ये चीज हो चुकी है. So first we calculate, so the probability of occurrence of event A given that B has already happened, that is called as conditional probability. Suppose that we have a jar containing 6 marbles, 3 are black and 3 are red. What is the probability of getting a black given the first one was black? Let's try to understand that. There are 6 marbles in a jar. 3 of them are black, 3 of them are red. These are red and these are black. Now it is given to you that the first one was black. The first marble was black. What is the probability that second would also be a black? Let's try to see that. Okay, so suppose there are 6. What is the probability of getting that? Now, getting a marble in the first turn, getting a black marble in the second turn. So probability of A given B, that is probability of A given B into probability of A into probability of B. So A is given to you. Yeah, so I'm just trying to make this formula simple so that I can explain you this better. A is given to you and getting a first black marble in first turn into probability of A, that is 3/6, into first marble is 2/5, 2, 1, 3, 3, 3. So that would be 1/5. Now see, there is another variant of formula. That's the reason these are all the probability concepts. Now see, this thing which I have explained you, that is probability of, now see how we write in our case. Let's go back to the thing. Let me conclude this. Now see this part which you see here, probability of D into Q into probability of Q. This can be written as probability of D intersection Q. Okay, that is probability of D into probability of Q. Like this also it can be written as. Now, see here, this part can be written as intersection. Exactly the same they have written here. Probability of A and B both occurring together. Okay. So this formula, what we write in our case is probability of A given B. We write this as probability of B given A into probability of A divided by probability of B. So this can be written as in P A intersection B. That is P of A and B, not intersection exactly and. So whenever there is a and, we multiply the probabilities. So this is the complete concept of probability. We would not go much deep into it because that is not much required as well. So same thing they have done here. Probability of A and B. So that is probability of A into B. So probability of A is 3/6 into probability of B is 2/5 and divided by probability of A. That is probability of A is 3/6. So when you solve this, you would get 0.4. So in this way, the only thing is the way how they write the formula. Sometimes it would be intersection, sometimes it would be direct thing. So let's get started with a data set so that we can understand that in much better way what is probability and how does it works. Okay, so now we have a simple case. Naive Bayes. So basically this is our data set. I have 4 important features here: outlook, temperature, humidity, wind, and play tennis or not. Now I want to classify whether a person would play tennis or he would not play tennis. Not play tennis. It is a simple classification problem here that we are going to try. Now for that case, we have been given with 4 things, that is outlook, then the temperature, then the humidity, and then the wind speed. So based on these 4 factors, we are going to identify, we are going to predict whether a person would play tennis or not. So now, how to write this and what are the situations for it? So first of all, this problem can be written as probability of you have been given with some features. Okay, you have been given with some features and you want to predict the y for it. Y is your last class. Let me write the formula here so that you can understand that in much better way. Okay, so now what you want to predict here, you want to predict whether a person would play tennis or not. And probability of no, we are going to predict here. So let's assume that. Okay, so now see, let's frame the formula. Pay attention, everyone. It is the same example which I have explained you. Probability of, you know some features. Your features are like x1, x2, x3, and x4. We know outlook, we know temperature, we know humidity, we know wind. We know these 4 things. We want to predict whether a person would play tennis or not. Simple as that. It is exactly the same formula. How you are going to write this? Now, you are going to reverse this first. So probability of x1, x2, x3, x4 would be given to you. That would be like in the starting, and you have been given with yes. Into probability of y divided by probability of x1, x2, x3, and x4. This we are going to do. Probability of x1 into x2 into x3 into x4 given that it is yes into probability of y, and then divided by x1, x2, x3, x4. So in this way, you would calculate the probability of yes. Same way, you would calculate the probability of no also. Probability of no given same features x1, x2, x3, x4, and the same formula you would just write from the above. You would reverse this. So it would be x1, x2, x3, x4, given that it is no, into probability of no divided by probability of x1, x2, x3, x4. This is how you would find both the probabilities. This would give you the probability of yes. This would give you the probability of no. Whichever probability is higher, you would say that your class would belong to that. If yes is yes, probability is higher than no, then you would predict for yes. If no probability is higher than yes, then you would predict for no. It is as simple as that. See, trust me, this is the only formula you need to apply and your Naive Bayes algorithm is solved. Understand, we are increasing one class, okay, like yes, no, and maybe. So here the third thing would increase, that you would calculate the probability of maybe also in the same way. If it is greater than no, if it is greater than yes, like that. So probability of maybe given that x1, x2, x3, x4 in the same way. Solve this problem. The moment you see how to solve this problem, everything would seem very, very simple for all of you. So now it's just a matter of putting the values into the formula and getting that done. Let's put our formula down now and let's solve that quickly. So what things you need here? Let's try to understand. So here is our formula. And in this formula, first thing is this equation seems very complex. Let's try to break this situation. So probability of x1, x2, x3, x4 given yes. So how you can write this? You can write this like this: probability of x1 given y, that is yes, into probability of x2 given yes, into probability of x3 given yes, like this. Now, what does this mean? This means that you are trying to, you know that the classification is yes, this is given to you. You need to find the probability of this word, which means that you know that the person is playing tennis. Understand what it means. I'm trying to explain you probability of x1 given y. What is our x1? X1 is our outlook. So probability of y is given to you. So you know that the person plays tennis, which means that these three people, and then this people, they play tennis. We would not worry about the no people now, because we already know it is a yes. And we would only focus on the outlook here because it is x1. So we would ignore the temperature, we would ignore the humidity, we would ignore the wind. We have only the outlook. Now in outlook, we just need to count. See how simple the counting is. Let's try to count and let's try to find the probability, because probability is just nothing, it's just the counting of things. So now to count it, let's count it first for sunny. Okay, let's count it first for sunny. So in sunny, that is yes. Let's see how many sunnies are there. There is one sunny here and one sunny here. One more sunny there. Two sunnies are there. Not one, two sunnies are there. So basically there are two Sunnies, and how many yes are there? See, it's very simple. What is the probability formula? Total outcomes. That is total yes. How many it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the Sunny are 9 divided by how many Sunnies are there? There are 2. So 2 by 9. So you got the probability of x1. Once again, everyone pay attention. This is really very interesting and very straightforward. I want to calculate. I'm once again explaining that, and then I would take if you have any doubts. Let's remove this. Pay attention. So I have this very big complex formula, that is probability of x1, x2, x3, x4. Given that it is yes, I need to find out this. So I would break that into simple chunks, like probability of x1 given y, probability of x2 given y, probability of x3 given y, probability of x4 given y. Now, how to calculate all this? First, let's try to calculate this probability of x1 given y. It is given to you that it is yes. See, it is clearly mentioned that it is yes. So we are going to remove all the no things because we know that it is yes. So all the no things are being removed from here. Now, first thing that I need to calculate is probability of yes given x1. So yes is given to you, you need to find the probability of x1, which means that you know it is a yes, you need to find the probability of outlook. So in outlook, there are three things we would first calculate for Sunny. So what's the formula for probability? Total outcomes. Total outcomes, that is yes. How many yes are there? There are 9 yes. And how many Sunnies are there? Only 2 Sunny, 1 and 2. So you got 2 Sunny. See how quick it is. This is the power of understanding anything. That is perfectly correct. For overcast, how you are going to find? It's very simple. Again, overcast, how many of them? 1, 2, 3, and 4. We would not care about this Sunny now. So there are 1, 2, 3, 4. 4 overcasts are there. So 4 by 9. Same way, rain. How many rains are there? Rain is just very simple. See, there are 6 here. So 3 rain would be there. Let's count that. This is rain 1, this is rain 2, and this is rain 3. So rain are 3 by 9. So in this way, you would get for x1. Same way you would get it for x2 as well. Same way you would get it for x2 as well. That is humidity. X2 is temperature. So for temperature, you have again 3 things: hot, mild, and cold. Same way you would have for humidity, and same way you would have for wind. I have already calculated these things for you so that the session time we can save and we don't need to count again and again everything. First of all, before I move forward, is this formula crystal clear, everyone? And how to count, how to find the probability, is that perfectly clear? That is the complete formula that you have. Let me write all the values here so that we can solve any problem. We can solve any problem. So now I am writing that here I have all, which is the things which I have already calculated. You can check that afterwards. Outlook has 3 values. We have already calculated that now. Sunny, then we have overcast, then we have rain. Then in outlook there are 2 values, yes for yes and then for no. So for Sunny we have seen that 2 by 9 it was. For overcast we have seen it was 4 by 9, and you calculated for rain also 3 by 9. Same way for no also we would calculate. Remember what I have explained you. We would first calculate for yes, we would calculate for no, and if we have third class we would calculate for maybe also. So we have 2 classes, so we would calculate for 2 classes now. For no also I have already kept in calculated for you, that is 3 by 5, 0 here and 2 by 5. Once I would show you how I calculated for no also. See that. So outlook, we would now only focus on the no part because it's now time for a no. Same formula, just it would be probability of no given x1, x2, x3, x4. Same way we would calculate probability of x1 given no. When you know that it is a no, so you would remove all the yes. So let me remove all the yes from here. Then this is also a yes. And this is also a yes. Okay, so now we have how many no's? 1, 2, 3, 4, and 5 no's. So our denominator would be 5. Then we want to calculate, let's say for sunny in no. So there is 1 sunny, 2 sunny, 3 sunny. So there are 3 sunnies. Yes, that is 3 by 5. So same way, you can also see that my values, what I have said you 3 by 5 for sunny, it is exactly matching. Sunny 3 by 5 for no. Now this is one outlook value that you have calculated. Now you need to calculate in the same way for second, that is x2. Okay, that is temperature. So for temperature, what we have? In temperature, we have 3 things again: hot, mild, and cold. Again, we have yes and no's for both of them. For hot, it is 2 by 9. Then for mild, it is 4 by 9. Then it is 3 by 9 here. Same way, for no, it is 2 by 5, 2 by 5, and 1 by 5. Now, like you got for temperature outlook, you need to get it for humidity as well. Humidity, and in the same way, humidity have only 2 things now, high and normal. And again, you have 2 values here, yes and no. So you have here 3 by 9. Here you have 6 by 9. Here you have 4 by 5. And here you have 1 by 5. Then after humidity, you have the last thing, that is windy. In that also you have the same thing: strong, weak, yes and no. So it is 3 by 9 here, it is 6 by 9 here, it is 3 by 5 here, and 2 by 5 here. First of all, now the complete algorithm is solved. How simple it is to calculate the test value. Okay, we have done literally we have done the thing. Just the only thing is left is, that is this probability of y. This thing is left. How to calculate the probability of y? Very simple. What is the probability of y? Total samples divided by favorable samples. So what are our total samples? How many values are there total? Let's calculate that quickly. If we have a big data, how we can find probability? If you have big data, you have algorithms for that. Naive Bayes works like this, Deepak. So your sklearn would find the probabilities in the same way, no matter how big your data is. Okay, yes, great. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 examples. And how many yes are there? We have already know that there are 9 yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 by 14. So probability of y is 9 by 14. Now tell me one thing, guys. If you look at the formula, can you find something is common in this formula? This is for yes, this is for no. Can you tell me there is something common? Denominator is common. See that? Your denominator is common in both the scenarios. Just look at this denominator, probability of x1, x2, x3, x4, x1, x2, x3, x4. So just tell me one thing. If the denominator is same, so let's say I have a denominator 5, here also I have a denominator 5. So 7 here I have, and here I have 8. Yes, whenever you have a same denominator, you can ignore that while comparing. You can ignore that while comparing. And same thing we are going to do here while calculating. I made a formula more simple for you. Now, whenever you calculate Naive Bayes, you would ignore the denominator here. So your real formula, your actual formula is just the numerator. So just trust me, we already calculated this x1, x2, x3, x4 given n. We calculated the probability of y and n also. We now just need to put that into the formula and we are done with it. Let's see that. Let's complete it and then we would take all of your doubts.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So let's assume that we have 4 things. Now Akash, you got all the probabilities. Can you do a test example? Yes. So for my test, I have 1 sunny. Okay. Let's try to take one example from the given data set itself. Okay, so let's say I want to find this example. So let's put that into and let's see whether we are getting no or not here. So we have rain, okay, we have mild, we have high, and we have strong. Let's assume that, understand guys what I'm doing. I'm treating this D14 as my test example. Let's try to find the probability of these 4 values. Let's try to find the values for this 4 things. Okay, so this is our outlook. This is our temperature. This is our humidity, and this is our wind. Okay, let's take first we would create this as a second example for now. Let's take a simple example first. So outlook, I am taking something random, that is sunny. Then I am taking here temperature, that is cool. Humidity I am taking high, and wind I am taking here again strong. So now what I am going to do, I just need to put that into the values. That is probability of yes given sunny into probability of cool given yes into probability of high given yes and into probability of strong given yes. And what was there more on denominator? One more term was there. Can you tell me what was the next term? Into probability of y. And do we need denominator? No, we don't need denominator. So we would just put the values here. Okay, so probability of yes given sunny, we can take that from here. Yes given sunny is 2 by 9. So let's put here 2 by 9 into probability of cool given yes. So where is cool? Cool is here. Cold it is, not cool. 3 by 9. So let's put that 3 by 9 here into probability of high yes given high. Yes given high, that is 3 by 9 again, into probability of yes given strong, that is again 3 by 9. Okay, so all values are 3 by 9 itself. Okay, 3 by 9. And what is probability of yes? Probability of yes is 9 by 14. So we'll put that here. Anyone can calculate what's the value coming out? I would also calculate that on my calculator. Okay, so 9 divided by 14, 6 into 0.6, that is 1 divided by 1 by 89, that is 0.0053. You can write it in simple. So in this way, you just need to put the values that you have taken into table. The seat, getting that table is a 5 minutes job. Putting that values is again a 2 minutes, and then calculating it just on a calculator. Okay, now the same thing you are going to do with probabilities of no also. So probability of S, sir, एक भी 0 हुआ तो 0 हो जाएगा ये तो yes, एक भी 0 हुआ तो complete 0 हो जाएगा. That's perfectly correct. So, which means that what it means, I can't understand it. Let's say one probability is 0. For example, this is 0. Let's assume that this is 0. Now, what it means that this 0 means that there is not a single instance, that there is yes and there is high. Okay. So in your training data set, there is not a single instance. That's the reason the probability is 0 part. Now you have here sunny, overcast, and rain. So overcast is 0 here. What does this mean? Which means that there is not a single instance that there is an overcast and people are saying no. Always when there is an overcast, people are saying yes for it. Which means that yes, that is a very strong indicator of a person's decision. So you should not neglect it. That is a good point. Maybe you can collect more data. This data can be small for you. You need to collect more data in that case, but you will never neglect it. Okay, yes. So now same thing you would calculate for no also. Probability of cool given no, probability of high given no, into probability of S, that is strong given no, into probability of no. You would calculate in the same way. Okay, you can put the values from the thing. Okay, for you, I would just quickly put the values. Probabilities of S given no is 3 by 5. Okay, everyone pay attention. I'm just summarizing this. Probability of cool given no, what it is, cool given no, into high given no, that is 4 by 5. into probability of strong even no, that is 3 by 5 once again. And what is the probability of no? That is 5 by 14, because you have 9 examples here, so 5 examples would be here. So when you solve this, you would get a value as 0.206. No is greater, perfectly right. In the same way, you would calculate for maybe also. And which one is greater, you would select that. So here the clear-cut answer here is no. So you would select a no. Now, same way you would calculate for this also. You would get the probabilities in the same way, and you would find the biggest probability and you would take that. Now we would see one more example. Okay, now this would be a text-based example, and we are going to see the coding part of it as well. So this is a text-based example. If you have a text, how you can use it. This is also very interesting. Let me see. First, do we need to code this? Just give me a second. Okay, so we would take one data set and we would code this first. Okay, and then we would move to the next step. So let's create a thing in Naive Bayes. We would create one notebook. Let's try to code this first and see the code is very, very simple. Code is really very simple. How to code a Naive Bayes? So I'm going to first take a data set. So everyone pay attention. So we would take our same libraries, import numpy as np, import pandas as pd. Okay, we would also need two more libraries here, sklearn dataset. So from sklearn dot datasets import. Now we are going to take here breast cancer dataset. Now this is a healthcare related dataset. So you would also understand the healthcare domain in that. So this is a breast cancer dataset. So we would load these things now. sklearn.datasets. Yes. Now to load a dataset, we would use this load breast cancer thing. We would load that into our data equals to load breast cancer thing, and we would have the complete data inside this. So this data is like a dictionary. You have a data here, which are the numerical values. You can see that. Okay, you have the targets here, whether a person has a breast cancer or not. So 0 and 1 here. Okay, and the target names are malignant and benign. What does this mean? So this means that whether your cancer is a big or a small at the initial stage. So malignant and benign. These are the two things here. Then you have name of attributes also here. So basically, what is the texture? What is the radius of a cancer? So everything is mentioned here. Like this is the radius, this is the texture. There are many columns in this data set. So you can see that the number of attributes, there are 30 numeric attributes. And you need to predict a class whether you would have a breast cancer or not. So you have information like the radius, how big the cancer is, what is the texture, whether it is smooth, whether it is compact, what is the concativity. This all are the 30 features that you have in your dataset. Let me show you that first dataset. These are the column names. That is the radius, texture, parameter, area, concave point, symmetry, factorial dimension. These are all the healthcare domain terms. So you can simply do like this, data dot data. So you would get all the values here like the arrays. If you want to get the column names, you would just use this feature names here. So you can just do data dot feature names and you would get all the column names here, 30 column names. You can create basically a data frame here. It's very simple to create a data frame. That would make the things simple for you. pd.dataFrame, and inside that you would give a dictionary. So you can just simply name the columns like this. For example, the first one is your so for dataset you can just give the two things here, np.c underscore. So that is used to give an array of values. np.c is used to give the arrays of values. Now first let me write that and then I'm going to explain you how to code this. Sir, from long ago, I have a doubt why we are using the brackets at the end of the model. Like, Ragul, which model you are talking about? This one? Yes. So basically, this is not a model, Ragul. This is a function. So see, whenever you use from sklearn import this, so then this is it's like a class or it's like a function for you. So for every class or function, you give this or open brackets. Okay. So we are not importing all the data sets. We are just importing this a small function or a class. Now in np.c, you need to give the two things, that is data, like this is your complete data, and comma data.targets. Okay, so what we are giving here the complete data, and also with that we are giving the target, that is 0 and 1, whether it is a cancer or not. Then at the last you need to give the column names as well, so that you should have a column names properly. That is, what are the column names? It is a list of data dot feature names. And at the end, you would also have a target here. So plus you need to write the target. So these things you need. So last column would be your np.c. See, let me explain you this np.c in more better way. So basically this translate objects to concatenation along second axis, which means that, see what I have here, Deepak, I have two things here. I have data and the target. They are in two different things. I have data.data different, and data.targets, that is zeros and ones, they are different. So I want to concat that I need to merge that. So that's the reason I have used here np.c. So it is like a merge thing in NumPy. This is just used to create a data frame for all of you, that is df.head. The moment you see, you would understand that. See, this 17.99, this was the value, the first value that you see, 17.99. See. So this is e raised to power plus 1 0, that would become 17.99. Okay, e raised to power 1 means 10 raised to power 1. So this would be 17.99. So you can see that the first value is 17.99, and we have at the end here target also, that is zeros and ones. So to get that, we have combined that here, that is c underscore, and then we have the column names. So we created a data frame here. Now you can simply get your x and y's. So you know that we have already seen that in all the examples, df.ilog, and we would just give here 0 to -1. Okay, and then same way we would do it for y, df.ilog, all the values but not last column. Okay, so we would get here x and y's. The moment you got x and y, you would do the same thing, train and test split. See, it is exactly same what we have done up till now in every of the problem. So let's go to decision tree. We have already the code for it. So we would not write the code once again. We would take the train and test split from there. So the same code for sklearn, we have taken that for train and test split here. So we have done a simple train and test split. Same 80-20 train split. Now, after doing that, we would train a Naive Bayes model. See how simple it is to train a Naive Bayes model. Now see, there are three things in Naive Bayes model. There are three things in Naive Bayes model. The first one is a Gaussian Naive Bayes model. So from sklearn dot Naive Bayes, from sklearn dot Naive Bayes import Gaussian Naive Bayes. So this is one of the things, that is Gaussian Naive Bayes. So we are going to import this Gaussian Naive Bayes. Now again, Gaussian Naive Bayes is a class. So we would create an instance of it, that is a classifier equals to Gaussian Naive Bayes. And then we are going to do here classifier dot fit. And that's it. We just need to give here x train and your y train. It is as simple as that. Now see, just keep one thing in mind. Whenever you have all the numerical values, see my this breast cancer dataset all have the numerical values. So whenever you have a numerical value, you would use a Gaussian naive Bayes algorithm. The moment you can train that, so you got a naive Bayes trained here. Now you can just see the classifier score here using the same thing, that is the classifier dot score, and you can give your test data to it. So see how good you have performed here. So here it would be X test, comma, Y test. So you see that we got 97% accuracy here. Really very, very good accuracy. So whenever you have a numeric data, you would go with Gaussian naive Bayes. Now there are two more type of naive Bayes theorem. One is multinomial. So what I'm going to do is I'm going to explain you that as well. So in this I would write here multinomial naive Bayes. Then I'm going to in the same way create the same thing so that you can understand it much better. Multinomial Bayes, and you would train a classifier here. And at the end, we are going to check the score for it. Now see, the moment you train a multinomial naive Bayes, okay, same things we have done. We created a classifier. This is another variant of multinomial, but multinomial is not used when you have numerical data. For numerical data, you would always use this. Let me write that here. Numerical data. And I have a very good post. Let me explain you that when to use Gaussian naive Bayes. So this is a very good on Quora. I have read that, so that would help you a lot to summarize it. This is a very good post. A person has summarized that very betterly. You have one more algorithm here, that is Bernoulli. Okay, so instead of this, you have one more, that is Bernoulli. Now, when to use Bernoulli, that also I'm going to explain you. When to use multinomial, that I'm going to also explain you. See, the moment you use Bernoulli, your accuracy drop down to a lot. So, whenever you have a numerical data, you would go with Gaussian. So, one more time, starting from the steps. Okay. See what we have done. We have done here nothing. We just loaded. Now everyone pay attention from the beginning of before. Yes, I am going to explain you from starting, no problem, because I see only 2 years here. So we loaded a breast cancer dataset. Now the interesting thing is you don't need to download it. You can directly load it. We loaded that in data variable. What all things we have in data? We have the complete array of values. We have the target zeros and ones here. We have the description about the dataset. Then we have the column names here. What are the different column names in feature names? Then file name also we have, and the module name also we have. From that, we use the data and the feature names. So what we did, we use this np.c function to combine the data and the target. And we gave the column names to it, that is all the feature names. And the last column is the target column. We created our data frame. If someone do not wants to create that, that is also okay. Then we divided that into X and Y. The last column is your Y, exactly like we did in all the examples. We did a train and test split here. And then we trained a naive Bayes. How you train a naive Bayes? You just need to import a Gaussian naive Bayes, that is NB. Then you provide your X and Y labels to it. Sir, why? Sir, combine Y. So you are saying that why we combine this? Yes. So see, basically, we have here two things. Okay, Ekansh, we have two things. We have all the values. Let's say we have the first thing is sunny, then we have windy, then we have cool, and then we have mild. We have this 4 values. Another we have whether a person would play tennis, yes or no. So what I said that combine these two in one data frame. That is why we combine these two things, that is the data and the target. And we gave the column names to it, that this is the column name for outlook, this is the column name for temperature, and the last column name is target. So that is how we just created a data frame here. Because up till now, it was just a simple arrays. You can see that it was just simple arrays. How you are going to classify this into yes and no's? How you are going to do that? So let's see that. Really very, very interesting. And something fun. But again, the complexity level is exactly the same that you have already seen. So let's jump directly now to how we are going to solve this. Okay, so naive Bayes, this is for text classification problem. One thing I have very interesting for all of you. Okay, so all of you remember that we have worked on Titanic dataset. So the same thing, I got one GitHub profile here. You can try this. Naive Bayes, not this one. Same thing, Naive Bayes predicting survival rate for Titanic crash. The same dataset they have, and they have used the same things here. Okay, they have reduced some columns here. You can keep in the same way all number of columns, and the complete part they have done the get dummies, exactly what I have explained you. Then creating, filling the missing values, then train and test split, then applying the Gauss naive Bayes here because this is a numerical data again. But you can apply here different algorithms also, and then they got the results. So you can try this later on. This is just for your reference, just for your sake of understanding that the things remains the same. The practical things remain the same. So let's see now, what if we use dropping columns if there is no null values? What is the use of dropping columns if there is no null values? Okay, so you are saying that, Ekans, let me understand your question. Why did we drop this name column? So now see, just try to understand, Ekans, is name help you to predict whether a person would survive or not? Let's say the person name here is Owen Harris, but when he's dying, he changed his name to, let's say, Miss Liana. Will that help him to survive? No. So basically, yes, it does not depend on that. That's perfectly right. The columns that does not depend on your survival, like the ticket number would not depend. It would not depend your name, not depend your ID, so that we won't delete. But even if we consider them, will that change something? So see, understand what is the problem. Let's assume that you are not deleting it. Then you would have an extra column. Is that correct? This is called as dimension problem in machine learning. Remember that as much you can reduce the column, you should try to reduce it. Yes. So every time try to remove the columns. That would help you to get a best fit model and not an overfit model. Okay, great. Let's come back to our example now. We have this text data set with us and we want to predict whether it belongs to class yes or class no. But sir, here he dropped embark to. Yes, correct. Embark, so just for the demo purpose he has shown, but you can keep the same way embark column also. You can keep the parch column also. You can keep the sib-sp column also. You can keep everything. Just for demonstration purpose, he dropped it. So now this is a text problem. Again, the classification is exactly the same, that you need to predict yes or no class here, nothing else than that. And how to do that, let's see it. First of all, it is exactly the same which I have explained you. Pay attention, I'm going to explain you once again now. What is the meaning of naive here? When I was considering C, this was my formula, probability of x1 given x2, x3, x4 like this. This was my overall formula. This was my overall formula. But when I break down, pay attention. When I break down, I use x1 single-handed. I use x2 single-handed, which means independently I used. Which means that when I was calculating outlook, remember that when I was calculating outlook, I removed all the other columns. Everyone agree that I removed all the other columns, I removed the no part? Yes. So this means that my x1 is independent of x2. x2 is independent of x3. Basically, x1 is independent of x1, x2, x3, x4. Which means that no matter whether it is hot, cold, mild, high, normal, weak, strong, it doesn't matter for me. This is called as my features are totally independent from each other. My features are totally independent from each other. This is called as naive assumption. Naive, naive assumption. That is why it is called as naive Bayes algorithm. Remember that this is a favorite interview question. What is the assumption in naive Bayes? The assumption is every feature that is written in your PPT as well, you can go through it. The first line that you would see. Naive Bayes assumes that, see, assumption, that presence of a particular feature in a class is unrelated to the presence of any other feature. Which means if there is an outlook is totally independent from humidity, from temperature, it is completely independent. That is called as Nave's assumption. Given I have these words like love, happy, joy, joy, happy. So given some words x1, x2 like this, I want to predict whether it is a yes or a no. So same formula, it would be probability of x1, x2 given y into probability of y and divided by probability of x1 and x2. Again, denominator would be same, so I'm going to remove this and you just need to calculate these two probabilities. See how to calculate that. Now, probability of y here. What is probability of y? How many y's are there? 4y and 2 no. Can you tell me quickly the probability of y? Probability of no, it is 2 by 6. Simple as that. Once you got the probability of yes and no's, you just need to calculate the rest of the probability. That is, let's take a testing example. You don't need to, you don't need to calculate the probability of every word. I want to check this word. Let's say my test sentences, love, pain, joy, love, kick. I want to find the probability of this, whether it belongs to yes class or no class. See how simple it would be. So you would calculate, so what would be the thing? You would first calculate the probability of this. Probability of yes given love. What it would be? How many yes are there? See how simple it is if you understand the formula. How many yes are there? But now pay attention here. You would not check the yes here. You would check how many words are there in yes. So let's count the word. So here it is word 1, word 2, word 3, word 4, word 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. No matter if the words are repeating, duplicate, no matter. There are total, in yes, there are 19 words. And in no, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 words are there in no. So your denominator here is 19 for yes. And how many love words are there? Let's calculate the love words. This is 1. This is 2. This is 3. This is 4. In yes only. See, I'm not calculating this love because this is in no. I just need to calculate in yes. So there are 4 words. As simple as that. Sorry, 4 or I missed. Yeah, I think I missed one more. That is 5. 1, 2, 3, 4, and 5. Yeah, sorry. So it is 5 by 90. Same way you would calculate for pain. Probability of pain given yes. I would just show you for pain also. What is the pain thing? In pain also the thing would remain the same. How many pain are there? There is only one pain, only one. Yes, here it is. So it would be just 1 by 90. Same way you would calculate the probability for love, and that is no. Okay, you would count that in no's now. How many love is there in the no? 1 and 2. So 2 by 9 no's are there. So 2 by 9. So in this way, you would calculate for every word love, pain, joy, love, kick. I have already calculated that. So I'm going to show you that like completely. So this is my, let me take this text sentence now. Sir, how yes is 19? So Shubham, there are 19 words in yes. So once again, I would show you that, no problem. So see, in yes, this is yes, 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 yes. So in this yes, how many words are there? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So in this way, you got 19 words here. Clear, Shubham? Same way for no also, you would have 9 words. Now I have calculated all the probabilities for yes. The probabilities of love is 5 by 19. For pain, it is 1 by 19. For joy, it is 5 by 19. And again, love would be the same 5 by 19. And for kick, it is 1 by 19. Same way, the no probabilities. What is the no probability? It is 2 by 19. You can check it later on. 4 by 19, 1 by 9. Sorry. It would not be 19. It is 9. So 2 by 9, 4 by 9, 1 by 9. Then this love would again 2 by 9. And then it is here. The kick is also 2 by 9. So you got all the values. Now it's matter of just putting that into the formula. So you need to calculate for this. Now you would just put that into the formula for yes. You would just multiply here 5 by 19 into 1 by 19 into 5 by 19 into 1 by 19, then 5 by 19, and then after that, yes, that is 1 by 19. 5 by 19 is 2 times. So 5 by 19 2 times and 1 by 19. Okay, and into, see, one more thing. Yeah, so we have taken 3 times, 1 time, 2 times, 3 times. Okay, and then we would also multiply the probability of yes. Remember that probability of yes. What is that? Probability of yes is 4 by, what was probability of yes? It is 4 by 6. Correct. That is 4 by 6. So you would put that here 4 by 6 in the same way. And this answer you would get it as 0.00000067. Same way you would do it for no. You would put all the no's probability here. And the no answer that you would get is 0.0018. 1, 2, 3 I have already calculated. There are 5 zeros up. Yes, and the 3 zeros down. So here one more 0 it would be. And 0.18. Again, the no probability is higher here. So our example belongs to no. So love, pain, joy, love, kick would belongs to no. So we are going to take one of the example in the same way, that is spam versus ham detection. Okay, spam mail versus non-spam mail detection. So we would take a data set from the internet for that quickly. Spam.csv, we would search it and we would get that anywhere, from anywhere we can take that CSV file. So yes, we can take this, and I would take here the raw file so that we don't need to download this. Okay, now see how interesting it is. Okay, now I would take one data set once again clear. Let's take this, import pandas as PD. Or let's do one thing. Let's make another file here so that it is not text classification. I would add here. So some techniques we are going to learn here. Text classification NB I will write here. Okay, so import pandas as PD. You would create a data frame, that is df equals to pd.read_csv. And the interesting part is we can give this complete link here and we don't need to download that. So it would read directly from this HTTPS, and it's not reading, it's giving some error. It should not give the problem. Let me see that if we can quickly solve it, else we would download and work on it. But it is not simple. This used to work perfectly fine before. Let me see that. There is some other way. Where it needs authentication, we have to download it. No, I can't. Like, this is a public thing, so it doesn't take that. But yes, just let me check that quickly. Yeah, see that we can directly read it. Okay, so we got the data set downloaded. I would store that data set. spam.csv. Let's copy this file and I will put that into our folder. That is machine learning NB, and server by default read.csv is comma as a file may contains more than expected, and yes, that can be the case. But we would delete this spam and we would keep this spam here. Okay, let's try this now. I think this will work. Is the encode error again, no problem. We need to change the encoding. Let's change the encoding part. Yeah, I think this would solve the problem. Okay, it is done. Yes, format is CSV, that's correct. So we got the data set here. Now, we got some rubbish column as well. Let's delete that rubbish column from here. That is df, we would just keep here column V1 and column V2. Only these two columns are important for us. Rest all the columns we have removed it. And let's see, df.tail is also correct. Okay, yes, we got a good data set now. It is completely very clear. Now we would see how many spam and ham mails we have. So df.value underscore counts, we can check that. Simple. And you would df.v1 we need to check here. So you can see that their ham mails means that it is not a spam, and spam mails means that that is a spam. So 747 spam mails are there and 425 are non-spam mails. So this is how your data set looks like. And basically you can see some examples of it. You can use df.sample and you can say 50. So you would get some random samples here. See, this is a spam. It can clearly see that something rubbish is written here, make new friends or fall in love, something like that. See, hit a premium pink, something like that, hit a link. This is a spam mail. Then someone you know is trying to contact you. This is again a spam mail. Important information, orange user XXX, again a spam mail. Award, winning numbers, spam mails. In this way, you can check your small data set. It's a real world data set. Ekansh. Now, what you are going to do, the first thing, first of all, your data, your model does not understand this spam and ham. So you need to convert that into ones and zeros. So I'm going to use here df of v1 and I'm going to change that to ones and zeros. So df of v1, df of v1. What I'm going to do, I'm applying a function here. That is a yes, label encodings. That's correct. You can use your label encodings or simply, okay, let's use here quickly label encodings also, so that yes, you can use map also simple. See, we can use here map, so we would not go to much like complex thing. You can apply a simple lambda here when you have only one or two categories, lambda x. And I just need to check a simple x condition. If x equals to spam, in that case, what I want 1 in that case. So I would write here 1, else 0. Simple as that. So if it is a spam mail, I would get 1. If it is a ham mail, I would get 0. So you can print that and you got df1 ready. You can see that now wherever there is a spam mail, see free entry, that is 1. This is second time we have tried to contract you, that is 1, and non-spam mail is 0. Now what you need to do in the same way, we are going to do a train and test split. Again, we are going to take it from our old thing, the train and test split. We would divide our data set into train and test split. So in train and test split, you would write here the df.v2. So v2 is this one. So I'm writing here my x is v2 and my y is df.v1. Simple as that. So instead of separating x and y again and again, I have just written here directly. So you would get train and test split in the same way. Unsupervised learning. So before going to unsupervised learning, Can you tell me what's the difference in supervised learning and unsupervised learning? Supervised has labels and unsupervised is without labels. A very, very, very big difference. Now we would understand where it is used in industry, how it is used in industry, and what are the relevance behind it. So let me take one image so that I can explain you this part in more detail, supervised versus unsupervised. We have already seen this, I'm just recapping you so that it's there 100% on your mind, what is supervised and what is unsupervised. So in supervised learning, you clear-cut know that this is your input data. This is your input data. And with input data, you also know the outputs. You have, remember the first day which I have explained you, supervision. Everyone remembers the example which I have given? Bicycle example. Where your father was teaching you how to ride a cycle. Now your father is your supervision. If you make any mistakes, for example, this model says this input data as banana, okay? Your model, your father would correct you. If you make a mistake in riding a cycle, your father would correct you. Your labels would correct you that banana and apples are not matching, which means that, bro, you need to change this label. Remember the RSS? We used to do that. The actual value is 10 crores. Your model is predicting 8 crores. So the error here is 2. We try to reduce RSS. Basically, this 10, the actual value that you have, this is labels. Labels helps the model to get trained, to get a very good model.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now in unsupervised learning, you don't have any labels. See that I have just the input data. Imagine that there is a small newborn baby. Okay, this newborn baby, there is no one who is around this baby. No one around this baby. There is no supervision. Keep that in mind. No supervision. In this case, what a baby can do, baby does not know what is apple, banana, orange, anything. But by looking at the shape, the figure, the size, the color, it can create the groups. It can create the groups. Everyone agree that a small child can do that? Based on the similarity, it can create the groups? Yes. Creating these groups are basically nothing, but they are called as clusters. These groups are nothing, but they are called as clusters. So that's the reason unsupervised learning is nothing, just it is also called as clustering. One part in unsupervised learning is clustering. Now a big pointer comes in your mind, Akash. When there is no supervision, when we don't know the actual answer, how model is going to learn? How model is going to learn? So for that, we have a very different rubrics that is completely different from supervised learning. But trust me, in the same energy level and the same interesting it would be to understand how without labels also a model can learn. It would be very interesting. Really, it would be very interesting. I would give you some interesting name here. The first name is Silhouette Score. 100% by the name, it doesn't make sense. What is Silhouette Score? Second one is Elbow Method. Again, with the name, it doesn't seem very interesting. But the moment you see the real maths behind it, you would really enjoy that, yes, this is how unsupervised can be solved also. Without knowing the real labels also, we can get a good things. So with this part, we are going to see in the session. Now, let's get started with the first part for today. What is clustering? What are the types of clustering? Let's understand that one by one. Clustering is a process of dividing the dataset into groups consisting of similar data points. Points in the same groups are similar as possible. Points in different groups are dissimilar as possible. Let's try to understand this with a very interesting Amazon example. Now, Akash, one doubt. Anyone has this doubt in your mind? So see, you need to ask me this type of questions. Akash, when we can already solve every example with supervised learning, why do we need unsupervised learning? When you don't have labels, then what you are going to do, bro? Imagine that Amazon have around 100 million of customers in all total. This 100 million customers have some data set. The data set is like this, where you have, like, let's say where there is one customer, he has spent how much on, for example, he has spent 10,000 rupees and he has bought a t-shirt, okay, of let's say a company called as some branded company. I would write here branded company. Okay. Same way, there is another person who has bought a t-shirt of 299. Same way t-shirt, again branded, and we have multiple columns that have the information. Now we have 10 million, like 1, 2, like this, we have 100 million customers. Now, imagine that we don't have any labels for this. There is no labels. We don't know that whether this customer is a high spending customer, low spending customer, or whatever it is. We don't have labels here. Now, so this is a non-branded. Okay, I would write here non-branded. So in this way, we had just the data. One way is what we can do is we can make a team. So how the things work in industry, pay attention. We can make a team here. That is a data labeling team. What this team would do, this team would basically sit and label this data set. Whatever labels we want, let's say we want a label, for example, customer who are a very high spending customer, low spending customer, medium spending customers. Like this, we want to label them, or we want to label that some other labels we want to give to the data, any labels, let's say. So this team needs to go through every record, 100 million records, and write in front of them that, okay, this person is high spending, low spending, medium spending. So this would require a lot of time. It would require a lot of time. It would require a lot of money as well, because let's say this data labeling team consists of 20 people. So this 20 people needs to be paid. So money would be required. And most importantly, tell me one thing. If this 20 people take 1 month of data, 1 month to label this 100 million records, 1 month to label this 100 million records, can you generate, or can you apply supervised learning data? Can you apply supervised learning before this 1 month? Perfectly no. That's very correct. Without you get the labels, you cannot apply supervised learning. So your model would be delayed in that case. After 1 month, you can start working on the model. So here comes wearing a Superman cape. Here comes unsupervised learning. So unsupervised learning says that, brother, I do not need any type of labels. That's the power for me. I am trained without labels. So what this unsupervised learning would do? Unsupervised learning would give you the clusters. That this is, let's say these people are very high spending customer, around 10,000 rupees, okay, or 20,000 rupees, 15,000 rupees, like this. Then they are medium spending customer, let's say 2,000, 5,000, something like that. And then there are very low spending customers, let's say 200 to 500, something like that. Now, in this way, you got the different clusters here. And this is not only in terms of numbers, in terms of, let's say, money. It can be based on brand. This person are only buying the branded products. This person are only buying the non-branded products, or let's say, yes, non-branded products. And these people are only buying the first copy product, let's say. So you can clearly create the clusters here. Can anyone tell me why these clusters are useful? Okay, Akash, we got 100 million data set. We understood that unsupervised can save our time, money, and model can be prepared within a day. But what is the use of this clusters? Target advertisement. This is the biggest industry right now. Every other industry works on this advertisement industry. Yes, target audience for marketing and suggestion. See, everything, even the world's biggest company, Google, what is the revenue model for it? It is the advertisement model. It works on advertisement. YouTube work on advertisement. Your TV channels, your biggest sports league, IPL, work on the revenue model for that is advertisement. Jo dikhega wo bikega, correct? So exactly like that. Now imagine that I'm going to give you one more case study, Samsung. Now imagine that you are a very big data scientist in Samsung. Let's imagine that Krishna is a good data scientist at Amazon. He created some clusters here. Okay, and now these clusters are not only based on money, they are based on age also, let's say. So this is actually the Samsung thing. If you see, Samsung create the clusters for people who can buy in the range of 2,000 rupees to 12,000 rupees. You would get a phone of Samsung. Samsung also create a people who can buy in the mid-range around 25,000 to 40,000. And then high spending customer who can even buy 1 lakh to 1.5 lakhs of phone. So basically Samsung caters the complete market, the low spending customers, the medium spending customer, and the high spending customer. Can you tell me in Apple how many clusters are there? Just 2 clusters. That is the medium spending customer. You cannot buy an Apple iPhone in 2,000 rupees. You need to pay something around from 40,000 till it caters the high range, that is from 1 lakh. For Apple, there is no garib. For Apple, the garibi starts at 40,000 rupees. So this is how company create the clusters, so that, okay, for this cluster, now there can be one more cluster. See, just pay attention. Now a new cluster has been created here, that is for, so this is now another cluster. If you have seen that this industry is booming a lot, gaming industry. Now Samsung is creating a specialized phone for gaming. There are another companies who are creating one more cluster here for gaming cluster. So this is exactly where clustering is used. This is a real case study of where you can use your unsupervised learning. So all are the examples of clustering. You can see that this fruit lollipops, how they are clustered into different groups based on the color. Okay, then paper, metal, plastic, again they are clusters. E-waste, glass, organic, they are clusters. Everywhere you can see the clusters. Clusters of different fruits here. It is used in everything like Amazon recommendation system. Okay, this collaborative filtering, content filtering, recommend products based on the clustering. Okay, what does this mean? So for example, the 2 persons are very similar. For example, let's say Ayush and Nikhil are 2 very similar. So Ayush has bought some products like this. So now the recommendation system would also recommend Nikhil the same products. The perfect example for this, you can open up any website and you would see that. So everywhere you can see that. Now there are different types of clustering. Exclusive clustering, that is what we are going to see. Hierarchical clustering, that is what we are going to see. Overlapping clustering is not that much relevant in industry, and we are not focusing much on that. I'm just going to explain you the topic. So, what do you mean by exclusive clustering? Exclusive clustering means that that data point can be only present in one cluster. So if I create a cluster of male and female, okay, so a person can only be there in male or only be there in female. You cannot mix that between. Maybe I would give some more other example here. Okay, if a item is, let's say I have created a cluster here for electronics, and I have created a clusters for gaming, not gaming, let's say plastic, maybe something. So now a thing that is not this, let's say books, or let me think for a quick example here, where the two things would be totally different. Electronics, and let's say now electronics is present in everything. Let's take something else. Let's take here shoes, okay, and let's take here makeup. Okay, now see, a thing that is there in shoes cannot be there in makeup, and the things that is there in makeup cannot be there in shoes. So this is exclusive clustering. Exclusive, understand the meaning of it. Do you understand when Flipkart says exclusive deal, exclusive membership, exclusive, this rights are only on Flipkart? So for example, only MI phones were first available only on Flipkart. What do you mean by exclusive? Only Flipkart has the right to claim the MI phones. Same way, if a product is exclusive in that, which means that no other can touch that product. Now, exactly opposite, we are going to see K-means clustering right after this. Overlapping clustering is like allows the data to be grouped in two or more clusters. There can be overlapping. So for example, if there is a electronics, there is a book. So there can be an electronic book here somewhere. Let's say Kindle. It is electronics as well. It is book also. Okay, maybe some book that has alarm, let's say, or book reads on their own, something like that. So that is overlapping clustering. So C means clustering, but we are not going to focus on that. Then the last and the most important again is this hierarchical clustering, that also we are going to see today. Hierarchical clustering. Okay, can anyone tell me what is hierarchy? What comes in your mind when you understand the word hierarchy? So like a hierarchy in your office, you have your manager. Okay, that manager has coordinates between them. Then that coordinates had again small coordinates. That manager has one more manager, that is called as hierarchy. And you would see the same hierarchy goes here. Yes, ranking system, organized system, one after the other, parent system, parent-son hierarchy like this. Now it's time to get much deep into this K-mean clustering, a really beautiful algorithm, and the algorithm that we are going to enjoy a lot. Now let's start the K-means algorithm and let's see how it works. Very interesting and really super simple algorithm again. So here are the biology marks, okay, and here are, let's say, maths marks. So here are the marking system I have simple. This is the biology mark. This is the maths mark. So I would write here maths here simple and biology simple here so that you can understand. It's just normal like you have seen in your school days. Now I'm drawing some points here. So let's say some points are here. I will make this bigger. Just a second. Okay. So can you tell me what things you can see here? So now this is like a general data. Let me explain you what I exactly mean here. Two clusters, some in good, some in maths, bio. Yes. Forget about clusters right now and only focus on a business case study here. So it is a very normal practice that this person is very good in bio. See that this is the 0 marks in bio. This is the 100 marks in bio. This is the 100 marks in maths here. So this person got a very good, like let's 100 mark in bio, but his score in maths is very low. Like he was not able to pass in maths. So there can be students at this place also. We are not focused on them right now. We are only focused on the colors that I am needing blue that you can see. They are special type of students who are performing very good in bio but very low in maths. Same way, this person has performed very excellent in maths, like out of 100 he got 99, but in bio again this person failed. Very low marks in bio, not even 35 marks. So here is your sum, students. Now let's see how this k-means algorithm would create the clusters for both of them. Let's see how k-means would create clusters for both of them. And trust me, this algorithm is just two-step algorithm. Let's start with the first step. And imagine the first step is the easiest step. That is, you can randomly choose 2 points anywhere on this complete chart. So one point I'm selecting here, let's say, and another point I'm selecting, let's say, let's say another point I'm selecting here. Okay, 2 points I've selected. Right now, you can select any points. Basically, you need to decide. The first step is to randomly assign. I'm writing that randomly assign clusters centroid. Randomly assign clusters centroid. So I'm assuming that I have 2 clusters. Now you can take any number of clusters. Deepak can take 20 clusters also here. Shatrugana can take 1 cluster also here. No problem. You can take any number of clusters. Right now, I'm starting with 2 clusters. How to select a good number of clusters, that also I'm going to explain. Now I have these 2 clusters. What I do as a first step is very simple. Everyone agree? Understood the first step? Now, see the second step. Second step is also very simple. That is assignment step. Assignment step. What do you mean by Akash assignment step? Assignment steps means that you need to calculate the distance. Pay attention. You need to calculate the distance of every point with the cluster. So this is my cluster 1, this is my cluster 2. So see that how I am doing it. Pay attention. This point, I am finding the distance of this point with this point, and distance of this point with this point. Tell me which distance is smaller here. Simple, Akash, very simple. It is C1. Now see, this is the only logic. You need to imagine that these are the 2 candidates. Let's say one is Mamta, one is Modi. One is Modi, one is Mamta. Like that, you can imagine it. The person who is standing closer to Modi would vote for Modi. So like this one was standing close to C1, so this would be colored in orange. Again, this one is close to C1. Again, you would calculate the same way the distance, this distance and this distance. So again, this point would be colored orange. Same way this distance, same way this, same way this, same way this, same way this, same way this. Same way, now see, here comes the interesting part. Akash, what if the distance, both of them is same? For example, this and this. If the distance is exactly the same, that is a very rare scenario because we calculate here the Euclidean distance. But if that happens, if the distance is is exactly same, that is a rare situation, but it is there, then you can assign to any of them. So for example, I am assigning this point. Let's for making it tough, I would assign it to, let's say, Mamta. So I have made this violet. Same with this point, now it is colored to violet. Now, rest of the point, as they are close to orange, so I would color them as orange. So this is orange, this is orange, this is orange, this is orange, this is orange. Let's say that. Now see the interesting part. Same way you would calculate the distance of this point also with this and with this. Now C2, because it is a little bit downer, so every point would have C2. So let me color them. So this would belong to the second cluster. Akash, but you said it is only a two-step algorithm. So does it mean that the clustering is done? What, Akash, this 3 points, do you say that these 3 points belong to good marks in biology? No, they should be belonging to some other cluster. Yes, the clustering, the process is not completed yet. And I have not said the lies also here. It is only two-step process. Let me explain you how it is a two-step process now. So now, see, both the steps I have explained you. Let's see what's the next step. So I would not going to erase this so that you can keep it in your mind for the next step. Now what you do, you run this algorithm in a loop. Only 2 steps. Now you would again go back to the first step. What does this mean? This means that you are going to take a centroid here. Let me explain you what do you mean by centroid here. So now you got one cluster. The orange ones are one cluster and this violet one are one cluster. Now the next step, instead of randomly assigning the centroid to the cluster, what you do is you take now the centroids for the cluster. Centroid for cluster. What is centroid for cluster? That also I'm going to explain you. Don't worry about it. So now how to calculate the centroid? Akash, you said centroid, but we don't understand what is the centroid. Centroid means the center of this cluster. See, this was our cluster 1, this was our cluster 2. Now you take the center of all these points. What is the center of this point? Somewhere here it would be the center. Somewhere here, let me color it with some other color. So this would be somewhere the center. So your centroid, which was here right now, that would jump into this middle place. And for this data points like this, the centroid would be somewhere here. Center means the center of the cluster. Imagine that Modi was standing here and Mamta was standing here. Now Mamta found out that her supportive members are at this place. So Mamta would come from here and she would stand here. And Mamta and Modi would go at this point. So this is called as centroid. Now your C1 and C2 would switch. How to make that switch? Pay attention. Now see how the switch would be made. So like I have made the arrows here. Now I would remove this part. Okay, that is this cluster is removed and this cluster is removed. And this both the clusters are now going to be jumping on this middle area here and here. This is your now new C1 and this is your new C2. That's it. See, interestingly, now you would again calculate the distance of this. Now see that this point you would calculate the distance. This point you would calculate the distance with this your new centroid and this new centroid. Can you see that this distance has increased a lot? Now can you imagine what would happen with this point? Very simple. This all would force him to now convert into this. See that? What does that mean? This means that when you calculate now the distance of this point with this cluster and this cluster, which one is smaller? Yes. Now you again do the assignment step. So this point would be now again colored as orange. And this is the final step where you got this as one cluster and this as one cluster. Now what you can do? You can assign a new teacher for them, a new maths teacher for them. They would explain everything from basics to this biology students, the maths part. And for this math students, you can apply a new biology teacher who can teach them from complete scratch from the day 1. This is how clustering helps you to create the clusters without the help of labels. Okay. So now let's see the demo of it. The demo is really very interesting. This is a website called as Naftali's Hellies. That is K means visualization. If you type, you would get the first website, that is Naftali Harris. And see that whatever I have explained you, I'm going to show you the demo. The most interesting demo of our complete machine learning. See that. Now this website, in this, you need, see the first thing what you can see here, how to pick the initial centroids. How to pick the initial centroids. Now I would say that I would choose. I want to choose this randomly, so I would click on I would choose. Then you can take any data set. There is a fix. There are very interesting data sets here, like a DB scan ring data set, this type of data set. Then you have another data sets also. That is this data set we are going to work on, Gaussian mixture data set. Now, the thing is, you can put this cluster anywhere. Tell me where I should put this cluster. Your choice. Cluster centroids, the first step. See, we are doing the first thing here. That is, we are randomly assigning the cluster centroids. So let's try to do that. I would put one here. Okay. Randomly anywhere. I would put second one, let's say here, and third one, let's say here. So randomly 3 ways at 3 point, I have put here 3 clusters. Now see the magic. When you click on go, pay minute attention. This is the real demo of everything. First step is clear, everyone, that we have randomly assigned the clusters. You can take 3, 300, 400, 4,000, 5,000, any clusters. Every point is a white point right now, which means that they do not belong to any cluster right now. Now what I'm going to do, the second step is assignment step, where you calculate the distance of every point with the centroids 1, 2, and 3. So they would be colored now. Pay attention. So when I click on go, see, they have been colored with green, blue, and red. Now pay attention. This is one cluster. What was the next step? Now see the next part. The next part was you would move this Mamta, Modi, and let's say Rahul to move to their centroids. Okay, you can consider anyone, whatever you want to consider. Gajudhar, let's say Amitabh, and some other also. Now this person would go into the center. Center would be somewhere here. Let me color that. So center would be somewhere here. For this, the center would be somewhere here. And for this, the center would be somewhere here. Now you need to click on this update centroids. See that? The moment I click on update centroids, exactly the position that I said, they jumped on that. Pay attention. See that? Your second step is also done. Now you keep doing this reassignment, update, reassign, update, reassign, update, reassign, update, reassign, update, reassign, update, till your centroids stop moving. This is your complete K-means algorithm. Once again, I would show you the demo. This time we would keep the point somewhere differently. Or let's say 1 point here, 1 point here, and let's say second point here. Okay, that also we are going to try, just one thing. So when I click on go now see, this is very interesting now. Now at this point, the clusters that are formed are wrong. It is saying that this is a red cluster and this complete is a green cluster. And it is saying that this is a blue cluster. So now you got a very wrong clusters here. But see how eventually they would make a perfect cluster. When you click on update centroids, they would jump to the centers. It would jump here somewhere. It would be jumping here somewhere. This point would be jumping somewhere here. And this point would be jumping somewhere here down. Because the center of this is here, somewhere here. or maybe little bit more here, something like that. So when I click on update centroid, see exactly at the positions, little bit up and down. Now see the points which are wrongly colored. This was a green, this was a blue. They would also be a correct point when you reassign it. See, and when you click on update centroid, your centroid will again move now. See, the moment your centroid stop moving, that is your final thing. Yes, when you visualize the things, it becomes very, very interesting, Deepak. Okay, now if you put everything at same place, okay, then nothing would happen. Okay, then nothing would happen. If you keep on everything at same place, nothing would happen. So I've kept a lot of points there. So it is not allowing me to reassign the points. You need to give some other points. Then only it would allow you to do that. Okay, so let's continue now. After that, we have understood the k-means in detail. Now the next part is to understand what are the drawbacks, how to find the best clusters, and the coding for it. Okay, so let me just copy this steps so that it's there for you. Now see, all of you understood that the problem is not the k-means algorithm, but the assignment step, right? Everyone agrees the assignment step is the problem? Yes. To solve the assignment step, you have an algorithm that is k-means plus plus. Now, this is not a new algorithm. It is just a smart, what it is? It is a smart initialization or smart clusters centroid, smart cluster centroid, which means that instead of giving a random clusters, we would use a smart technique for that. How to use a smart technique? Let's see this. Very interesting and very simple. See, now first of all, I would assume that all the points are again our normal white point, blue points, and not the colored ones. So let's take them back into the picture where we have all the blue points and blue points and blue points. Okay, now what you do in the first step is you randomly select one point among the data points. You randomly select one point from the given point. I was trying to see if I can get this return so that I don't need to write that again and again. See, pick the first centroid randomly, which means that you need to select the first point, but it should be amongst the point. You cannot select here random anywhere. It should be any point in between them. For example, this point I have selected. You need to select a point, not anywhere in the thing. That is the first difference. In k-means, you can select it anywhere, but in k-means plus plus, it should be a point. Second step, you need to calculate the distance of this point. Okay, you need to calculate the distance of this point with the rest of all the points. So this point, so you calculate the distance of this point with this, with this, with this, with this, with this, with this. Every distance you would calculate. Okay, and as the distance is smaller, the probabilities to select that as a next cluster is also smaller. So in short, I would just summarize it. If distance is higher, in short, highest distance would be your next centroid. So which is the highest distance here? The highest distance is, let's say, this one. Okay, so now this becomes Now this becomes your centroid 2. This is centroid 2, this is centroid 1. Now let's assume that you have some more data points. For example, some data points here, some 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 here, like this. You have more data points. Now what you are going to do, pay attention. This is a very important point. You would calculate the distance of every point. See, for third cluster, what you do, calculate the distance to its nearest centroid. What does this mean? This means that you would calculate the distance of this point with this cluster centroid and not this one, because this distance is smaller. That's what I said, to its nearest centroid. So pay attention. So you would calculate the distance of all the points to its nearest centroid. So this distance with this, this 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 with this, like that. Again, now this is close to this centroid, so you calculate this distance, this distance, this distance. Then again, in the same way, you would calculate all the other distance also with the centroid. This distance is closer to C1, so you would calculate this distance, this distance, this distance, and this distance. Now, among this, whichever is the maximum distance, for example, this one is the maximum, or this one is the maximum, whichever is the maximum, you would select that as your next centroid. So you would get now, let's say this cluster, this point as your next centroid. So instead of randomly assigning it, you would do a smart technique for it. So exactly that is written here. Compute all the distance in the data set from the selected centroid. The distance from the farthest centroid would be computed by the distance formula they might have written there. Okay. It would be the same Euclidean distance. I'm going to explain you that. And then, okay, let me see that if they have shown that somewhere. Okay, I can show you the demo right now for it. Let's forget about this block. Let's see the demo right now. So if you see in restart, you have two options. Either computer selected randomly or you selected randomly. This both of them are exactly same, no problem. You can try that afterwards. But do you see a very interesting thing here? Yes, everyone can see this. This is really your k-means plus plus. Now see the magic. I would click on this same data set and it would tell me to add a centroid. Now I don't have an option to add a centroid. Okay, I don't have a thing to add a centroid. I would click on add centroid. See the magic. Randomly it has selected one point. Now what I told you, pay attention. I told you that it would calculate the distance of this point with rest all the points. Like it would calculate with this, with this, with this, with this, with this, and all the data points it would calculate. Which one is maximum? It would take that. Any guesses? Which one would be the maximum? Any guess? Any guess? Yes, very. I also think that it's just a guess. I think this one is the farthest. Let's see that. I would click on now add centroid. See, pay attention. Yes, exactly that is the point. Now, what would happen? It would again calculate the distance to its nearest centroid. This one with this, with this, with this, with this, this point with this with this, with this, with this, like this, it would calculate. And again, this centroid distance with all these points. Now, can you tell me any guesses which one would be the maximum here? I think this one can be maximum or this one can be maximum. This both can be maximum. My probability is more on, so tell me, this is first, this is second. What do you think according to you, which one is the maximum? Okay, Shatrughna says 2. I think first one, let's see. 2, 1, 2. Quick, everyone, try to make a guess. 1 2 1 2 1 2 1 2 1 2. Let's say now you just need to click on add centroid. Okay, but yes, exactly the same thing. It would find the maximum distance. It would find the maximum distance and it would take that point. How? Now see, at this place, even if you want to find different clusters, you cannot do that. Our k-means problem is solved. Try that once again. Let's do restart. Farthest point, Gaussian mixture, add centroid. Randomly it would select add centroid, add centroid. Go. You would get the perfect clusters. Let's restart it. Farthest, Gaussian, add centroid, farthest, farthest. Now, every time you would get the best clusters when you do a smart initialization. Okay, so this is the k-means demo. Okay, now, so same thing, pandas, numpy, and now I'm going to need a matplotlib also. So import matplotlib.py plot as pl3. This also we are going to need today, and df equals to pd.read_csv, and we have taken here the income CSV. So let's see what we have for our CSV. A small data set just to explain you the thing. This is our CSV. This is our complete data frame. Only 21 rows we have, but this 21 rows would let you explain everything in k-means in 100% detailed manner. It would be really interesting. I'm going to show you the complete visualization and each and every part in detail. So now you don't need to code with me. You can code it later on. I will going to give you this book. Okay. So here we have name, age, and income of a person. Some age, some income, and it is exactly same like our data set, which is we have taken the bio marks and the maths marks. Like that, we have two columns, age and income. Let's name this properly, df.columns. And instead of this dollar and all that sign, I'm going to name it more properly. Just a second. df.columns equals to, and we are going to remove this thing from it. So now it's look beautiful. We got our data frame. We have age and income. You can do a scatter plot if you want to do it. I'm going to do the scatter plot for you. plt.scatter. Everyone pay attention. You don't need to code it right now. df.age, df.income. So you can see a clear scatter plot. This is how our data set look like. And pretty much it is clear that it would require 3 clusters. See that how simple the k-means clustering is. Just 1 and 2 lines of code. That's it. Now from sklearn, we are going to import this from sklearn.cluster import k-means algorithm. So we are going to import k-means. Now it's pretty much straightforward. We are going to do here k-means, and inside that we are going to write the number of clusters, how many clusters you want. You can start with 2 clusters, 3 clusters, 4 clusters. Let's start with 4 clusters. So n_cluster, you need to mention the number of clusters here. So k-means n_clusters equals to 4. Okay, now you would store that in km equals to k-means cluster. You can write it k-means like this, or to make it simple, we would just say k here for simplicity. 4 clusters we have chosen here. K-means is not defined. We need to take this exact k-means here, and we got the model fitted here. So basically we have created an instance of k-means here. Now what we need to do, see, ideal it should be 3 clusters, but we have taken here 4. Let's try to see what happens if we take 4 clusters. So we are going to just do here k.fit_predict. k.fit_predict. This is the function that we use here. You need to give the columns. So the name column is not important for us. We are going to remove this name column. Let's remove that here, df.drop, and I'm going to drop here the name, comma, axis equals to 1. comma in place equals to true. Okay, so we are dropping this now. We don't have this all the time, the name column. We have just this two. So we are going to predict here on the complete data frame that whatever we have, and we would store that in, let's say, y thread. So this is our y thread. See how interesting it is. Pay attention, everyone. We said 4 clusters and it gave us for every data point which cluster it belongs to. Like cluster 2, cluster 2, cluster 0, cluster 1, cluster 3, cluster 0, cluster 2, cluster 0. Yes. Let's see that visually. Now see, this visualization code may be a little bit difficult for you, but I'm going to make it simple for you. Now let's try to make this visualization which point belong to which cluster, because from here it is difficult. That first 2 points belongs to cluster, first 2 points belong to cluster 2, like that. So let's plot it. df.cluster. So we would create a new column here. Okay, we are creating a new column here, that is a cluster column. So df with the name CL, that is the clusters. df cluster equals to y underscore pred. Okay, so we have taken the y prediction in the df cluster. So you can see that this is our height looks like. So every cluster got which points it belongs to. Now we just need to put that into a simple scatter plot and our task would be done. So we would make for all of them different thing. So like for them, df0 equals to df of df dot cluster equals 0. Can anyone tell me what this line of code does? So basically the 0 means that, okay, what does the 0 means? The 0 means that this line, all the points that belong, no, this is not encoding, Shatrugana. The points that belongs to 0 cluster, for example, these 2 points, they would be grouped together. Okay, these 2 points which belong to second cluster, they would be grouped together. So I'm just checking a condition. If cluster is equals to 1, put that in df1. If cluster is equals to 2, put that in df2. Just see that I would run this 4 lines of code and see my df2. Only the points that belongs to second cluster are there here. Same way in df3, the points that belong to third cluster, that are only there. Now just let's plot this. So we are going to do here plt.scatterplot, and inside that we would just mention what we want to plot, df1. So basically our first 0 cluster, df.age. Okay, then comma df0. We are talking about only the 0 right now. Okay, so df0.income. Okay, and we are going to mention the color for them. Let's give them a color as yellow. The first cluster, we have a color that is equals to yellow. So let's see the scatter plot. You can see that the points that belongs to 0 cluster have been colored as yellow. df0. Now let me do it for all of them. So we would do it the same thing for df1, df2, df3. So this is now df1. This is df2. And this is df3. Okay, now everyone we would give them a different color. Let's say red. Then we are giving this as blue. And this is as green. So now we got all the points colored here very, very properly. Now this is how the clusters have been made. Very simple. This is our data set. And the clusters have been made very, very simply here. Okay, you can just do plt.plot legend. plt.legend. So you would see that which clusters belong to what. You need to give them the label as well. Then only you can see the. So you need to give them a label as cluster 1. Okay, forget about the legend. Legend is not important. You can see the color. So do you see that we are able to make the perfect clusters here? No, they are not the perfect cluster. See, perfect cluster would be This can be belonging to one cluster, this can be one, and this can be one. Right now, how the clusters are looking like? This is looking like as the one cluster. This is looking like as a second cluster. This is third, and this is fourth. And let's now make the same thing with three clusters. Now see, the same procedure I am repeating, but with three clusters. Let's see the magic of it. So here now I'm doing it instead of 4 clusters, I'm doing the 3 clusters here. Then the same procedure I'm going to repeat. The y predicted should be there in this clusters. That is the new column we would have is the new predicted with the 3 clusters. Okay. After that, we are going to do the same thing. Again, all the 4 data points here. But we would not have here 3 clusters, 4 clusters, we would only have 3 clusters now. And we would do exactly the same procedure once again of plotting it. But again, the 4th cluster is not there. Now see the magic. Can you see that it is little bit more good? Can you clearly see that now 3 clusters are only there? And when these 2 points were wrongly classified, now they are at least red.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, let's understand what is Silhouette method. It is exactly works in a similar way of elbow method, where you are going to find the good number of clusters. So let's see that what is Silhouette score. So the spelling of that is SILHOUETTE, Silhouette score. Now there is a very simple formula for Silhouette score, that is B minus A divided by max of A comma B. Let's try to understand what is this B minus A and what is this A and B. Let's understand that. First of all, let's understand what is A. So A is average inter-cluster distance, that is average distance between all clusters. Okay, what is A? A is average distance intra-cluster, that is average distance between each point within a cluster. Let me write that. Average distance in a cluster. Average distance within a cluster. Now, what does this mean? Let's try to understand that. And what is B? B is, this is called as intra. Understand the word intra. And then you have inter. Inter is basically average distance between clusters. Average distance between clusters. Let's understand what does this A and B means. It's very simple and very interesting. Now, let's assume that, let's understand this with a story. You have 2 clusters. Let's assume that in this cluster, you have all the people who are buying the clothes more than 10,000 rupees or around 10,000 rupees. And here you have people who buy in the range of 100 to 500 rupees, all the clothes. Now in this cluster, in 10,000 cluster, you have one person who is, okay, let's make it like this, just a second. One person is here of 10,000 and one person is there in 500. Now you make a cluster of both of them like this. Is this a good cluster? No. Let's understand why it is not a good cluster. Because people who are different, basically the distance between the 2 persons, this distance within a cluster, should be as less as possible. You should not happen that you make, so if you have a data set like this, you make a cluster which is something like this. Should you make like this a cluster? The cluster should be something like this, right? Yes. So understand here why this is a good cluster, because when you have 2 persons in the cluster, like this person and this person, and if you keep both of them in a one cluster, the distance between them should be as less as possible. The distance between them should be as less as possible. Now, that is called as That is called as how similar an object is there in the own cluster. That is called as cohesion. So this A is basically called as cohesion. This is the term for it. Cohesion. But Akash, how this is A is calculated? It's very simple. Pay attention. Very simple it is. So you have, let's say, a data set. Okay. And you have, let's say, points here like this. Now what you do, you calculate if you have two clusters. Let's assume that this is one cluster and this is another cluster. You take one cluster C1, you calculate the distance of this point with this, with this, with this, with this, and with this. You would have 5 distances. You would take average of all of them. Okay, same thing you would do for the second cluster also, C2 cluster also. So you would get average of each cluster. Now assume that if you make this as a big cluster, then the average would be higher or lower. Tell me. Once again, I'm framing a question. When you have C1, when you have a small cluster, the average distance would be, let's say, 10. When you increase the cluster, the average would increase or decrease. Very good. That should be lower. That's a perfect answer. This should be lower. Which means that, now understand it logically. Which means that when you make a cluster, it should be a compact cluster. Pay attention. When you make a cluster, it should be a compact cluster like this. You cannot make a cluster like this. So that's the reason A should be as lower as possible. The more the A is low, which means that you have a good cluster. Here we just calculate the average of distance. You take average distance D1 plus D2 plus D3, you divide it by 3. That is the average. The point should be closer, but again, there is a B here. Pay attention, what is B? B is when you make one cluster, okay, the distance of that cluster should be high with another cluster. So you cannot make a clusters that are very close. So for example, you cannot make a cluster like this. Either make it a very big cluster like this. So that is called as B. How is B calculated? It's again very simple. Let's understand that. You have some data points, let's say like this. You have data points here like this. Now what you do, you calculate, you take any one point from random. Let's assume that we take this point. We calculate the distance of this point with all other points. Now in different cluster. For A, it was intra-cluster. Intra means inside the self cluster. Inter means you have heard the term inter-school, which means that against second school, again different school. Interstate. Inter means that someone another. So with another cluster, you take all the distances D1, D2, D3. Same way you would calculate D4, D5, D6, D7. You would take average of this. One more cluster, let's say you have it. You would calculate the distance of this point with all the other points in the same way. You would calculate the average of this also. And out of this, which one is minimum? Okay, which one is minimum? You take that as your B point. To understand how well you have made the clusters, whether it is a good or a bad, you calculate these two values. It is very simple. A means that if you make a cluster, the point should be very close to each other. This is called as intra-cluster distance. Within a cluster, all the points are close to each other or not. B is inter-cluster. Inter-cluster means either you have made clusters which are very close or very far away. So B should be, tell me, B should be lower or higher? Very high. Why? Because if you make a B very small, which means that this distance is very small, this is B, which means that it is a wrong cluster. Your B should be as high as possible. Now let's understand this with the values. Let's put the values into the formula. That is B minus A divided by max of A comma B. Intercentroid distance. No. Again, it is not intercentroid distance. There is nothing concept of centroid here, Shubham. You take a random point from this any one cluster, calculate the distance, take the average. Same way you do for another cluster. A and B are two different clusters in one graph. No. Shatrugana, you got confused. A and B are two values that we calculated for every cluster. See, you would have this cluster, this cluster, this cluster. You would calculate the value of A for this and B for this. You would calculate A and B values for this. For every cluster, you would calculate A and B values. A value is calculated by taking the average within the points between the cluster, and B is calculated by taking away from the clusters. Sir, why B should be high? Okay, very good point, Arihant. We can have many B. No, Shubham, see, that's the reason I said you would take average of this, and then you would select the minimum average. So imagine that, Shubham, imagine that. And for you also, Arihant, imagine that you have clusters like this. Okay, now you make this as one cluster, this as another cluster, and let's assume you made this as a third cluster. So is this a good cluster, Arihant and Shubham? No, perfectly not. Why not? Because this cluster is very close to this cluster. So Arihant, basically B calculates this distance, that how your next cluster is close to you. If it is very close, which means that B is very low, because it is a distance between the cluster. So it is very low. If it is very low, which means that this is not a good cluster. So B should be high. And Shubham, we don't have multiple Bs. Out of this, you would get one B here, one B here. You would take the minimum B as your final B. So this is your final B. Now let's put the values into the formula and understand it perfectly clearly. Now let's assume that our B value is, let's assume that in this case, now tell me first of all, A should be lower or higher? Very good, it should be lower. And B should be higher. That's very good. Now let's assume that Hemant made a cluster and he did opposite. Hemant made a cluster and he did opposite. For example, he had data points like this. Okay, and what he did, he made a cluster 1 like this and cluster 2 like this. You can clearly understand that here A should be higher because of this and B should be lower because of this. Yes, the case is opposite in this. Yes, let's try to put the values. Let's assume that A is higher and A is 10. And B is lower, and let's consider the value for that is 1. So 1 minus 10, B value is, for this case, B let's say is 1 and A is your 10. Now we would take max of 1 comma 10. What is max of 1 comma 10? 10. So minus 9 by 10. What it is? Minus 0.9. Yes, this is the example for bad cluster. Let's assume that this time Hemant made a perfect cluster. Okay, he has a data set. And in this data set, he has the points which are very close and B is very far away. So the B is higher this time and A is lower. So same case get opposites. Your B value is higher. So let's assume it is 10. A value is lower, that is 1. Max of 10 comma 1 is 10. So it would be 9 by 10. It is 0.9. Yes, this is called as silhouette score. It is so simple as that. Silhouette score values are between -1 to +1. -1 means that you have made a very bad clusters. I have shown you the example for that. Minus 0.9 was the example for this. It is very close to 1. So it is a very bad cluster, and values which are close to 0.9 are considered like values close to 1 are considered as very good clusters. So this is the example for silhouette score. Now it's time to move to the next part of it. And let's try to understand how the thing works. Let me see if we can implement that quickly, or later on we would implement it. Let me see if we can do that right now. So this is how you got the fit product silhouette score. So like I said, silhouette score is always between -1 to 1. So we got very close to 1. That is your silhouette score. And what was the K value? K value for us was 3. You can see that it's a very good clusters basically. So that's the reason you are getting a good silhouette score. Let's try to make it bad. Let's try to make it bad and see how it performs our silhouette score, whether it goes down or not. So let's repeat this, but this time we would change the K value and make it look bad. Let's make it 2 now. So number of clusters, this time I would make it 2. Many things would change after this. Okay, this would change. We would have only 2 clusters. This would also go down. Okay, so now this is your 2 clusters. You can clearly see that. So here definitely your A has been increased because the distance in yellow points are very high. Okay, now SSD would remain the same. It would not change. Now see the silhouette score for it. You can see that silhouette score has went down. Makes sense? So we have covered everything in k-means clustering now. The silhouette score is a measure how similar an object is to own cluster compared to other clusters. So this is the complete example on k-means clustering. Let's try to now see hierarchical clustering. Before I move to hierarchical clustering, is everyone perfectly clear with this? On screen, let's start with a very interesting topic now. The next topic, hierarchical clustering. What is hierarchical clustering? Where it is used? Why should we use it? Let's understand each and every point in. Now we have completed k-means here. Let's understand hierarchical clustering. Now hierarchical clustering is little bit different. Okay, it is not used that much as we use k-means in industry, but it is still used. So I'm going to explain you the points here, how it works. So we would just understand the maths behind it, how it works, what is the principle behind it. So hierarchical clustering, the algorithm starts with all the data points assigned to one cluster on their own. Then the 2 nearest clusters are merged into one, and this process continues till only one single cluster is left. Now pay attention what happens here. Let's assume that we have this as a data set. Okay, you have this as a data set. Now what you do here, you start making first of all the clusters. The first step is every point is considered as own cluster, which means that if we have 10 points, this is one cluster, this is one itself cluster, second, third cluster, fourth, fifth, sixth, seventh, eighth. Every point is a cluster in their own. This is the first step. Now let's see the second step. Now in second step, you merge the clusters which are closer. So basically, what you do here, the points which are very close to each other, I would not say them the points, now they are clustered, you would merge them. So basically, these 2 points are close to each other, so I'm going to merge them together. This is now my new cluster. Again, I would merge the 2 points which are close. This is my another cluster. Now, see that this point is very close to this cluster. So again, I'm going to merge this. That is my next cluster. This again becomes a close point or clusters. Then this becomes a cluster in itself. And then finally, you have a very big cluster like this. Let's go it step by step so that you can understand it much better. We had one data point here somewhere. Let's draw that. Now, the first step in this you have is the points which are closer, you merge them like this. Now, the next step is you keep doing that. You keep doing this third step until you get all the clusters together. So this would be one cluster now. This would be another one cluster. Then this, and then complete all of them in one cluster. This is called as hierarchical. Clustering. Let's understand the maths behind it and let's understand how it works step by step. So in hierarchical clustering, there are two major things: algometric, agglometric, and divisive. These are the two main clustering techniques. Okay, let me write that so that you can understand this in a 100% detailed manner. These are the two techniques that are there in hierarchical clustering. One is your agglometric, AGGLO metric, MERATIV. Okay, and next one that you have is divisive. Now in industry and for the scope of your session, algometry we are going to learn in detail, because divisive is not used in industry. In a very rare scenarios they are used, because it is very much computationally expensive. You need to divide that into multiple. So what happens? Let's understand the difference first. What you do in agglometric clustering is exactly the process this I have explained you. This is called as agglomerative clustering. Now what is divisive? Divisive is totally opposite from this, which means that you say this all points. Okay, let's take this. You say this all points belong to one cluster first. You initially start with the opposite approach and you say that this all points belong to one cluster. Then you further divide the clusters into two like this, and then you further keep dividing the clustering like this. In divisive, you consider all points. The starting point is all points belong to one cluster. Now understand that the problem in this is you keep on dividing the cluster. What you do in divisive, you keep on dividing the clusters. Now this division of cluster needs to be calculated for each and every point. So for each and every point, we are not going into maths. I'm just explaining you the problem with this. For every point, you need to decide whether this point would be in this cluster C1 or it would be in C2. For this point also, you need to decide whether this would be in this cluster or C2 cluster. So for every point, you need to calculate, there is a maths, the sum of squared errors. Now that is totally different. We are not focusing on that. The major issue here is it is highly computationally expensive. That requires a lot of time, a lot of RAM to run this algorithm. So we don't use divisive a lot in industry. We use agglomerative clustering. Exactly same 2 points are written over here. Each observation start it as a own cluster. Each observation is a cluster, and then the pair of clusters are merged into one, and that moves up the hierarchy. So you keep on merging this two, then you keep merging on this two like this, and the hierarchy is made. All observations start in a one cluster. See, all observations are in one cluster, and you splits are performed recursively. You move down here. So here you break a big hierarchy into small cases. Here you start with small and you merge them into high hierarchy. This is a difference between agglomerative clustering and divisive. And then we are going to understand the mathematical problem of it. So now, guys, while I was explaining you this part, let's understand that. Let's make it a little bit bigger. Now here comes a very interesting thing. You have this data set. There is one big problem here. I am taking this as my one cluster. I am merging these 2 points and merging this 2 point. Can you decide this point belongs to this cluster or it belongs to this cluster? Can you make me understand that? Yeah. So basically, like you take in average, the similarity between first and 2 point, and then you sum all of them. So for example, in average, what you do, you take D1 plus you take D2 plus D3. In WOD, you take D1 square plus D2 square plus D3 square like this, and you divide by the number of points, whatever you have. Okay, whatever points you have, you divide with that. So basically the formula for WOD is written in the same way. You calculate the difference, the distance between the point in clusters. Like this is your I point, this is your I point, this is your J point. You calculate the distance. You take the square of that. Okay, you sum all the values and you divide it by the number of points in cluster 1 and in cluster 2. This is called as your WOD. Just simple, you take average square. So here I need to, what was my problem? Remember the core problem. What was it? I was not able to decide which distance I should select, D1 or D2. So let's say Ayush says me, take the complete linkage. So in complete linkage, you take the maximum value. So from this D1, D2, I took the maximum one. Let's assume that this distance, let's remove this distance is maximum. Okay. And from here also, I would calculate the distance of this point and this point. Which one is maximum? This one. So I would take this point, maximum. Now I have a clear choice. I have this distance D1. I have this distance D2. Which one is smaller? This one is smaller, D1. So this would be considered in this side cluster. Let's zoom in. Okay. Now see, it's very simple. What was our problem? Our problem is to find the distance between two clusters. Okay. If I want to merge these two clusters, I need to have a distance. Yes. Now which distance I should select? Should I select this distance? Should I select this distance? Should I select this distance? Which distance I should select? So what I do in single linkage, I calculate all the distances. Pay attention. With this point with this, with point this, with this point with this. Same with this point, this with this with this, and this with this. Whichever is the minimum distance, you take that as your point. So see, this is the minimum distance. So I'm going to consider this distance. In complete linkage, you just take the opposite. You take the maximum distance. See, same clusters, maximum distance. In average, what you do, you take average of all pairs. Basically, this with this with this, you take average. This with this, you take an average of this. That is your average linkage. In centroid, so centroid is not important. We don't consider centroid, but you take the centroid difference. Simple as that. And the last one is the WOD method. Now in WOD, what you do, the formula, understand that. You take the distance of every point, let's say D1. In average, what you do, you take D1 plus D2 plus D3 divided by 3. Yes. In WOD method, what you do, you take D1 square. Okay, you take D2 square plus D3 square divided by 3. That is the change in formula. While doing this, you also calculate the variance in your clusters. How spread the points are, that within the cluster, you calculate that also. So many times WOD methods is also used. These methods are just to select which distance we should consider. Let's try to solve a problem and you would understand that very perfectly. Okay, pay attention. Very, very easily you would understand that. We would take a small data set. Let's assume that we have 5 data points. 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. And now I have already for you calculated the distance. Let's assume that we have 5 data points, 1, 2, 3, 4, and 5. Now what I have done, I have already calculated the distance of 1 with 2, 1 with 3, 1 with 4, and 1 with 5. What is the distance? The distance from 1 to 1 is 0, 1 to 2 is 9, 1 to 3 is 3, 1 to 4 is 6, and 1 to 5 is 11. First step is clear that I got all this distance. I have been given with this data set. Okay, same I would calculate with 2. Now 2 distance with 1, we have already written that, so I would write here nothing. 2 distance with 2 is 0. 2 distance with 3 is 7, then 5, then 10. Same way for 3 distance with 3 is 0. 3 distance with 4 is 9. 3 distance with 5 is 2. 4 again. 4 distance with 5 is 8. And 5 distance with 5 is 0. So what we are going to do is 3 and 5 we are going to write in the starting here. 3, 5 here. Okay, let's write one little bit by space. I am just repeating the values here so that I can remove it from here. Okay, so now I have a space for 3, 5. This is one cluster for me. Then you have one cluster, second cluster, and the fourth cluster is this one. I would write here the fourth cluster. That is 650. I'm doing nothing. I'm just making it look better. Okay, I'm doing just nothing. So here also I would have 3, 5. Let's write it separately. Let's remove all this. So the first cluster that we have made is 3 and 5. So we are going to combine that here. 3, 5, 3, 5. Then remaining clusters 1, 2, and 4. 3 and 5, 1, 2, and 4. Now here comes the linkage logic. Pay attention. Up till now, we were calculating the distance of each point with each other. Now you have this cluster 3, 5. You want to calculate a distance of 3, 5 with this, 3, 5 with this, 3, 5 with this. Yes. So let's try to see how to get that. 3 and 5 with 3 and 5, it would be 0 always. Now 3 and 5 with 1. See, very interesting it is. So you have 3 and 5. Let's assume that. Let's remove all this. Let's assume that this is your 0.1, 0.2, 0.4. This is your 3. This is your 5. Now, which distance you would select? You would see the distance of 0.1 with 3. You would take the distance of 5 with 1. You would calculate both this distance. And this time I am taking here complete linkage. Okay, I am taking here complete linkage. Complete linkage means the value which is the highest. So let's see that. The distance between 1 and 3 is this one, that is 3. The distance between 1 and 5, okay, that is 11. Which one is higher? So here between 3 and 5, you would select the higher distance, that is 11. Super clear. Have you understood the complete linkage here? Now in single linkage, you would take the minimum, in average, you would take average, in odd, you would take odd. Okay, same way you would calculate the distance of 3, 5 with 2. Let's see that how it is 3, 5 with 2. So 3 distance with 2, 3 distance with 2, what it is? 3 distance with 2 is 7. 3 distance with 5, 3 distance with 5. Oh, sorry. 5 distance with 2 it should be. 5 distance with 2, what it is? 5 with 2 is 10. Which one is higher? 10. So again, we are going to take here 10 as a distance. Same with 3 and 5 with 4. So 3 with 4, what is 3 with 4? 3 with 4 is 9. And 5 with 4? 5 with 4 is 8. Now we are going to take 9. Yes. So we are going to take here 9. Now this distance are very clear from the above. One distance with one distance. So yeah, one distance with 1 is 0. Again, okay. Then one distance with 2, we would take that from the above thing. Only one distance with 2 is, okay, just a second. It is one distance with 2.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Yeah, that is 9. One distance with 2 is 9. Yes, this is 9. So exactly same from the above, we are going to take that one distance with 9. One distance with 2 is 9. Then here it is 6. Then here it would come as 0, 0, and 5. So you understand it step by step. Now what we have done, we have merged 3 and 5 and we have calculated the distance. What is the next step? Quickly. After doing this, what is the next step? We got this one cluster. Then new cluster. How we are going to find a new cluster? Minimum distance. So let's assume that these two are the minimum distance. Again, we are going to take, which one is the minimum distance here? Quickly. Understand 3, 5, and 2 means you are saying, yeah, I understand your point, Mahesh, no problem. This means that you are saying this point. No, 3, 5, and 2 means this. Is this correct? This is the minimum. At the same time, you are going to draw a dendrograms as well. Pay attention how to draw dendrograms. The first thing that you got is 2 here. Okay, so you would create a dendrogram for it. What is dendrogram? Pay attention. In dendrogram, you have on y-axis the distance. So distance is like 2, 4, 6, 8, 10. So this is the distance. On x-axis, you have your cluster points. On x-axis, you have cluster points like cluster point 1, comma, whatever your cluster points are. So let's assume that we have 1, 3, 5, 2, 4. Now, first we have merged which clusters? 5 and 3. What we have merged? We have merged 5 and 3. So you are going to draw at 3 and 5. You are going to merge them together at 2. Why 2? Because the distance between them is 2. This is the first step in dendrogram. Very good. Now we have merged here. See what we have merged. We have merged 2 and 4. So in the same way in dendrogram, pay attention. Let me copy this. We will move it down. I should make at 2 and 5. Yes, correct. And at the 5 place. See like this. Understand how I made this. 2 and 4. We are combining this. So at 2 and 4, I combined it. And what should be the height of it? 5. Why 5? Because here it is 5. The distance between them is 5. So let's remove everything because we need to write everything from once again. 2 and 4 are going to be merged. So 3, 5 would remain at their same place. We got a new thing here. Now 3, 5 would be here also. Then we got 2 and 4. So we would write here 2 and 4. Here also 2 and 4. Okay. And then at the last one. So 3, 5 with 3, 5 would be 0. Now, very interesting. How you are going to calculate a distance of 3, 5 with 2 and 4? You have two data points, 3, 5, 2, 4. How you are going to calculate that? Again, you would calculate a distance of 2 to 3. You would calculate a distance of 2 to 5. You would calculate a distance of 4 to 3. And you would calculate a distance of 4 to 5. Let's write that quickly. What are the distances? So we are going to write here 10. As simple as that. Now you would do the same thing, 3 and 5 with 1. We have already seen that. So that would come out to 11. You can try that later on. Then 0 here. Then again it would be 9 here. And then 1 and 1 is 0. So in this way, you would get all the values. Now, again, you would merge here the clusters. Tell me. Now, again, you are going to merge the clusters. Tell me which one is the smallest. 2, 4 is merging with 1 at 9. From 1 till 9, we are going to raise it. And we are going to connect that with 2 and 4. This is the next step in dendrogram. 2, 4, 1 is combined. And then now at the last, we are going to combine that with 3 and 5 as well. 1, 3, 5. Okay. Yeah. And now we are going to, at the last, when you solve this, you would also combine this 2, 4, 1 is combined into 1. Then this 2, 4, 1, you are going to combine with 3 and 5 as well. At whatever place it is, you are going to combine that. Okay, this complete process is called as dendrograms. And this is how you make clusters into one. So basically you cut these dendrograms and you get the number of clusters. You would understand that with a practical example as well. We would come on it. Let's understand what is this dendrogram. The height of a dendrogram at which two clusters represent the distance between two clusters in data space. The decision of number of clusters that can be best dissipate different groups can be made by observing dendrograms. The best choice of number of clusters is the number of vertical lines in dendrogram cut by the horizontal lines that can traverse the maximum distance without intersecting the clusters. Now let me show you that. We would see this example. Let me show you that how to decide where to cut that just by a practical example. Let's open one practical example. Just give me a second. We have a cricket data set for this. Let's try to take that data set. So this is our data set of cricket data set. Now let's have a look. Just 2 seconds. Have a look at this data set. What this data set is speaking about. Okay, you have a span here. You have the run rates. You have a player. Okay, now coming back to our part, we have this, we can use here Latin also. Just let me take that Latin one. Okay, no problem. So we have this data set. The shape of this data set is 79 players data we have and 13 rows, 13 columns we have, like span, number of matches, innings, number, runs, then different type of columns we have. Okay, now in this you can do all the basic things. You can check for null values. You have already know that. You can check df dot null values and all that things you can do. We can cluster here the group of all the players. Let's try to group based on how we can see if there is any group or not. So if there is null values or not, let's check that. Df dot is null dot sum. We have already seen this. So there is no null values in this. Okay, now the next step that we are going to do here is, first of all, to convert the span into years of experience, we first split the span into start and then end and store in new column. Now see, this span is not useful for us directly. If we convert that into number of years, you would understand that better. So first we will split the span on this dash. How to do that? Pay attention. There is a simple function for that. Df dot span, this is the column name, dot string, this is string, dot split, and in split you can mention dash, comma, expands equals to true. So what it will do, pay attention, it has created two columns for you, 1989 and 2012. So you can clearly see 1989 and 2012. So we have splitted this two columns, okay, so that we can calculate the years of experience that they have. So in our data set, now we have start and end, both of them, 1989 and 2012 is the end. So from this span, we have created it. Now, we would convert this start and end into integers because we want to calculate on them the values. So the start and end, we are going to convert that into as type dot as type. That is, we are making an integer conversion here. We are converting them to integers. So they would be now in integers 1989 and 2012. We want to calculate the experience. So what I'm going to do here is df of end minus df of start. Okay, now how much experience Sachin Tendulkar has? 2012, 1989. So that is around 1999, then 2009, 23 years of experience, something like that. Yes, exactly 23 you can see for Sachin Tendulkar. We would store that in a new column, that is df of experience. Now the moment we got the experience, now these columns are not useful for us, the span column, the start column and the end column. So let's remove that. So df dot drop, and inside that we are going to mention the column names, whatever we want to drop. That is the start column. Then we have span column and end column. Span and comma end. We know that we need to give axis equals to 1. So axis equals to 1. And we need to also give in place equals to 2. So now we have a clean data frame as we require. Okay, we have runs, inning, match, scores, everything we have in a proper place. Now, the next thing is that we are going to do, we can do all the EDA, like you can make the subplots and all that stuff, you can do it. We are not doing the EDA correlations and all that here. Again, if you want correlation, you can get that very easily. Let's import Seaborn, import Seaborn as SNS, and we are going to do here SNS dot heat map ndf dot core. So you would get a heat map of your correlations, how it look like. Okay, you can see that country column. Okay, now let's for now drop this player column also. Let's remove the player and see how it looks. So I'm going to df dot drop, and inside that I'm also dropping here player. Okay, let's keep the player also at some place in player column, so that if we want, we can use it in the later stage. So instead of drop, we are going to use pop. I hope everyone remembers what is the pop, and we are going to use here player. So now from our DF, the player has been gone. Okay, and in player we have the players, so that in future we can use that once again. So we have all the players also. Now you know that you need to rescale them because the values are very high here and very low values here. So we need to rescale them. Okay, so here is, so we are going to use here scaling. So same way, import sklearn, and from sklearn we are going to use preprocessing. From sklearn dot preprocessing import standard scalar. Okay, scalar. Now once we got the standard scalar, we are going to scale our data frame. So we would create an instance of it in scalar equals to this. We are going to fit the scalar SCA dot fit underscore transform. This already we have done it, so I'm not explaining that once again. And we are going to give our data frame, the new data frame to it, and df underscore scaled. Okay, now you would get df underscore scaled here, which is all in a proper manner. What error we are getting? Cannot convert the string to float. Yes, there may be some problem. Let me remove that. Just a second. We need to convert this into float. Yeah, let's convert that. Let's do that quickly. So we have this star. That's the reason it is facing an error. Let's replace this star and convert this. Okay, let me do that quickly before converting it. Okay, let's continue. So df equals to, we are going to remove the star from here. So df dot hs, okay, dot replace. Let's replace this star with, let's replace the star with the empty thing, and we are going to store that in hs. And let's print df dot head after this. Yeah, it has gone. So we need to do str, then only it would remove it. And then after that, we need to convert this hs again back to, okay, now I think it would work. Yes, it has worked, and you got all the scaled array. Okay, now the moment you got the scaled array, you can fit your clustering to it. The next step after getting this array is to create, just a second. Now, the moment, let me see if the values are matching as respected. Yes. Okay, now I need to create the columns once again for this, so that we can create a new data frame. This is an array. So I would use the old columns, df dot columns, whatever columns I had, this, all the columns I'm going to use it, and create a data frame of pd dot data frame. And inside that, I'm going to write this scaled array, that is df underscore scaled. Okay, and comma columns I'm going to take from the above, so that I would give the name as it is. So comma columns columns equals to the same thing we have taken from above. And the moment you do that, you would get a new data frame here, that is df1. Let's give it as df1 equals to this. Okay, we got a new data frame that is looking like this. Okay, we have experience here, we have number of runs, HS, everything is present to us in a perfect manner. Okay, now let's do the model building, how to make a model, how to make a dendrogram. Let's see that. It's very simple. Now for hierarchical clustering, you need to use scipy, scipy.cluster.hierarchy, hierarchy. This is the module name, hierarchy. From that, we need to import linkage. Linkage, what it is, I have already explained you. Like linkage, you need to also import the dendrogram. Dendrogram also I have explained you in detail. Dendrogram. Okay, you need to import these two things. Now see, the thing is very, very simple. You need to just use this linkage package. In this linkage, give your scaled data frame, that is this df1. whichever you have scaled right now, df1. Okay, then comma, you need to mention the method. By default, the method is what method? Okay, by default the method is single. You can change that linkage method. You can make it a complete linkage also. Let's make it complete linkage. And distance is always Euclidean. You can see that the distance is always Euclidean. It performs hierarchical algorithmic clustering. So the moment you do that, you would get a dendrogram. I would write here as merge equals to dendrogram. Okay. And now we are going to take here dendrogram. So dendrogram, we would take it from here, and inside that we need to give this merge. That's it. And you would get a dendrogram within a second drawn at your place. But this dendrogram is very short. Okay, this dendrogram is very short. Let's make it a big dendrogram so that you can understand it much better. So I'm going to just make it the figure size big here. You already know how to make a big figure size. So plt dot figure. Okay, and then you need to mention the fig size. And let's take it 20 cross 10. Okay, and plt dot show. PLT is not defined. Let's define PLT, import matplot lib.pyplot as PLT. Fig size is also not defined. Fig size equals to, it should be. Okay, now see, this is your good looking dendrogram. All the data points which are there, how many points were there? 37 were there. Whatever it was there, we have made a good looking dendrogram here.
Machine learning is the heart of artificial intelligence, and it consists of techniques that lay out the basic structure for constructing algorithms. These algorithms are used to build machine learning models that predict some outcome based on the input. So let's look at the first question. So the first question is, what are the types of machine learning? So there are three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. So let's see them in detail. So the first is supervised machine learning. In this type of machine learning technique, machine learns under the supervision of labeled data. There is a training data set on which the machine is trained, and it gives the output according to its training. So for example, if a patient is diagnosed for a disease of cancer, so the machine will predict the outcome based on the input or the symptoms as positive or negative. Now the next is unsupervised learning. Unlike supervised learning, it has unlabeled data. So there is no supervision under which it works on the data. Basically, unsupervised learning tries to identify the patterns in the data and make clusters of similar entities. After that, when a new input data is fed into the model, it does not identify the entity, rather it puts the entity in a cluster of similar objects. So you can see over here, the robot tries to identify the object and makes the clusters of similar objects, and whenever a new data is fed into the machine, it tries to identify it according to the cluster identified by it. Now the next is reinforcement learning. So reinforcement learning includes model that learn and traverse to find the best possible move. The algorithm for reinforcement learning are constructed in a way that they try to find the best possible suit of action on the basis of the reward and punishment theory. So you can see in the example, the agent tries to learn from the environment, observes the environment, select action using policy, and it gets a reward or penalty according to its suitable action. So whenever it gets the reward or penalty, it tries to learn the right suitable action according to the environment. Now let's see the next question. So differentiate between classification and regression in machine learning. So in machine learning, there are various types of prediction problems based on supervised and unsupervised learning. There are classification, regression, clustering, and association problems. So here we'll discuss about classification and regression. So in classification, we try to create a machine learning model that assists us in differentiating data into separate categories. So the data is labeled and categorized based on the input parameters. For example, imagine that if we want to make predictions on the churning out of customers for a particular product based on some data recorded. So either the customer will churn out or they'll not. So the labels for this would be yes and no. So this lies under classification problem. Now the next is regression. So it is the process of creating a model for distinguishing data into continuous real values instead of using classes or discrete values. It can also identify the distribution movement depending on the historical data. So it is used for predicting the occurrence of an event depending on the degree of association of variables. For example, the prediction of weather condition depends on factors such as temperature, air pressure, solar radiation, elevation of the area, and distance from the sea. So the relation between these factors assist us in predicting the weather condition. So this was about classification and regression. So the next question is, what is linear regression?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So linear regression is a supervised machine learning algorithm. It is used to find the linear relationship between the dependent and the independent variables for a predictive analysis. So you can see the equation over here, that is y equal to a plus bx, where x is the input or the independent variable, y is the output or the dependent variable, and a is the intercept and b is the coefficient of x. So let us see the graph for it. So this is the graph where it is having a best fit line that shows the data of weight, that is y or the dependent variable, and height, that is the independent variable, of 21 years old candidates scattered over the plot. So this straight line shows the best linear relationship that would help in predicting the weight of the candidates according to their height. So to this best fit line, we'll try to find the best values of A and B. And by adjusting the values of A and B, we try to reduce errors in the prediction of Y. So this is how linear regression helps in finding the linear relationship and predicting the output. Now let's head on to the next question. The question is, how will you determine the machine learning algorithm that is suitable for your problem? So for identifying the machine learning algorithm for our problem, we should follow these steps. So first is problem classification, second is checking the algorithm, and third is implementing the algorithm. So classification of the problem depends on the classification of input and output. So for classification of input, it depends on whether we have data labeled, that is supervised learning, or unlabeled, that is unsupervised learning, or whether we have to create a model that interacts with the environment and improves itself. For classifying the output, if we want the output of our model as a class, then we need to use some classification techniques. If it gives the output as a number, then we must use regression techniques. And if the output is a different cluster of inputs, then we should use clustering techniques. Now checking the algorithms in hand, after classifying the problem, we have to look for the available algorithms that can be deployed for solving the classified problems. Finally, we'll be implementing the algorithms. If there are multiple algorithms available, then we will implement each one of them one by one, and we'll check for the accuracy. And finally, we would select the algorithms that gives the best performance. Now the next question is, what are bias and variance? So bias is the difference between the average prediction of our model and the correct value. So if the bias value is high, then the prediction of the model is not accurate. Hence, the bias value should be as low as possible to make the desired prediction. And the variance is the number that gives the difference of prediction over a training set and the anticipated value of other training sets. So high variance may lead to large fluctuation in the output. Therefore, the model's output should have low variance. Let's see the diagram for it. You can see in the diagram, the desired result is the blue circle at the center. And if we get off from the blue section, then the prediction goes wrong. So the model should have low bias and low variance. And if the model is having low bias, high variance, then very few of the points are lying close to the desired result. And if the model is having high bias and high variance, then the points are not lying close to the desired result. So the model should have low bias and low variance. Now the next question is, what is variance inflation factor? So the VIF is the estimate of the volume of multicollinearity in a collection of many regression variables. So it is calculated as variance of the model divided by variance of the model with a single independent variable. So the VIF quantifies the extent of correlation between one predictor and the other predictor in a model. It is used for diagnosing collinearity and multicollinearity. So higher value signifies that it is difficult and impossible to access accurately the contribution of predictors to a model. Now let's head on to the next question. So we have to explain false negative, false positive, true negative, and true positive. So let's start with true positive. When the machine learning model correctly predicts the condition, it is said to have a true positive value. Then true negative, when the machine learning model correctly predicts the negative condition or class, it is said to have a true negative value. Next is false positive. So when the machine learning model incorrectly predicts a negative class or condition, it is said to have a false positive value. Finally, when the machine learning model incorrectly predicts a positive class or condition, it is said to have a false negative value. Let's understand this with the help of an example. So if an alarm goes on in case of a fire, it is true positive in the sense that there is a fire. That is, the fire is positive and the prediction made by the system is true. Next is, if the alarm goes on and there is no fire, then system predicted fire to be positive, but it made a wrong prediction, hence the prediction is false and the condition is false positive. Next is, if the alarm does not go on but there was a fire, system predicts fire to be negative, which was false since there was a fire. So it is a false negative condition. Finally, if the alarm does not go on and there was no fire, the fire is negative and this prediction was true. So the condition is true negative. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is used to explain a model's performance and gives the summary of the prediction on the classification problems. So it assists us in identifying the uncertainty between classes. So this is the formula for calculating the accuracy from a confusion matrix. So it consists of true positive, true negative, false positive, and false negative values. So the accuracy is calculated as the sum of the true positive and true negative values divided by all the outcomes. So the accuracy is calculated as the sum of true positive and true negative values divided by true positive, true negative, false positive, and false negative. For example, consider this confusion matrix and it consists of values as true positive, true negative, false positive, and false negative for a classification model. Now the accuracy of the model can be calculated as below. So it is the sum of true positive and true negative value divided by the sum of true positive, false negative, true negative, and false positive values. So the accuracy comes to be 0.78. So the accuracy of the model is 78%. Now let's head on to the next question. So what do we understand by type 1 and type 2 error? So type 1 error is also called as false positive, and it is an error where the outcome of a test shows the non-acceptance of a true condition. For example, a cricket match is going on, and when a batsman is not out and the umpire declares that he is out, this is a false positive condition. So here the test does not accept the true condition that the batsman is not out. Now type 2 error. So type 2 error is also called as false negative, and it is an error where the outcome of a test shows the acceptance of a false condition. For example, the CT scan of a person shows that he is not having a disease, but in reality he is having it. Here the test accepts the false condition that the person is not having the disease. So when should you use classification over regression? So both classification and regression are associated with prediction. So classification involves the identification of values that lie in a specific group, whereas the regression method entails a predicting a response from a consecutive set of outcomes. So the classification method is chosen over regression when the output of the model needs to yield the belongingness of the data points in a dataset to a particular category. For example, we have some names of bikes and cars. We would not be interested in finding how these names are correlated to bikes and cars. We would check whether each name belongs to the bike category or the car category. So that is why we use classification over regression. Now let's head on to the next question. So we have to explain logistic regression. So logistic regression is the proper regression analysis used when the dependent variable is categorical. Like all the regression analysis, logistic regression is a technique for predictive analysis. It gives the output as binary. So logistic regression is used to explain the data and the relationship between one dependent binary variable and the one or more independent variables. Also, it is employed to predict the probability of a categorical dependent variable. For example, if we have to predict whether a citizen is a senior or not, so the output will be in 0 or 1. So there are three types of logistic regression, that is binary logistic regression. So in this, there are only two outcomes possible. For example, to predict whether it will rain or not, it will give the values as 1 or 0. The next is multinomial logistic regression. So in this type of regression, the output consists of three or more unordered categories. For example, prediction on the regional languages like Marathi, Telugu. The next is ordinal logistic regression. So in ordinal logistic regression, the output consists of three or more ordered categories. So rating an Android application from 1 to 5 star, it comes in ordinal logistic regression. Now the next question is, imagine you are given a data set consisting of variables having more than 30% missing values. Let's say out of 50 variables, 8 variables have missing values which is higher than 30%. So how will you deal with them? So to deal with the missing values, we need to first identify the values, and for that we'll specify a different class for the missing values. After that, we'll check the distribution of values over the data set, and we would hold those missing values that are defining a pattern. Finally, we'll change these into yet another class while eliminating the others with the help of eliminating functions available in Python or R. Now, the next question is, how do we handle the missing or corrupted data in a data set? So in Python, there are two methods that are very useful. So we can use these two methods to locate the lost or corrupted data and discard those values. So the first is isNull method. So we can detect the missing values using isNull method. And after that, we can use drop NA for removing the columns and rows with null values. Also, we can use fill NA to fill the void values with a placeholder value. Now, let's head on to the next question. So we have to explain principal component analysis. Firstly, this is one of the most important machine learning interview question. So in the real world, we deal with multi-dimensional data. Thus, the data visualization and computation becomes more challenging with the increase in dimensions. So in such a scenario, we might have to reduce the dimension to analyze and visualize the data easily. So we do this by removing the irrelevant dimensions, keeping only the most relevant dimensions. So this is where we use principal component analysis. So finding a fresh collection of uncorrelated dimensions and ranking them on the basis of variance are the goals of PCA. So here is the mechanism of PCA. So we have to compute the covariance matrix for data objects. Then we have to compute the eigenvectors and eigenvalues in a descending order. Next is to get the new dimensions and select the initial n eigenvectors. Finally, we'll change the initial n-dimensional data objects onto n dimensions. So here is an example for it. Here, the two graphs shows the data points and the two directions. One is green and the other is yellow. So we got the graph 2 by rotating the graph 1 so that the x-axis and y-axis represent the green and the yellow directions. So after the rotation of the data points, we can infer that the green direction gives us the line that best fits the data points. So here we are representing two-dimensional data, but in real life, the data would be multi-dimensional and complex. So after recognizing the importance of each direction, we can reduce the area of dimensional analysis by cutting off the less significant directions. Now we'll look into another important machine learning interview question. So why rotation is required in PCA? So what will happen if you don't rotate the components? So rotation is a significant step in PCA as it maximizes the separation between the variance obtained by the components. Due to this, the interpretation of the components become easier. So the motive behind doing PCA is to choose fewer components that can explain the greatest variance in a dataset. So when rotation is performed, the original coordinates of the points gets changed. So there is no change in the relative position of the components. So if the components are not rotated, then we need more extended components to describe the variance. Then the visualization and prediction becomes more difficult. So you can see over this graph, the data points, these blue dots represents the data points. And if we rotate the axis to these dimensions, then all the points will lie in this x-axis. So the previous one is x-axis and the new dimension is x-axis where all the data points lies. Now let's head on to the next question. So we know that one hot encoding increases the dimensionality of a dataset, but label encoding doesn't. So how? So when we use one hot encoding, there is an increase in the dimensionality of a dataset. So the reason for the increase in dimensionality is that for every class in the categorical variable, it forms a different variable. Suppose there is a variable called color. It has three sub-levels as yellow, purple, and orange. You can see over here. So one hot encoding color will create three different variable as color.yellow, color.purple, and color.orange. Now in label hot encoding, the subclasses of the certain variables get the values as 0 and 1. So we use label encoding only for binary variables. So this is the reason that one hot encoding increases the dimensionality of data and label encoding doesn't. So you can see over here that in this label encoding, the categorical variables or categorical values are given to the name of the food, and in one hot encoding, the 0 and 1 values are given, and the separate variables will be created for it. So it increases the complexity of the data. Now let's head on to the next question. How can you avoid overfitting? So overfitting happens when a machine has an inadequate data set and it tries to learn from it. So overfitting is inversely proportional to the amount of data. So for small database, we can bypass overfitting by the cross-validation method. So in this approach, we'll divide the dataset into two sections. So these two sections will comprise testing and training sets. So to train the model, we'll use the training dataset, and for testing the model, for new inputs, we'll use the testing dataset. This is how we can avoid overfitting. Now let's head on to the next question. Why do we need a validation set and a test set? So this question is similar to the previous one. So we split the data into three different categories while creating a model. The first is training set, the second is validation data set, and the third is testing data set. So let's see training data set. So we use the training set for building the model and adjusting the model's variables. But we cannot rely on the correctness of the model built on top of the training set. The model might give incorrect output on feeding new data. So we use validation set. So we use a validation set to look into the model's response on top of the sample that doesn't exist in the training data set. Then we will tune hyperparameters on the basis of the estimated benchmark of the validation data. When we are evaluating the model's response using the validation set, we are indirectly training the model with the validation set. So this may lead to the overfitting of the model to the specific data. So this model won't be strong enough to give the desired response to the real world data. So for this, we use the test dataset. The test dataset is the subset of the actual dataset, which is not yet used to train the model. So the model is unaware of this dataset. By using the test dataset, we can compute the response of the created model on hidden data. So we evaluate the model's performance on the basis of test dataset. So we do not always expose the model to test dataset after tuning the hyperparameters on top of the validation set. As we know, the evaluation of the model on the basis of the validation set would not be enough. Thus, we use a test set for computing the efficiency of the model. Now, let's head on to the next question. So what is a decision tree? So a decision tree is used to explain the sequence of action that must be performed to get the desired output. So it is a hierarchical diagram that shows the actions. So you can see the diagram over here. So we can create an algorithm for a decision tree on the basis of the hierarchy of actions that we have set. So over here, you can see we are checking whether a person is fit or not. So the parameters are, the first one is, we'll check whether the person's age is greater than or less than 30. So if it is yes, then we check for eats a lot of pizzas. So if this condition is true, then the person is unfit. And similarly for this, if the person is greater than 30, it checks for exercises in the morning. And if it is yes, the person is fit. So this is the working mechanism of a decision tree. So let's head on to the next question. So we have to explain the difference between KNN and K-means clustering. So K nearest neighbor or KNN, it is a supervised machine learning algorithm. And in KNN, we give the identified or labeled data to the model. Then the model matches the points based on the distance from the closest point. So you can see over here, these are the matched points according to the centers. And for K-means clustering, it is an unsupervised machine learning algorithm. So in this, we give the unidentified or unlabeled data to the model. Then the algorithm tries to create the batches of points based on the average of the distances between the distinct points. So you can see over here, these clusters are formed. So this is the difference between KNN and K-means clustering. Now the next question is, what is dimensionality reduction? So in the real world, we build machine learning models on top of features and parameters. So these features can be multidimensional and large in number. Sometimes the features may be irrelevant and it becomes a difficult task to visualize them. So here we use the dimensionality reduction to cut down the irrelevant and redundant features with the help of principal variables. So these principal variables are the subgroup of the parent variable and it conserves the feature of the parent variable. Now let's move on to the next question. Both being tree-based algorithms, how is random forest different from gradient boosting algorithm? So the main difference between a random forest and GBM is the use of techniques. They both use different techniques for implementing. So random forest advances prediction using a technique called bagging, and GBM uses boosting to advance the predictions. So let's check each one of them. So in bagging, we apply arbitrary sampling and we divide the data set into n samples. After that, we build the model by employing a single training algorithm. Further, we combine the final predictions by pooling. So bagging helps to increase the efficiency of the model by decreasing the variance for overfitting. Now let's see boosting. So in boosting, the algorithm try to review and correct the inadmissible predictions at the initial iteration. After that, the algorithm's sequence of iteration for correction continues until we get the desired prediction. So boosting assists in reducing bias and variance both for making the weak learners as strong learners. Now let's move on to the next question. Suppose you found that your model is suffering from high variance. So which algorithm do you think you could handle this situation and why? So for handling the issues of high variance, we should use bagging algorithm. So what it does is it splits the data into subgroups with replicated sampling of random data. And when the data is splitted into subgroups, we create rules using particular training algorithms. And finally, we use pooling for combining the predictions of the model. So you can see the diagram. The data is divided into subgroups as bootstrap 1, 2 till n, and the models are created as model 1, 2 according to the training algorithms, and finally they vote for the final prediction. Now the next question is, what is ROC curve and what does it represent? So ROC stands for receiver operating characteristic. So we use ROC curve to represent the trade-off between true and false positive rates. So in ROC, the area under curve gives us an idea about the accuracy of the model. So you can see the graph. So this graph shows an ROC curve. So the greater the area under the curve, better the performance of the model. So let's move on to the next question. So what is rescaling of data and how is it done? So in real world scenarios, the attributes present in the data will be in a varying pattern. So rescaling of the characteristic to a common scale gives benefit to algorithms to process the data efficiently. For example, if a student is gaining marks out of 100 as 60 in subject 1, out of 150, 120 in subject 2, and 180 out of 200 in subject 3. So after rescaling, the marks will be out of 10. So in subject 1, he'll get 6 out of 10. In subject 2, he'll get 8 out of 10. And in subject 3, he'll get 9 out of 10. So this is how rescaling gives us the benefit to rescale the data in a common scale. Now let's move on to the next question. So what is binarizing of data? So in most of the machine learning interviews, so this question is asked. So I'll give you an example. So first of all, converting data into binary values on the basis of threshold values is known as the binarizing of data. So the values that are less than the threshold are set to 0 and the values that are greater than the threshold are set to 1. So this process is useful when we have to perform feature engineering, and we can also use it for adding unique features. So here, if a student A in subject 1 gets 60 out of 100, in subject 2 he gets 20 out of 100, and in subject 3 he gets 70 out of 100. So if the threshold is set to 40, So if the marks are greater than 40, then the student is passed, or if it is less than 40, then the student is failed. So after binarizing, we'll get the output as 1 and 0, from which we can decide whether the student is failed or not. Now let's move on to the next question. So how to standardize data? So standardization is the method that is used for rescaling data attributes. And the attributes would likely to have a value of mean as 0 and the value of standard deviation as 1. So the main objective of standardization is to prompt the mean and standard deviation for the attributes. So we'll implement standardization using Python. So let's move on to our Jupyter notebook. So this is our Python code for standardization. So we have imported the NumPy library and matplotlib.pyplot and pandas. So we'll be using the pre-processing in Python. So we'll be importing it from sklearn package. So basically pre-processing is used. It is a package that provides several common utility functions and transformer classes to change raw feature vectors into a representation, and that will be more suitable for downstream estimators. So in general, learning algorithm benefit from the standardization of the data set. So this is the use of pre-processing. Then we'll load the data set. So I have loaded the data set using pd.readcsv. After that, we'll have a look at the original data. So the original data is over here. So it denotes the scientific values. So we have to do min-max scaling, or it is called rescaling of the data. So for this, we'll use min-max scaler. So we'll be storing it in min underscore max underscore scaler. So pre-processing dot min-max scaler, and the range of the feature will be from 0 to 1. So values will be stuffed in between 0 and 1. After that, we'll use this fit underscore transform to fit the value of the data and transform it into a format. So let's have a look at the values after min-max scaling. So you can see the values are between 0 and 1. So these are rescaled. Now we'll look at standardization. So we'll use standardization, and we'll use this object of standardization and store this standard scaler in it so that we can use it afterward in standardization. After that, for scaled feature, we'll use this object as x underscore after standardization to store the values that are standardized. So after printing the values after standardization, the output would look like this. So the negative values are the values that are less than mean, and the values which are positive are greater than the mean. Now let's move on to the next question. So executing a binary classification tree algorithm is a simple task, but how does a tree splitting takes place? How does tree determine which variable to break at the root node and which at its child nodes? So Gini index and node entropy assist the binary classification tree to take decisions. So basically the tree algorithm determines the feasible feature that is used to distribute the data into the most genuine child nodes. And according to Gini index, if we arbitrarily pick a pair of objects from a group, then they should be of identical class and the possibility for this event should be 1. So to compute the Gini index, we should do the following. So we should compute the Gini for subnodes with the formula as the sum of the square of the probability for the success and failure. So that is p square plus q square. Then we have to compute Gini for split by weighted Gini rate of every node of the split. Now we'll see entropy. So entropy is the degree of indency that is given by the following. So this is the formula for entropy, where A and B are the possibilities of success and failure of the node. So when entropy is equal to 0, the node is homogeneous. And when the entropy is high, both groups are present at 50-50% in the node. Finally, to determine the suitability of the node as the root node, the entropy should be very low. Now let's move on to the next question. So what is support vector machines? So support vector machine is a machine learning algorithm that is majorly used for classification. So it is used on top of the high dimensionality of the characteristic vector. So we'll implement SVM using Python. So let's move on to our Jupyter notebook. So I've written this code. So first we'll import datasets from the sklearn package, then confusion matrix, as we will be calculating the accuracy of the model, and train test split from sklearn dot model selection, because we'll be splitting the dataset into train and test set. So we'll use the iris dataset for this. So I'll load the dataset and I'll store it in iris.data and iris.target. Then we'll be splitting the dataset into train and test set. So we have separated the data into data and target and stored it in A and B. So we'll be creating separate test and train dataset for it. So we'll be using train test split function for this, and we'll give the argument as A, B, and random state will be 0. After that, we'll import SVC from sklearn.svm to implement the model. So we'll build the SVM linear model by using the SVC function and store it in svm underscore model underscore linear, where kernel will be linear and will give the data as train dataset. After that, we'll predict the model's outcome using the predict function and give the argument as test. Finally, to calculate the accuracy, we'll be using the score function. So we'll be using this svm model linear dot score and give the argument as a underscore test and b underscore test. So after that, we'll get the confusion matrix. So we'll be using the confusion matrix function. So this will be our output. So this is our output that we get. And using this confusion matrix, we can calculate the accuracy of the model. Now, let's move on to the last question of this machine learning interview questions tutorial. So we have to implement KNN classification algorithm. So the problem statement is classify the iris flower based on sepal and petal length and widths using KNN. So we already know that it is a supervised machine learning algorithm, and in it we give the identified or labeled data to the models, and then the model matches the points based on the distance from the closest point. So let's move on to our Jupyter notebook for implementing this. So this is our code for implementing the KNN classification algorithm. So we'll load the iris dataset from sklearn.datasets. Then we'll be importing k neighbors classifier, which will help us in implementing the KNN classification algorithm. We'll import numpy and then train test split, so that we can split the dataset into train and test dataset. Then we'll load the iris dataset and store it in iris underscore dataset. After that, we'll be splitting the dataset into train and test using the function of train underscore test underscore split. After that, we'll use k neighbors classifier and we'll store it in kn object. Then we'll fit the model on top of training dataset, that is a underscore train and b underscore train. After that, we'll be creating a new array and store the values of the characteristics of the flower in a underscore new. Then for predicting, we'll use this predict function to predict the outcome using the a underscore new dataset. After that, we'll be printing the predicted target value, predicted feature name, and the test score, which will give us the accuracy of the model. So the model has predicted that the feature name is Satosa and the test score is 0.97. That means the accuracy of the model is 97%.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.